Hey guys, I welcome you all to the live session on AWS Full Course by Intellipaat. This session is conducted by multiple experts who will be teaching you all about AWS from basic to advanced level. This session is specially for those who wants to learn AWS from scratch and make a career in it. So, before we begin the session, make sure to hit the subscribe button and also hit on the bell icon so that you will never miss an update from us. Firstly, we will begin with Introduction to Cloud Computing. In that, we will explain you what is cloud computing, why do we need that, and also tell you cloud infrastructure. Then after that, we will be learning about physical server, availability, and local zones. Then we'll move on to AWS Elastic Beanstalk. Then later on, we will be learning about private, public, and hybrid clouds. After that, we will introduce you to virtualization and AWS, followed by AWS services and global infrastructure. Then later on, we will be learning about AWS EC2, EIP, VPC, and AWS Pricing. Once we finish with all the basic concepts, we will be learning about AWS Code Commit, Code Deploy, and Code Pipeline. Then finally, we have covered how to become a cloud engineer and followed by AWS interview questions and answers. So guys, this is the agenda of the video. Without any further delay, let's get started.
What is cloud computing? We'll go ahead and understand that aspect. See, you must have by now, all of you, I know it's COVID season, so probably you never took your Ola or Uber cabs, but you have in the past, right? So you have taken Ola or Uber to go from place A to place B because it's very convenient. You pick up your car, you pay for whatever distance you travel based on the type of car that you have purchased. You've taken the service, you go ahead and pay. So same, same kind of a model is what cloud computing also provides. Here, cloud refers to the internet and computing refers to getting access to all IT resources over the internet. That's the short form of cloud computing. Now, before we delve deep into cloud computing, just so that people here, I'm sure most of you, more than 60% of you, are already aware of cloud computing. You're already working in your organization. But more than 40% here are pretty new to cloud computing. We have absolutely no idea. Okay. So for such people, we are going to go ahead and take a look at the very basics. Okay. How do I get access to your compute resources over the internet? So here I have my laptop. I have access to, any of my website. So this is the website I go to, aws.amazon.com. This is just to go ahead and show you how easy it is to go ahead and get myself, say for example, a server. So I come here, I have already created what's called as an AWS account. I've already created one, so I'm going to use that AWS account to log in. This is pretty much like, you go to Amazon, you'll sign in with your account like that. In cloud computing, you have your email address. With this email address, like this, you log into AWS. AWS stands for Amazon Web Services. Okay. So you log in here. So you change, these are the various places in the world where they have what's called as compute resources. Okay. So we'll talk more about this infrastructure. So I'm currently wanting to say, I don't want Oregon, I want to go to North Virginia. I choose my region. I decide where I want my server, for example. Okay. After I do that, I go to services. Now, if you see here, these are all the IT services anybody in this world can get access to, and they pay for however long they're going to use. This is cloud computing. Over the internet, I get access to compute resources, meaning servers, okay, in short, or storage devices, or databases, or if you want to migrate anything, you have migration services, or if you want to create your own network, you have networking services. Then you have a lot of tools which developers would want to use. Talk about anything, be it your security services or big data analysis or what is this, machine learning. You have a plethora of services. Over 200 plus services are there just for you to go ahead and use it. Just for simplicity's sake, I'm going to show you. Let's time it. It is what, 8:14 p.m. This is called as, this is how you get virtual computers. EC2 stands for Elastic Compute Cloud. Okay, so you would find this terminology being used in this particular course almost always. Okay, elastic means it is very flexible. You want a server today, you don't want a server tomorrow, or in another half a minute, you don't want this server. You can go ahead and, just like a toy, you can buy it, you can go ahead and throw it away. That's how it works. Now take a look. I don't want to waste time here. So 8, because we're on the timer, right? We'll start the timer now. 8:15 p.m. We want to get started by creating a server. Take a look at how easy and simple it is. In a few clicks, whatever type of server you want, whatever operating system you feel like for today, you can go ahead and choose the operating system and get started. Okay, so say for example, I want a Linux server. I choose something like this. Okay, and I can launch it. We'll talk more about all this, but I'm just showing you how easy it is and simple it is. If you know the basics, which you will know, okay, you would understand that we have launched a server in less than a minute. It is getting started, it's getting created. This simple it is. Okay, but did you notice that in less than 2 minutes, I have a server which is already running? Cool, isn't it? Not just a server. You can go ahead and get yourself anything in IT that you feel like. If you just search, if you know what kind of service is available, you can go ahead and get it for yourself. So who is a AWS architect? Now, AWS architect is the person who goes ahead and, speaks to the customer and understands the customer's requirement, understands the business model of the customer, identifies what the customer can use or buy from AWS. Generally, customers have their own what's called as data center, and they would want to go ahead and migrate to cloud because of this flexibility that you see. Now, if you notice, I got myself a server. I didn't have to think too much. Less than 2 minutes, I could open up my server, bring my server up. If I feel like, I can just go ahead and say, okay, I'm done playing with this. I'm done doing my testing or whatever. So I don't want the server anymore. I can terminate it. Once I terminate, I don't have to pay a single penny for this. Okay. Now, this is the beauty of cloud computing. It goes ahead and allows you to get IT resources as and when you require. You can do the testing. If you like it, you can keep it. If you don't like it, you can always go ahead and modify it or terminate it. So nobody's going to question you about why you terminated immediately. No, you're going to be charged per second or per minute basis, depending on what you have made a choice for. Very clearly, there is written documents which mention very clearly how much you have to pay for this service, and depending on how you have configured, these are all called as features. Okay, so yeah, we'll be looking at all this in detail. You will notice these are all various features. These are all various ways of purchasing what's called as elastic compute cloud. Okay, virtual machines or virtual servers. These are all various options that you have. Extra storage space for your server, extra security options for your server. And then I changed my location. I said, I want my server in North Virginia. I could have selected my server from any other place in the world. Now, what are these places? Let's have an understanding about that. Okay. See, when I say you're getting virtualized resources, IT resources over the internet, AWS goes ahead and keeps what's called as data centers across the globe. That's called as AWS Global Infrastructure. I want you to take a look at this so that you have an appreciation as to the kind of effort AWS has put to make sure its service is always available. Okay, so look at the picture here. I'll give this link to you. You can bookmark all these pages, okay? But this is already available for you in your course material also. In this PPT, you will have information about that. But I just find it useful to go ahead and give you links, just additional one. That's the link of this page. Now take a look. See, over across the entire globe, whatever lines that you see, these are all called as fiber optic cables that are laid. Now, if you wonder what are they connecting, what is it that is available here, you would find that initially when AWS started, they went ahead and um, built data centers not for AWS. AWS was not even there. They built what's called as these data centers to go ahead and make sure their website, Amazon.com, was available for their customers. Okay. So if you know, back in 2000, this website called Amazon.com, for people who have not seen this website, well, I'm sure none of you have seen this website because it's so popular. But yeah, this website was becoming popular, very popular in 2000, the year 2000. Now, its popularity was very good for Jeff Bezos, but in another way, Jeff Bezos' team, the IT team, found it extremely challenging to go ahead and keep up with the kind of volume of people who were wanting to access this website. Now, in order to make sure that this website was always up and running and always answering to customers' queries whenever they click any item, because this is a website where now everybody purchases everything in the world. Okay. So, to make this possible, the backend IT team was building what's called as the data centers. Now, this is how the data centers would look like. Where are the data centers? You would find big buildings where you would find a lot of servers and storage devices and networking devices. All this was originally built in North Virginia for AWS's parent company, Amazon.com. Okay. Now, with Amazon.com becoming very popular, they had to go ahead and solve a lot of issues which many customers back then were facing in the IT world itself. So you all know when we had to go ahead and build our servers, we had to buy these big boxes. And this is how a server looks like, by the way, for people who have no idea of what a server looks like. Nowadays, we have to write physical server, otherwise, even Google doesn't know. So this is how a physical server would look like. These are called rack servers. So this is how a server would look like. Yeah, that's probably one of our IT engineers there. So this is how servers would look like. Okay, we had to procure this hardware, and then we had to go ahead and get the operating system CD and install the CD, get the license for that operating system, and then if everything works fine, which takes a couple of hours, then we had to get the software applications, install the software, buy the license for the software, and all that. So pretty much to bring anything, that server that I brought up in 2 minutes, if I were in 2000, year 2000, 20 plus years ago, it would have taken me easily half a day to 1 day to go ahead and build that kind of an infrastructure. So doing that for a development environment or a testing environment might take half a day, but to bring it into production might go ahead and take a couple of months because it needs a lot of approval. You need to do a lot of testing and approval and all that stuff. And the amount of mistakes that we could do when you procure hardware like this, which was very costly back then, and even now it is costly, not that it is cheap, you know the chances of you making a lot of errors, were very, very less. Okay. Now, thanks to the hard work that the team who built Amazon.com did with cloud computing, just like nowadays you can rent a cottage or rent a car, you can come here just because they have made everything available to us. What they've done is with cloud computing, they have made all the infrastructure that they have built, all these data centers that they have built across all these regions, they have made it available on rent. So as and when you need, from whichever region you want, this is called as a region. North Virginia is a region. So in this region, for example, this is a region which is that North Virginia is where they started. So you would see North Virginia, AWS started in 2006. Okay, so in 2006, AWS began its services for the world. That is 6 years after Amazon had everything sorted out. Well, now North Virginia's website is, sorry, data centers are up for you know, the people to go ahead and rent out. They have what's called as 6 availability zones. Now, see, availability zone is slightly different from data center. They are the same, but let me just tell you what it is. Do you see these blue dots? 1, 2, 3, 4, 5, 6 dots. Those are called availability zones. Now, if you take a look at availability zone itself, availability zone, those blue zones that you see, is a collection of a couple of data centers. So you would find inside an availability zone, you would find these physical buildings which have, I'll show you that because it's available. AWS data center. This is how the data centers of AWS look like. Okay, so you would find that in the same availability zone, because see, you cannot go ahead and build a concrete structure however big you want. There is a limit to that also, because inside a data center you'll have to have you keep racks, and these racks contain servers, storage devices, networking devices, routers, switches, gateways. Talk about everything, it's all there. Okay, so all of them need to be cabled, all of them need to be kept in a right temperature, humidity level, and all that stuff. So all you see this one here, these are all the AC ducts. Okay, so there is a limit to the floor space also. Therefore, a couple of data centers will be there, physically separated data centers. When I say physically separated, assume there is a compound of building and then there are 2 or 3 data centers like that. So if I have to draw it for you, so let's say this is an availability zone, short form AZ. So if this is the North Virginia, okay, so let's assume there are 6 availability zones. So there are 6 availability zones inside North Virginia region. Okay, North Virginia is a big region. So one of the availability zone, how will it look like? It will have one data center here, another data center here, third data center here. All of them are connected to one another like that. Okay, like this, each data center is connected to one another. Okay, so all of them are connected to one another using this fiber optic cables. Similarly, if you take a look at the globe, every data center is connected to one another as shown in this picture, and all availability zones are connected to one another, and they are also connected to other regions. So in the cloud, this is where actual physical servers are present. So on top of this physical servers is where we go ahead and install what's called as virtualization softwares. We call them as hypervisors. And that's on top of that is where you build your servers or your databases. Or other than this, other than these availability zones and data centers which are connected to one another, you have something called as these local zones. Now, local zone is slightly different. So see, local zone is there to go ahead and ensure that there is a single data center there, just to make sure that there is no what do you say, you cannot expect to keep your servers in a local zone and expect high availability to be in place. No, unlike normal availability zones, which come with a couple of data centers which are connected to one another, local zones are present in some remote regions where you cannot actually go ahead and closer to that particular region's proximity. You see that, certain cities, for example, I think Osaka has, or no, Osaka now has data centers by itself. Earlier, it used to have a local zone. So these local zones are there, where you have a smaller data center where it has same servers, storage devices, networking devices, and all that stuff. But they are not like your normal data center. You should not keep resources in a local zone and expect to have real high availability in place. This is there just to go ahead and keep it near the customer's place, where there's a lot of IT, population who are using their particular region. So this is something new that has come, local zones. And there is also something called as points of presence. Points of presence is important for you to understand. See, across the globe, now, for example, right now stay in India. Okay, I stay in Mumbai. So let me show you my place. Come on, see here. This is India here. Now, this is Mumbai. In Mumbai, if you notice, there are three availability zones. The blue dots that are there are three availability zones. So inside one availability zone, there could be multiple data centers. Okay. Now, at least two data centers will be there in any given availability zone. Remember that much. At least two data centers will be there in an availability zone. Now, this particular, say for example, see in Mumbai itself, Mumbai is a small town. I mean, is a good city only. But then there are regions within India. India is a very big country. So if you notice, say for example, this is the easternmost part of India. Okay, so there you cannot build a data center because it's pretty costly to build data centers. Okay, procuring the land, there's a lot of capital investment involved. So building data centers is not possible. Building smaller computer rooms, always possible. Okay, so that smaller computer rooms that they've built across, say this is Delhi, this is what, Calcutta maybe, and other regions here. So across India, they have built smaller points of presence, which is also called as content distribution network, CDN. We also give it another name called as cloud front. So your points of presence are also called as edge servers, edge locations. These are different names given. Points of presence, edge locations, edge cache servers, content distribution network, cloud front. These are all various names that are given to smaller computer rooms, which will always cache the information which you're always looking for from the nearest available data center and give it to you. Okay, this is for content distribution. You have your points of presence, or your POP as we call it. Okay, so I was talking about this global infrastructure, right? So you have regions, availability zones, some local zones also, which is nearer to the customers who generally use compute, or IT industries are more there. And then you have local points of presence, which are nearer to customers. Say, for example, in South America, only in Sao Paulo you have data centers. Only in Sao Paulo you have availability zones. But across South America, you would find that there are smaller, what do you call, points of presence or content distribution networks, CDNs, called points of presence, this pink one. Okay, that's present. All of them are connected to one another. This is called as cloud front. So anybody, for example, who is sitting somewhere here, wants to access AWS, they go to aws.amazon.com, they would find absolutely no kind of a delay as long as their internet connection is fine. The speed at which they get connected will be all the same. And you would find that they log into this, not this. This, yeah, aws.amazon.com. They log in with their ID. Once they get connected, everything else will be the same. Even though somebody sitting here might not really go ahead and access the data center in Sao Paulo directly, they do get access to the website very fast because there is this points of presence here, content distribution network here, which enables caching, which enables the kind of what do you say, the response that AWS gives to its customers is seamless. It doesn't really matter where in the world you are, as long as you have internet connection, you get access to the the cloud infrastructure. Okay. So in addition to that, there are other stuff also which is present here. You might want to go ahead and know about ground station and all. Is not really necessary for you. If you really want to use satellite communication for your own application, you have ground stations. And this is your network, which entire globe is connected with fiber channel. And this is a private network which AWS uses. It's called as the private link. Okay, this is the physical infrastructure laying fiber channel cables over the Pacific and across the entire globe. That's a challenge in itself, but that's how internet works. Let's see, take a look at the advantages of cloud computing one by one. Okay, what were the advantages? Now see, before cloud computing, let's take a look at Amazon's case itself. That Amazon.com, if they had to go ahead and create a server, I'm talking about before cloud computing came into being, it would take, just like we used to go ahead and do this in our regular day-to-day activities back then in our backup and storage administration days. If we had to go ahead and build a server, first of all, availability of that physical server is a big question mark. And if we got one, to get the operating system CD, that's another task. To get the license for that operating system, hopefully it'll be written on the on the CD. That was again we used to keep the fingers crossed. If let's assume I got everything in place, then installing it was another nightmare, because every operating system has its own special set of requirements to understand how to install, how to configure. Let's assume I did that also. Then to get all the software that was necessary to install the software application and configuring it and bringing it into production, trust me, it would take minimum a week, a maximum 3 months, if at all it was to be made available in the to the regular production environment, to get all the approvals and all that stuff. Now that was before cloud computing. Now with cloud computing, whether I want a compute resource, okay, meaning a server, virtual server, for example, or if I want a storage, or if I want to build myself a database which is managed by AWS, or if I want to migrate my existing servers to the cloud or vice versa, or if I want to create my own network, which is, very safe in the cloud, if I want to create my own DNS setup, if I want to go ahead and accelerate the speed at which my client reaches my network, I could do all that. And I could use developer tools, robotics, security, talk about big data analysis, uh, any people from AI, machine learning, AI, mobile, IoT. So every one of you who is here, whether you're here for learning cloud, learning architecting, or if you're a developer, you should understand that every one of this is there. If you know how to use it, it takes just a few minutes. So for example, if I have to build a server, I would come here, click on this EC2, magically in less than 2 minutes. Let's take it as a challenge. So this is 828, and I'm going to bring myself a server. Linux, any operating system you want. Red Hat, SUSE, Ubuntu, Windows, whatever you want, you choose. Okay. So magically, I choose all this, go ahead and give another, outside the server, I keep a security guard that is called as the firewall here. Okay. So I go ahead and choose one of the firewalls. This is North Virginia, yes. Review, launch. I will talk about this keypads and all that stuff. I'll acknowledge that I have it. So if I am an authorized user using various layers of security, we'll go ahead and get ourselves a server. Did you notice that less than 1 minute, I have my Linux server. It is already going ahead and setting itself up. In some time, when give it some time. See, even when you go ahead and update your operating system and start your laptop, it's going to take some time. Like that, right now my virtual machine is getting created. Okay, in less than 2 minutes, you would find that this server is going to be up and running. See, it already has its IP address set up. It already knows where exactly, in which data center it's present. It has everything up and running in less than 2 minutes. Okay, so like this, if I am a website developer, I could go, this one that I showed you was called as infrastructure as a service. That's a virtual server on cloud. A virtual server is an infrastructure. So this is called as infrastructure as a service. Okay, so I could launch it in 2 minutes. Now let's see, magically, though I'm not a developer, I'll go ahead and create a website. And I'll do that in record time. Okay, thanks to this service called Elastic Beanstalk.
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which one of the following cloud concepts is related to sharing and pooling the resources? A. Polymorphism. B. Virtualization. C. Abstraction. D. None of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Which is a platform as a service. Let's assume I'm a website developer. Okay, so, and I don't want to bother about creating that server and installing it and configuring it, and I don't want to do all that. I want a ready-made server on which I already have the platform on which I want to go ahead and code. Let's assume I'm a PHP developer. So I'm going to go ahead and develop a PHP app using this platform as a service. Okay, so how am I going to do? I'm going to go ahead and do something like this. I'll create one name tag just to go ahead and show you that this server was created using platform as a service. Okay, so I come here as a developer. I say, okay, today Java doesn't seem like a good one. .NET, Node.js, Python, everybody is using. I want to be different. So let's say I choose to use PHP. Okay, so I come here. I say I want PHP. My cloud service provider will create this platform called PHP on Linux for me. Okay, he'll give me a couple of choices. These are the only choices. So I choose the platform, and then I could configure more options. I could go ahead and set up a database in the back, or go ahead and have some load balancers, send some notification, extra security, more software, everything. If I want, I can configure. Okay, put it in a network and all that stuff, and then I can go ahead and create this app just like that. Okay, so now in the background, it is going ahead and creating. See, this is platform as a service where AWS, the service provider, is creating the environment for me. All I had to do was upload the code. Okay, that uploading code part I guess I did not go ahead and show you. I chose a sample application there. You could have gone ahead and uploaded your own code from your desktop or laptop. That during the Elastic Beanstalk class we will see. Okay, so this is a classic example of platform as a service where I am sitting here relaxed talking to you. This is my AWS service provider doing all the hard work of creating a storage called S3, creating a firewall, configuring the proper firewall settings, giving an IP address for my website. Okay, and in some time you will notice that my website will be created because I already uploaded the code, the software code. Okay, I probably did not show you that part of how to create that particular upload the software code. I will show it to you in a minute. So take a look. All this hard work AWS team is doing for us. It's all automated for us. This is platform as a service. Okay. So infrastructure as a service, you saw a server that came up in 2 minutes. That is EC2, Elastic Compute Cloud. Elastic Beanstalk is an example of what's called as a platform as a service. You choose the platform. I chose PHP platform. You could have chosen .NET or Java or Python or Go or whatever fancy languages you developers would use. Okay, choose that. Write your code, upload the code. As a developer, do your job. Your job is to write the code. Write the code, check if it is working. So as a developer, you are not going ahead and you don't have to go ahead and think and assume that if I write this code, probably I'll get this output. If you want to check, upload the code and see. The environment gets created for you. The infrastructure gets created for you like this. And then you can check if your code output is as you wanted it or not. If you feel it's not right, remove the code, put back another code and check. That's the beauty of cloud computing. Okay. So see, that's why I wanted you to see all this, because this is all happening in the background. You got an IP address, it launched an EC2 instance on your behalf, and then it went ahead and did a couple of things. So once you've played with anything and everything on AWS, just to go ahead and show you that it actually created a server in the background. Let me show you. EC2 is your virtual server. Okay. See, remember I came here and created only one server, but there are two servers running. How? Because using that platform as a service, there was one more server which got created. This was created by the AWS team using that software or that service called as Elastic Beanstalk. Okay, so this was the web server which got created. This is the server I created. So I could choose to create an infrastructure like this. I'll name it and call it infrastructure as a service demo. Okay, and this one was a platform as a service demo. Okay, so using PaaS we created, right? So this was the platform as a service demo. So like this, you could use many of these services. By the end of this course, you will love that there are so many stuff that's available here which you could use, not just the compute but the rest of the services as well. Where is the infrastructure question? So for that, we'll take a look at most of what we're going to be taking a look at. What is public, private, hybrid cloud? How's Google and Gmail, Microsoft Azure, how are they compared to AWS? All that you'll find the answer in one single link. That link is called your AWS Global Infrastructure. This one magical link will go ahead and give you an answer to all that question. It's very important to understand. So there you go. If you just scroll down here, there is a lot written there, but I want to take you to a movie. So I'm going to click on this beautiful animation here. This is your AWS infrastructure. So Jeff Bezos has been doing a phenomenal job of creating a lot of data centers across the globe. Okay, so he started here in North Virginia. In North Virginia in 2006, if you go there close, he built what's called as data centers within North Virginia. So started in 2006. There are 6 availability zones. We have to learn a couple of terms, especially in AWS. Okay, so what do you mean by availability zone? Availability zone doesn't mean one data center. No, availability zone, which is shown as blue here, if I click here, you would see that availability zone has a couple of data centers in the same location. So if I click on data center, if you see, this is the actual data centers. Okay, Now, data center is a physical location where you keep all your servers and switches and storage devices. But you can't go ahead and have it in one physical building, okay, because there's a capacity limit. And here Jeff Bezos is catering to the entire world, okay? So we are billions of people. Therefore, in one availability zone, he will have, or AWS has, a couple of such buildings, probably all of them sharing the same parking lot. Okay, so one availability zone actually contains couple of data centers, at least two or more than two data centers might be there in every availability zone. All of them have, redundant backup, redundant power supply, redundant everything. So that's why you should know that when I'm saying availability zone, I'm talking about physically separated couple of buildings in the same radius. Okay, they're all having their own infrastructure, not dependent on one another. And if something fails, there's one more building for high availability sake. So that is an availability zone. Did you understand the term availability zone? How is it different from the term data center? So if you're building a company, because you're not as rich as Jeff Bezos is, I know that. Okay, I'm sure you're going to become one. But until then, if you are going to go ahead and start a company, you will probably build a small computer room or one data center maximum, because that itself will cost a lot of money. That's called capital expenditure. Now you can save all that money. If you're starting a company today, do not go ahead and invest in a data center, because take a look. If you go ahead and take a look at the cloud service, in which region you want. Let's assume you start a business in, say, North Virginia. Your business is doing very well. You want to go ahead and, set up somewhere in Brazil or Sao Paulo or California or Ohio, or you want to go to Spain, you feel like going to Middle East, Bahrain, or you want to come to our place. Welcome to Mumbai. Okay, so anywhere in the globe, without thinking, giving it a second thought, wherever you want, your IT resources could be launched, because in every region refers to the location. Okay, so this is called as a region. Mumbai is a region, Hyderabad is a region. Like that, across the globe, Bahrain is a region. In every region, you will have at least two availability zones. Every availability zone will have at least minimum more than one data center. Okay, and all of them are connected to one another. All the data centers are in production. Okay, every data center is connected to each other. These small white dots that you see, they are actual fiber optic cables which are laid to connect the entire global infrastructure which is in place. Okay, so in addition to all this availability zones, you would find that there are something called as local zones which are built. You would not use local zones for production and all. You will use local zones when you don't require non-critical data. You just want to go ahead and do some testing or something like that, and you don't mind losing that information. Then you can put it in a local zone. Local zone might not have redundancy in place. Okay, it's not unlike availability zone which has redundancy of data centers and storage devices and everything. Local zones are just nearer to your location where you might want to use computational power. Okay, so that's local zones. In addition to that, to make sure that, see, globally AWS customers are in billions now. All of them are across the globe. Okay, some of them are not present in the main cities. Many of them are present in the tier 2 cities or in villages, okay, in remote towns. But everybody has access to the internet, thankfully. All right. So for such clients, what AWS has done is they've said, just because you're in a remote ranch, for example, and you have internet connection, doesn't mean that you have to go ahead and to reach to AWS website or to reach to the data centers of AWS. You don't have to go ahead and wait. The latency to reach AWS resources on the cloud has been reduced thanks to what's called as your content delivery network, which is called as CDN. Do you see here? I'm trying to go ahead and expand. It's not expanding. So it's called CDN, Content Delivery Network, also known as Cloud Front. It's also known by other names, edge location, regional edge location, or points of presence. So these are smaller computer rooms which can be easily built. At least for AWS, it is very easy. So they have built smaller computer rooms across the globe. Many are there, just to make sure that they are closer to their customers. Okay, that way, when a customer tries to reach, the latency, time taken to reach their servers is less. Obviously, to use these points of presence exclusively for various production purposes, you need to pay a little bit extra, but it's worth the money. Okay, so that's your points of presence. Let me see. So what do we have? What have we learned? We have learned that there are over 24 regions as we speak right now across the globe. Region means location. So currently, when I launched these two servers, um, I launched it in North Virginia. In that North Virginia region, in one of the many data centers, you know, it's called as availability zone. We don't call specific data centers. We mention only the availability zone. So this availability zone is called US East 1E. That is where my server was launched. Okay, so like that.
Just a quick info, guys. Intellipaat provides online AWS certification training in partnership with Future Skills, mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
You choose which region, wherever you want, you can go ahead and launch your server. Okay, so there are over how many? 24 regions. So in 24 regions, 77 availability zones are there. In addition to that, 5 local zones are also there, which I told you there's no redundancy of data center. One data center might be there. Okay, so if that goes, that's it. So there's no redundancy of data centers in local zones. So in addition to that, they've come up with something called as the wavelength zone, which came very recently. When I say recently, in the last 1 or 2 years is when wavelength zone came up. You all probably must have heard about something called as 5G. At least in US, Verizon probably did a lot of what do you say, advertisement, and they're already providing 5G services. So if you're already a person who's using 5G, you know that AWS and Verizon are partners now, and to go ahead and support 5G network, they go ahead and they have something called as the wavelength zone. So earlier days, we didn't have data centers or wavelength zones in New York, for example, or New Jersey. Okay, so now we have wavelength zones in such places as well. So there are 12 wavelength zones across the globe, okay, in various regions wherever 5G is supported. So like that, there are there are 220 edge locations or edge cache locations across the globe. They are still continuing to build that network. So if you see the globe here, so these blue ones are the already existing data centers or regions. Okay, so this is where they started in 2006. There are 6 availability zones only in North Virginia. And in addition to that, they have 3 local zones also and 6 wavelength zones. North Virginia is their favorite. That's where they get started. So anything new they want to test, they'll test it in North Virginia. Okay. So like that, you would find there are various data centers. So near North Virginia, in a different region, it's called as US Government Cloud. Now, I need you to pay attention here. This US Government Cloud, general public like you and me will not get access unless and until you belong to the US government and have the necessary user IDs and authentication and all that stuff. You won't even get access to it. Okay. Can't even see it in the management console. These are private clouds. The one that we are seeing right now, the ones in Canada, the ones in North Virginia, the ones in Ohio, the ones in Oregon, North California, or Sao Paulo, or anything else that you see here, These are all available to the general public. Okay, that's called public cloud. Except for this US government in the West Coast has 3 availability zones that's not accessible by the general public. It's private. Similarly, in the East Coast, US government cloud, private cloud. Okay, and the Chinese also, they are very special. They don't want access. They want no general public to access it, so it's private. Okay, so that's private. Beijing is also private, so you cannot get access to these. That's why if you see here in the regions, can you see Beijing or US government or the whatever was the other one in China? You can't see because those are not available to you and me. It's not available to the public. Those are private clouds. Okay, I hope you have that clear distinction between what is available to the general public cloud, and what is private cloud. Okay, yeah, wavelength zone is only for 5G support. Okay, right. What else? We wanted to go back here. Okay, here only, right. Yes, what are the orange ones? The orange ones are the newer availability zones or regions with multiple availability zones that are currently being built. By the end of this class, I'm sure that they're going to go ahead and make some of these oranges will become blue. That's when you will find that, they'll update this particular this particular page. They will change the number of regions that are available. These numbers will always change. Okay, so don't have to sit and by heart all these numbers. Nobody's going to question you that way. So this is where you find the details of actually where the data centers of AWS are present. Okay, so having understood this, let's get back to comparing ourselves with Microsoft and Google. Okay, so see here, there is this company called as Gartner. Gartner goes ahead and publishes what's called as a magic quadrant for various companies in various fields. All right. So in cloud infrastructure as a service, for the last 10 years, for the last decade, they have marked AWS as the market leader. How have they marked them? They are not going ahead and getting anything from AWS for doing that. No, they are completely transparent. They do it for various companies in various fields. Okay, so based on a company's ability to execute and completeness of vision in that specific specialized area, in this case infrastructure as a service, they have identified certain companies and marked them as niche players and market leaders or visionaries and what's that, challengers. Okay, so Amazon's web service has been the market leader in platform and infrastructure as a service for the last 10 years continuously. So that talks volumes about their capability of providing the service that they are providing. Okay, so I don't want to go ahead and tell anything about Microsoft and Google. They're also doing very well. They're also market leaders, but they are placed wherever they are placed right now. Okay, so good to have some competition. It's all right, because that's how the customer is always in a benefit when you have multiple players in the market. Okay, so that's all I want to go ahead and tell about Microsoft and Google. You be the judge. Okay, moving on. So we've talked about the global infrastructure. We've talked about what is a public cloud, what's a private cloud. We've compared the, Amazon and Microsoft and Google. What else did we want to do? Yes, I wanted to talk more about your IaaS, PaaS, and SaaS. We will do that now. Okay. Right. Thank you, Ankit. Now let's talk about IaaS, PaaS, and SaaS. I've already shown you a demo of IaaS and PaaS. Now it'll be fun to go ahead and see how much you've understood. Okay. See, now I want you to pay attention. Public cloud means these service providers cater to the general public's requirement. They have rented their services to the general public. That's why you can hire or rent their resources. Just like you will rent a car, you can rent a server, or you can rent a any service of AWS or Microsoft or Google or IBM Bluemix, from them you can go ahead and get it. It's available for the general public because they have such wide data centers or such big infrastructure that they can rent it out to the world, general public. Okay, so these AWS is a public cloud service provider. Now HP, for example, okay, or Dell EMC, for example, they do have data centers, but they cannot afford to go ahead and rent it out to the world because they don't have such humongous infrastructure. Okay, so what this Dell EMC or HP has done is they rent out their data centers to some corporates as big as them or smaller than them. So to their friends in the corporate world, if you are another company, you want to go ahead and rent out or get your service, get your own set of data centers from private cloud service providers, they will go ahead and rent. Who? HP or Dell EMC will rent. Okay. Now, if you want to become a private client to AWS, as I told you, you have to be either US government or Chinese government. That big. If you don't give them that volume, they don't even consider you to become a private cloud. They won't build a separate region for you. Okay. So AWS is a hybrid cloud service provider because they do have private customers who are very, very high net worth customers. So therefore, AWS can be classified as a hybrid cloud service provider. This is one way where the service provider, like AWS is a cloud service provider. He can be classified as a hybrid cloud service provider also. There's one more term which companies or people, when you and me talk, we use in terms of customer, from the customer's point of view. For example, if I as a customer has a on-premise data center, I have a small server room or a big data center in my own location. I've been using it for some time. Before cloud itself, I had it. I don't want to throw it away because I already have paid a lot of money to buy the data center. I've bought the data center, for example. I have hired only the internet service. Other than that, the storage devices, servers, operating system, the license cost, everything I've already have. Okay, so I as a customer already have an on-premise data center. I want to keep this, but for my additional requirement, I want to use the EC2s and the Elastic Beanstalks and all that stuff. Google Docs, I want to use all of that. So if I'm having an on-premise data center, in addition to that, if I'm also using cloud service, and if all of them are talking to one another and using it, we are a one big family like that. That is also called as a hybrid cloud, but this time hybrid cloud refers to, from the customer's point of view, wherein all his IT resources are present based on that. So two different ways of classification, one from the service provider's point of view, another from the customer's point of view. I hope that part is clear. So depending on what your meeting is, you have to understand what they are talking when they say my customer is using hybrid cloud. That means your customer actually has some servers on premise in his own data center and some across the cloud, some from Google, some from Microsoft, some from AWS, like that. So that is one way of taking it. Okay. Okay. Now let's talk about infrastructure as a service, platform, and software as a service. Talking about infrastructure as a service, um, as you see, on premise, all that is in blue is owned by the server owner. I mean, owned by the customer. Okay. All this data center, the customer paid using his money. He, did capital investment, bought the data center, or he's paying a rent for that. Storage devices are not very cheap, they are costly. He bought that. Server, he bought it. Virtualization software license, operating system license, database license cost, firewalls, and lot of other things with reference to security. He bought it. Software applications, he bought it. He's paying the license, upgrade of the license, upgrade of servers, He has to go ahead and maintain the power supply, keep it turned on 24/7, have redundancy of power supply in place, and then he has to cool these devices. Just like I'm turning on my AC now, he has to turn on the AC and keep at a optimal temperature and humidity level for all these infrastructure that he has. That will cost him a lot of money. Okay. Now, if the customer believes that, and after seeing our demo, and when you try to go ahead and sell this infrastructure as a service, you're telling the customer, you know what, if you're a new person, you're starting the company now, don't build a data center. AWS already has a data center, not one, across the globe. So many are there. The infrastructure, the network also is provided, because you saw the fiber optic cables that are there, which is connecting the entire globe. Okay. The storage devices, servers, virtualization, software license, everything is given to you. That is infrastructure as a service. When I chose EC2, what did I say? First thing I selected was the operating system. That's all I chose. From there on, I have to pay. Until here, I don't have to pay a single penny, because this capital investment I am not doing. Already the service provider has done it for me. Okay. So depending on what operating system I chose a Linux operating system, remember? So this Linux operating system that I chose, for how many ever minutes it ran, for actually this is Linux. Okay, so if it's a Linux, we charge you on a per second basis. So depending on, I think I terminated it after 5 minutes or 10 minutes. So for how many ever minutes I had this turned on, only for that amount of time, I'll have to make a payment based on the operating system I selected, based on the region where I have selected, based on the type of instance I have selected. I have to go ahead and make a payment. And the pricing and all is very transparent here.
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which one of the following is cloud platform by Amazon? A. Azure, B. AWS, C. Cloudera, D. All the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
We will see in detail about the pricing for every single service. That is during the EC2 class we will take a look at. But everything is properly documented. Pricing for every resource is mentioned here. What is free? As a free tier user, in the first 1 hour, our friend explained to you that for the next 1 year, from the time you created this AWS free tier account, you're going to get, almost most of the services that you have to practice are going to be free for you. That way you're able to learn. Okay. So we will take a look at every single service and what is eligible for free tier, but during the class, not now. So that's your infrastructure as a service. OS onwards, inside that OS, whatever you want to do, it's your choice. You want to install a database, you want to install a game, you want to do whatever, that server is yours. It's your playground. Okay, that's infrastructure as a service. Now in platform as a service, you saw, did you not say, I didn't have to go ahead and choose or install the operating system also. It created the operating system. If I had wanted, it would do the database creation. It would have updated the security. It did, right? It created a firewall and it gave me the network setting, everything, secure IP, everything it did. I had to choose that PHP application, that's all. Once I chose the platform, which is PHP, I went about doing my business of uploading my code. In my case, I didn't even do that. I chose a sample application and a website just popped up. Okay, that's pretty cool. But if I'm a developer, whatever code I want, I can type it or upload the file in that specific language or the platform I chose, and I can upload it. Okay. Today, our aim is to ensure that you understand what is infrastructure as a service, what is platform as a service, the difference between them. And needless to say about software as a service. Software as a service, you and me have been using it for the last decade or so, more than that. Right? Google Drive, Google Docs. Have you ever, honestly tell me, have you ever bothered to figure out where that hard drive, where your Google Drive is? Have you ever bothered to figure out what application this Google Documents is using? Who cares? As long as the URL is working and it's shared and you can access, right? Advantages are you do not have to build data centers or buy servers or do anything. Okay, in a click of button, you saw in less than 1 or 2 minutes I could build myself server. I've launched my own website thanks to the cloud services. So whatever I used, as soon as I used, I had the discipline of going ahead and terminating. It is like this. You go ahead and rent a car. Let's assume you want to go from New York to New Jersey. Okay, you're renting a car. Would you just go ahead and rent a car, land in the house and not pay the bill? The car will wait for you. So however long the car waits, you have to pay a waiting charge. You are smart, so you won't do that. You will go ahead and say, I don't need this car anymore. You will pay the bill. Okay, as soon as you've reached your destination. Like that. In your cloud, all you have to do is once you've used it, terminate it, make it a habit. If you don't do that, eventually you'll find yourself paying AWS unnecessarily because you might unknowingly, there is something called free tier account that you will all be creating. Okay, hopefully that part was taught.
Virtualization, the base of cloud computing. What is the base of cloud computing? So in order to understand cloud computing, you must understand the data center virtualization, which is the base of your cloud computing. And data center virtualization encompasses a wide rate of tools, processes, and technologies, which is enabled data centers to provide the services using virtualization. But what is the virtualization? What is the virtualization? Virtualization, I'm just writing here virtualization. Virtualization. So virtualization.
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which one of the following cloud concepts is related to sharing and pooling the resources? A. Polymorphism. B. Virtualization. C. Abstraction. D. None of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Kind of a technology over data center, which makes it possible to manage multiple servers, applications, hardware resources at the same time. And it all possible with the help of the software called hypervisor. I'll give you one example. Let's say hardware, or not say hardware, infra is better. Infra without virtualization. Okay, so this is the one thing. Let's say you have a machine, you have a server. This is your bare metal server. This is your bare metal server, and you install this server in your company's data center, right? This is a physical server, and this physical server can have multiple Ethernet links, and this is a switch, and here you have a storage. Okay, this is called storage, and this is a switch, right? And you are connected with the switch. This may be a L2 switch, and this is your server. And at the top of the server, what you install? You install operating system. You install operating system. Let's say you are using your very popular Windows 2016 server. Okay, so this server, maybe you're running some applications on the top of this. So you have a number of applications running on the top of this. There's the application 1 and application 2. These are applications. I think you do like this, applications. And the major part of this scenario, why I'm just discussing all these scenarios. Let's say this machine has a hardware configuration. This machine has, let's say, 16 core CPU, which is very nominal. It's not a great thing. So 16 core means it's a very generic kind of server, and 64 GB RAM. So this is. But on the top of this, what you're getting only one server. You're getting only one server. So with this Windows 2016 server is consumed, it is covering the entire resource. And on the top of this, you have a couple of applications running on this. So if you see the performance of this machine, the performance is almost 20%, 10% to 20%. The rest resources are not being used. So no application in one go can use your 16 cores, and one or two application using this Windows 2016 server are not sufficient to use your 16 GB RAM. So whatever the resources you have, you are basically not using those underlying resources. So you have a great wastage here. So let me take this now, infrastructure with virtualization. Now, infrastructure with virtualization. Yeah. Now what you will do? Let's say this is a blade server, right? And let's say the configuration was 16 core and 64 GB RAM. Will it be okay? And this was the CPU. Now we have one software, is called hypervisor. This is a hypervisor. What is a hypervisor? I tell you. What is a hypervisor? Hypervisor is a kind of a software you directly install on bare metal. We have two different kind of hypervisor, but hypervisor allows you to share hardware of host machines like your CPU, memory, network interface, and other hardware resources. Hypervisor are mainly categorized into two ways. So no, sir, this is not a developer class. This is an AWS Solution Architect class. So you will install a hypervisor here. So this hypervisor, we have a type 1 hypervisor. If you have a type 1 hypervisor, this type of hypervisor can be directly installed on the hardware. So this is the hardware. This is your hardware, right? You can directly install on this hardware. And we have a number of options here for hypervisor. We have ESXi. ESXi is a hypervisor. Second, you can use Zen hypervisor. Zen. We have Microsoft. What is the name of Microsoft? Hypervisor of Microsoft. Hyper, etc. We have a number of companies, but these all are type 1 hypervisors. You can directly install on your hardware resource or hardware machine or blade server. And now on the top of this, you will install operating system. You will create a virtual machine. So this is a virtual machine 1. Let's say this is a virtual machine 2, and this is a virtual machine. So these are virtual machines. I tell you here, this is a virtual machine. And every virtual machine will have hardware configuration, right? Let's say you are allocating 2 core for this machine with let's say 16 GB RAM. You are allocating this resource to this machine, right? And what about the next machine? We have a next machine. So you are allocating, this is a VM2. Let's say this is the VM2. This is the VM2, sorry, VM1, we can say VM1, VM2, and VM3. So these are the virtual machines, and every virtual machine has hardware configuration. Or you are allocating some resources to every hardware, sorry, to every virtual machine. And these resources are coming from underlying hardware resource. So this is the hardware resource here, right? This is your hardware. And further, on the top of this, you are installing operating system. Every virtual machine will have its own operating system. Let's say the first machine has Windows server, second machine could have Linux. Let's say this is the Linux server, right? So we have 2 Linux servers and 1 Windows servers. And the top of this, now you have multiple applications. All these are applications. All these are applications, right? Apps. I'll say all these are applications running on different machines. So on a same machine, now instead of using so this is the network connectivity, let's say, instead of using one operating system, now you have multiple operating systems. So you're utilizing this machine in a better way. So this is the use of virtualization, but we have 2 different kind of a virtualization. All these machines will have a different IP addresses. All these machines will have different IP addresses. Let's say this is your ESXi. Okay, so this is your ESXi, and we installed ESXi directly on this hardware machine. Yes, you'll get all these features, everything. Understand this. Let's say now think about the type of hypervisors. We have 2 type of hypervisors. Number 1, type 1, and another is type 2. Is it okay? Citrix is a company's name, Faizan. Citrix is the company name. It's not a hypervisor. What exactly is hypervisor is sharing underlying resources among virtual machines. Let's say this is your hardware. You please do understand. Let's say this is your hardware, and this hardware has 20 core CPU, 128 GB RAM, and we know that 1 core is equal to 2 virtual CPU. 1 physical core is equal to 2 virtual CPU. This way, this machine has how many virtual CPUs? 40. We have 40 virtual CPU. Please just do concentrate here. Then I'll be able to give the answer. Please don't write in between. It's not possible for me to just leave and this so please, let's say you have 20 cores and 128 GB RAM. Okay, and now you need almost 15 virtual machines. VM stand for you need 15 virtual machines, and every machine must have at least 2 core or 4 virtual CPU. 2 core, 15 virtual machines, and every machine must have at least 2 virtual CPU plus 4 GB RAM. At least I'm planning to create 15 machines on the top of this server. 15 virtual machines is simple. Even though after this you will have some resources in your hand. So what you will do, you will install type 1 hypervisor here. You will install type 1 hypervisor. And this hypervisor will allow you to share this underlying resources among these 15 virtual machines. So with the help of this hypervisor, so on the top of this, what you're doing, you are creating 15 machines here. Let's say I'm saying these are the 15 machines. 1, 2, 3. These are the 15 machines. And every machine will have its own operating system. There's an operating system. Some operating systems are Linux, some operating systems are Windows. Like there's a Windows operating system Linux, and this is a Linux. Sorry, this is a Windows operating system. This is a Linux operating system. On the top of this, you have some applications, right? All these are applications. So what you are doing here, you are better utilizing your underlying hardware resources, and you have now more machines, and these machines are working as similar to the physical machines. This is the advantage of hypervisor. Are you okay now? Now, hypervisor have two types. If you are installing hypervisor directly on a bare metal, directly on hardware, this is a hypervisor, and this is your bare metal, or you can say your hardware. And on the top of the bare metal, if you're installing hypervisor, you can directly create virtual machines on the top of this. All these are VMs, VM1, VM2. Such kind of hypervisor is known as Such kind of hypervisor is known as type 1. This is type 1 hypervisor and type 1 hypervisor. And some examples, if somebody will help me to give examples of type 1 hypervisors. Okay, type 1 hypervisor. Example, Zen hypervisor. Zen is from Citrix company, right? We have ESXi. This is from VMware company. We have Hyper-V. This is from Microsoft. Few more we have. Yeah, but we are talking about type 1 hypervisors. So my popular is ESXi. AWS is using Zen hypervisor. AWS is using Zen hypervisor. In their data center, right? Okay. But we have a few more examples related to type 2. What is the type 2? In type 2, you do not use type 2 in your data center. First of all, you cannot use these type 2 in data centers. You normally use type 2 on your host machine, like your desktop, either desktops or your laptop machines, right? Not in your data centers. So let's say this is your desktop hardware, and you generally see.
Just a quick info, guys. Intellipaat provides online AWS certification training in partnership with Future Skills, mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
So every desktop or laptop, the first of all will have some operating system. Let's say it has Windows 10, and at the top of this, now you are installing hypervisor. So this is a type 2 hypervisor, right? On the top of this, you are creating virtual machines. So this is only for your hands-on practice. Your hands-on. So if you want to just gain some experience over using these virtual machines, definitely you can use. So we have type 2 examples. Anybody who can help me to give the type 2 examples? VMware Workstation, Oracle Box, right? KVM, right? Oracle Box, Virtual Box, whatever, etc. We have few more. But these two, Workstation and Oracle Box, are very popular. Okay. So I think this is the difference between type 1 and type 2. You can find, and we are using type 1 in our data centers, right? We have some question. What is the main difference between type 1 and type 2 with respect to functionality? Functionality wise, both are same. The only thing is, Chiranjit, type 2 hypervisor needs some host operating system. Type 2 hypervisor needs some host operating system, while type 1 hypervisor you can directly install on bare metal on hardware. You do not require any operating system to install first. Next is the kernel of hypervisor. Through the kernel of hypervisor. Okay, so this is the hypervisor, and now I'm going to create a data center, virtualized data center. You please do see here, virtualized data center, an idea of virtualized data center. virtualized data center. Let's say you have number of hardware. I'm taking, let's say this is hardware, this is hardware. This way you have number of hardware, and every blade server has its own ESXi or hypervisor, right? These all are hypervisors. So I'll say hypervisor. And all these machines, all these blade servers are connected with some layer 2 switch or layer 3 switch, right? So this is layer 2 switch. I'm taking layer 2 switch to provide. All these are blade servers. And please don't ask what is a blade server now. Blade server is a simple server you normally put in a rack of your data center. In data center, we have racks, and in rack, we have multiple servers, and those servers are known as blade servers. Okay, now here, so all these are the hypervisors. All these are hypervisors. Yes. So on these machines, you have now hypervisors. Let's say you're using Zen hypervisor, or you're using maybe ESXi hypervisor. And once the hypervisor is installed, you put them in a cluster. You put them in a cluster. And let's say this is a cluster, the cluster of your servers. And on top of this, now you can create virtual machines, large number of virtual machines, right? These all are virtual machines, and every virtual machine can have different operating system. Let's say I'm taking operating system with different colors. These are the operating system, right? These are operating systems, OS. And on top of this, you have now application. Let's say some has one application, some has multiple applications. So these are the applications, right? So this is a very simple example. And now here you are connected here with some management server. This is data center management server, data center management server, and this is connected with this. And maybe this also is connected with kind of Active Directory or LDAP. And you have the storages, multiple storage for your data center, right? These are the storages. And this is the inside your company. So within the company you're using. And if you're making such kind of infrastructure over internet platform, this becomes cloud, correct? So we are taking AWS services. The services are basically grouped with some names. So here we are talking about compute under this certification. Compute, we have compute is a group, right? We have storage, we have networking, and we have see, these are the groups, correct? No, you have not to pay any extra if you are changing region under free tier. Okay, compute. Under compute, we have a service. Compute is a group, correct? So compute, storage, networking, and databases. These are groups in AWS services. Under compute, we have a EC2 service. EC2 stands for Elastic Compute Cloud, right? What you can do with the service? You can create and manage virtual machines. And here, virtual machines are known as instances. Correct and correct. So you can create and manage instances. Not only this, you can in EC2, you can create and manage load balancers and auto scaling. Okay, so these are the feature of EC2 service. AWS, I'm not writing every time. EC2 service. Okay, everyone. Second is in compute, we have another service. Let's say we have Lambda service or Lambda function, sometimes we call it Lambda function. What you can do with the Lambda function? If you have a code and you do not have any machine to run, and you do not want to use any machine to run your code, you want to run a code in a serverless manner. So you will use AWS Lambda function. So using this AWS Lambda function, you can run your code in a serverless manner. I'm not explaining these services. I'm just introducing the number of services we have. So I'm just giving an idea, kind of a service like EC2 is an elastic compute cloud. What you can do with EC2, you can create machine, you can manage machine, you can manage load balancer, you can create and manage auto scaling. But what is load balancer or what is auto scaling? We have a separate dedicated sessions on these terminologies, right? So Lambda function runs code in a serverless manner in AWS. Good. You don't require any EC2 instance. You don't require any virtual machine to run your code. Without virtual machine, through Lambda functions, you can, in compute, if you go there, you have Lambda, EC2 Lambda, you have Elastic Beanstalk. I'm taking a few only, not all, right? Because I'm giving some here examples. These are not the part of your syllabus. You cannot consider like this is the part of the syllabus, but I'm giving kind of a information knowledge, what kind of services we have in AWS. Okay, so Elastic Beanstalk. So this is a platform as a service, PaaS in AWS. There's a PaaS service in AWS. So if you have a program and you don't know how to create underlying hardware to run your application, you don't know how to launch, let's say, Tomcat server, you don't know how to configure load balancer, auto scaling, and you don't know how to actually create a kind of a network in order to create a machine. So there is a long list of the services you need to just configure to implement your workload, or to actually publish your application. So we have one service here, and the service name is Elastic Beanstalk. So this Elastic Beanstalk will help you to deploy machine and underlying infrastructure to run your machine. Just provide your code to Elastic Beanstalk, and Elastic Beanstalk will create underlying infrastructure for you automatically. So there's a kind of a magic for you. If you really think, you do not require any knowledge. You are a programmer, or you have a program. Somebody just gave you a program to just launch. In a few minutes, you will launch that application. You will publish that application over the internet using AWS platform. So this is a platform as service. That program will support this Elastic Beanstalk is supporting to almost every popular language. Let's say .NET, Java, Ruby, Python, and blah blah blah. Number of languages are there, right? And all popular languages are supported by Elastic Beanstalk. So Elastic Beanstalk is a platform as service. Will it work? Right. Let's say we are talking about storage here. We have a different kind of storages here. We have flat storages like S3. S3 is a simple storage service. S3 is service, okay? Simple. So you can say this is a object level storage. or you can say it's a flat storage. Why I'm saying it's a flat storage? It is not for any particular operating system. This is not supporting to any particular operating system. It does support to almost all popular operating system. Number one. And this is a storage within AWS. This is a storage within the AWS. And it's a limitless storage. It's a limitless storage. Any amount of limitless storage. Any amount of data can be stored here. And you can use this storage over the internet. S3 can be used over the internet. Right? But it's an object level storage. And we have multiple features. S3 has multiple interesting features. S3 has multiple features and security as well as operational features. And this is a very big topic. This is a very big storage. I told you it's a limitless. But if you're using free tier account, only 5 GB, storage in S3 is free of cost. If you're using more than 5 GB, AWS will charge. But if you talk about a limit of S3, it's a limitless. Any amount of data you can upload. The only thing is you have to pay for this, right? And we have different kind of, but now it's enough to just know that we have a storage solutions. And the first storage is S3. S3 is the object level, or you can say it's a flat storage. We have not a limited number of environments. We have unlimited storage. I'm talking about. We have unlimited storage in S3. Okay. We have EFS, elastic file sharing, elastic file system. Here we can say elastic file system. This is a file system. This is a NFS shared storage, or you can say it's an NFS storage for EC2 instances in your infrastructure. So this is a NAS kind of a storage. This is a NAS kind of storage using NFS protocol. Protocols, correct? This is called EFS. So if you're using this EFS, you're going to have a common storage for your EC2 instances. If you're seeking a common storage for your EC2 instances, you have a very good option here, EFS. And people recommend it for Linux machine, but to Windows 2, right? Next is, this is a file system. This is file system X, and this is a SMB protocol. It uses, or you can say SMB storage for EC2 instances, and it does support to Active Directory of Windows. It does support Active Directory of Windows 2. Correct? Very interesting. This again is a common storage, but using SMB storage protocol. So number in elastic means to S3 file system. Now in S3, in AWS we have one more service, S3 Glacier. If you are finding the service for data archival, or this S3 Glacier is a very cheap service. Okay. Second, if we have few more storages. Next is networking. In networking, we have AWS VPC, virtual private cloud. Very important service. use this service to create and manage network, manage isolated network and their components, and their such as, what are those components? Those components are Internet Gateway, IGW, Internet Gateway, and Virtual Private Gateway. Next is route table. Okay, route table, subnets, and NAT gateways, then VPC peering, then transit gateway, and security groups. Okay, groups, and network access control list, etc. Few more components are there, but these are some important components. This is an introduction to services, introduction to AWS services in your AWS, right? So if you just go there, your list of Route 53. Interesting. What is the Route 53? Route 53 is a service. Yes. Route 53 is a DNS service in AWS. Okay. And why you are using Route 53? To manage zones. Route 53 to manage DNS activities. DNS. Secondly, routing policy. Traffic routing policies, domain name registration, and DNS resource health check. So all these activity you can manage through Route 53. Yeah, that's why we're using port 53 here. Okay, global accelerator. A little tough to understand if you have no knowledge about AWS. Global accelerator. Using global accelerator, you can provide static IP addresses to ELB's endpoint. Use this service to provide two static IP address. Public IP address to ELB's endpoint. Correct? ELB's endpoint. Number one. Number two, and this service can also be used. This service can also be used to distribute your content. To reduce latency. And this service can be used to content distribution. To reduce latency. Right. That's all. So this is the global accelerator. So this way you have number of services. Global accelerator is comes under networking. VPC is not for security. VPC we are using to create an isolated network. So by default you get a one default VPC. If you want to create a multiple isolated network within the same region, you should use VPC service. Okay, will teach here. I think this concept is more than enough. If you need to just understand what you can do with this service. Correct, Faizan? We have services for security. If you need to understand the services for security, we have a different, these are the services for security, like IAM, Cognito, Guard, Inspector, WAF and Shield. All these are secure for security, identity and compliances. WAF and Shield is very powerful tool here. This WAF and Shield. WAF is what? Okay, one by one will come. Now let's talk about first of all database. We'll talk about security. In database, we have RDS, one service. We have DynamoDB. RDS is a relational database service. Okay, using this service, you can create any SQL server, or you can say SQL server or SQL service, you can say. You can create any server like Aurora, Microsoft SQL, MySQL, PostgreSQL, any else, Oracle, etc. Few more, right? In DynamoDB, this is a no SQL database service. Okay, and you can use DynamoDB to manage and create NoSQL database. We have a Redshift. Sorry, we have a Redshift. What is a Redshift? If you want to create a data warehousing service, if you want to create data warehouse, data warehousing, right? Yes, OLTP, correct, right? So these are the database services we have. We have some services from security. We have some security services. In security, most important is a part of our syllabus, IAM. So identity and access management. So you can use this to create and manage. What you can use? Create and manage users, groups, roles, and policies. Correct? With the help of IAM. And you can also provide multi-factor authentication to your users for secure login. Next is we have a service called WAF. WAF is Web Application Firewall. Web application. So if you want to apply a web application firewall to your load balancer or to your application, this is very fantastic service. In this service, you will have updated policy-wise actually rules. You can use those ready-made rules and you can apply on your application or in your infrastructure. But you have to pay for those rules to AWS. And these rules are basically fulfilling all the compliances and the conditions you normally see in your professional environment. Web application firewall. Few more services we have. In management and governance, we have we have the service called AWS organizations, right? So if you have multiple AWS account, let's say a company, and your company has multiple AWS account and you want to manage billings as well as the services and users, groups, roles, policies, everything centrally for those multiple AWS accounts, you can first of all club them together to provide such facilities. So, and the service is known as AWS organization. Okay. Next is we have cloud formation. Very interesting. We have cloud formation. So I'm writing a little shorter here, and I'll ask you people to just complete all these details. I just gave some idea, 1 line or maximum 2 lines. So I hope you should at least just write 2 or 3 lines on each and every service name, right? The cloud formation from a template of program. You can create and you can create infrastructure. You can create AWS infrastructure. No need to create your infrastructure manually if somebody provides you kind of a template or kind of a program in terms of template. If you're using that template, all EC2 instances, VPC, then subnets, security groups, and firewalls, their configuration, everything can be managed through this cloud formation service. This is a very interesting service. Okay, cloud formation. Next is CloudFront. CloudFront is for content delivery. Elastic Beanstalk also use the similar kind of backend templates available, and it will use. Next is cloud monitoring, CloudWatch, cloud monitoring. if you want to monitor the resources, in AWS. We're using CloudWatch. We have a cloud trail to manage and store logs, logs about the services, logs about AWS services. Okay, so these are few things I just discussed here. What is an EIP? Okay, EIP is a fixed static IP address to instance or network interface, or you can say ENI, elastic network interface. So every machine will have a network interface, correct? So how to provide? So please listen to me very carefully. If you want to provide a fixed IP address, fixed IP address means static IP address to your instance or a network interface, elastic IP address is the best solution, because normally by default when you create an instance, your machine does not get any fixed IP address. It gets by default a dynamic IP address. What is the meaning of the dynamic IP address? So when you start your machine again, when you restart your machine, when you stop and start your machine again, your IP address does change. But if you want to see a static IP address to your machine, so we have a solution, elastic IP address. So elastic IP address is the link with your account, first of all. So you have to purchase it from AWS, and AWS charges for EIP. So you can associate or disassociate EIP with your instance or network resource anytime. So what is the important about EIP? So first of all, EIP is a fixed IP address. This is a fixed static IP address to your instance, number one. Number two, an EIP is a public static IP address, which is reachable from any instance. And it's means this EIP is reachable from internet. EIP is reachable from the internet, correct? And a static IP address based instances can be reachable from internet from anywhere. In order to provide an entry to reverse DNS, you always require a fixed IP address. So this fixed IP address, why we are needing fixed IP address? Why EIP? So EIP is main concern is, first of all, it's unchangeable. Number one. So first of all, why EIP is required? Because it's unchangeable. Number one. Number two, you can use this fixed EIP in DNS configuration, correct? If you don't have a fixed IP address, you cannot maintain any resource record in DNS. So if you want to configure this IP address of this instance in DNS, if you want to include this IP address in the DNS, your machine must have one fixed IP address. Clear? One more thing I need to just tell you, because I told you this EIP is not a free of cost, and we have a limit to get the number of EIPs in our account. So maximum 5 EIP can be taken per AWS region, correct? Maximum 5. I'm talking about the free tier account. I'm talking about the free tier account. But if you need more fixed IP addresses or more fixed EIP addresses, you can take in support of AWS team. They will increase this quota. To understand your requirement, they will increase the quota of your EIPs. But by default, maximum 5 EIP can be taken. One more thing, in case of failure of instance which is running an application on AWS, a new healthy instance can have the same static IP address. Means the one EIP, if your machine goes down on which you are using this EIP, you can use the same EIP with another healthy instance. Okay, you can say EIP can be associated with another healthy instance. So meaning of this. And next is, if there is a need for more static IP address for your AWS architecture, you can raise your request to additional EIPs to AWS support team. They will increase the quota of EIPs, as I already explained. So this is the thing. Now we can take some lab activities related to EIP. Lab related to EIP. Okay, I'm just trying to mention first of all how to get an EIP, or how we can allocate. How we can allocate an EIP in your AWS account. AWS account. Number one, this is the first activity. Second is, once you have EIP, once you have an EIP, how to associate the EIP with an instance. Correct? And once it is done, you can just go for test and verification.
Just a quick info, guys. Intellipaat provides online AWS certification training in partnership with Future Skills, mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
Test and verify. Verify once it is done. Next is how to disassociate the EIP from the instance, and how to remove the EIP from your account. EIP from your account. So these are the activities we are just going to take. These are the 4 things. So one machine can have only one EIP, and one EIP can be associated with one EC2 instance or network card. So let's start. We are here. So this is your AWS account. I just created a new AWS account because I was not using it for last 3 weeks. It was suspended because of non-payment. So I created just now a new account. So this is the EC2 dashboard. So first of all, I must have one running instance. Right now, I do not have any instance. So I'm going to create a new instance here. Right now, I don't see any instance. I'm just going to launch an instance here. You give me just 1 second to create my instance. Right? Next, this is the default setting I'm taking. I'm not making any changes here. And storage, 8 GB is okay. Yeah, of course, I would like to give the name to my instance here. That's the name. Let's say my Linux server. And this is the security group. This is a security group. Of course, we have the security group. I'm taking all ICMP. I want to allow ICMP protocol to just check whether it's pingable from internet or not. Okay. And you launch it. And once you are on the final step, you need to just create a new key pair. Let's say Intellipaat, and today is 19th December. Okay, I'm just downloading the key pair, and you launch the instance. And finally, I think the instance has been launched. So this will take hardly a few minutes to launch it. So the machine is there. This is the public IP address of the machine. But this is a dynamic IP address. Of course, this is what is the meaning of the dynamic IP address of dynamic public IP address. Will anybody please update me? What is the meaning of public dynamic IP address? What is the significance of this IP address? If we have already the public IP address, why we are just trying to give EIP? EIP is static and it will change when you restart the machine every time. Very perfect. You are 100% correct. So this is the IP address we have, and CMD. I just do open a CMD and I just trying to ping my machine. My machine is pinging. Everything is perfect. Okay. So now it's time to provide an EIP. If you see here, under this public IP address, we have public DNS, and below this entry, we have elastic IP addresses. So we do not have any elastic IP address here. Do you see any elastic IP address here? No. It means you need to provide an elastic IP address to your machine if you need a static IP address to this machine. So what is the step we need to initiate? On the left hand side, this pane, if you scroll down under network and security, you have elastic IPs. Do you see elastic IP? So you click on elastic IPs. You don't see any elastic IP address in this region. Correct? You don't have any elastic IP address in this region. What I'll do? First of all, I'll allocate an elastic IP address to my account in this region. You click on allocate elastic IP address. First of all, you need to select. This is the region you have, US East 1. US East 1 means North Virginia. This is the code of North Virginia. And you are just going to take this static IP address from the Amazon pool. Means Amazon will provide you this static IP address, correct? So rest things I'm not telling you about the global accelerator and all. I'll just give some idea about later on what is the meaning of this global accelerator, okay? And the global static IP address. Right now I'm just choosing Amazon's pools of IPv4 addresses. You just click on allocate. As you click on allocate, immediately you will have one static IP address here. You will have one static IP address here, and this is static public IP address. But the thing is, this elastic IP address is not associated with any resource. This is just free. You just allocate it to your account, correct? But if you see associated instance ID, you don't see any instance ID here, correct? So what you will do in next step, I need to provide this static IP address now, this EIP to your EC2 instance. Now we have one EC2 instance. What you will do, you will select this, you will just go to actions, and you will associate the third option we have, associate elastic IP address. You click on associate elastic IP address. We have two options to map this elastic IP address, either with the instance or with the network interface. And you know that every machine has a network interface. If you directly want to attach this EIP with the network interface card of your EC2 instance, or this network interface card can be used for the load balancer, this network interface card can be used for any other purpose, for the storage sharing, correct? But right now, I'm just allocating this EIP to my EC2 instance. So that's why I'll select the EC2 instance here. Next is what instance, which instance you require to map this EIP. So if you select here, if you just click here on instance box, so already the instance you already created will appear. You select this instance here, and do you want private IP address to your machine? Yes, by default it should. Your machine should have even private IP address, because the private IP address is provided within the organization. or within the organization. Of course, this private IP address is not accessible from internet, but if you want to access your machine within the organization, within the AWS account, this private IP address is required. That's why I'm selecting this private IP address, which was earlier given by default to your EC2 instance. So this is the screen in which you are associating your elastic IP address to your EC2 instance. So this is the EC2 instance ID. Now click on associate. Once you click on associate, you see the elastic IP address you had, this. Now it is associated with this instance ID. Correct? Correct or not? It means if you choose this EIP, I'm also just copying this EIP among you people. You can see in your chat, just try to ping this IP address. You try to ping this IP address, and the response should be yes. Right? I'm going back to EC2 instance this time. This was the EC2 instance. And this time you would see earlier we had no elastic IP address to my machine. So this is the elastic IP address to my machine. Correct? I'm refreshing it and I can see. So this is the elastic IP address to my machine. And the same elastic IP address is my public IP address. Correct? And the same IP address you can find in the DNS name of your EC2 instance. So we did a few things. How to get an EIP, number one, correct? And once you have an EIP, how to associate it with the instance. And now it's time to test and verify. In order to test and verify, it's a simple, you just go to internet and just ping and just paste the IP address of your machine. This is a static IP address. So it's a pingable, number one. Number two, if you stop the machine, and if you start the machine again, we'll get the same IP address or not? We should have the same IP address. The purpose of providing the static IP address, it should not be changeable. Yeah, this is chargeable. I told you one more important thing I need to add, the charges of EIP. The charges, number one, in AWS account, in AWS free tier account, you'll get only one EIP free of cost. Free of cost, condition is if the EIP is associated with an instance, or interface, network interface, correct? Then only it is free of cost, and only one EIP, because you are using free tier account. No, private IP address is not the dynamic. Private IP address always is fixed, correct? Private IP is not dynamic. It is fixed, correct? Okay, so this is done. You can also use this public DNS to reach your machine. This will also work. It does work here. It should work. It is not working. Why it is not working? Let me see. What the change? Okay, my machine is stopped. Oh, sorry. My machine is stopped. I need to start the machine first, correct? I need to start the machine. Once you start the machine, you'll have the same IP address, yes or no? You must have the same IP address.
This is the purpose of providing this EIP to your machine.
I'm waiting here. Just a minute.
Now I can see my IP address is fixed now. And if you try to run the same command once again, if your machine is up, this command will respond. Okay. So this was your EIP. So once it is done, now your test and verification is done. How you can disassociate if you want to free this EIP from your instance? What are the steps to be initiated? First of all, you will disconnect this static IP address from your EC2 instance, and that is termed as disassociation. And once it is disassociated, the first step is disassociation. Disassociation of EIP from the instance. So once it is disassociated, then you can release the EIP from the instance. Correct? I think this is clear. My spelling is not disassociation. Right. Okay. I'm going back. So this is the EIP. You go to the EIP again. You click on EIP. You select your EIP. We are disassociating this EIP from that associated instance. Correct? You select the instance, select the EIP, go to action, and now we have an option here, disassociate elastic IP address. You just click on disassociate EIP. It'll ask about, means you're just going to disassociate, and what are the consequences of if you are disassociating this EIP. It is written here. You cannot use this static IP address again. Correct? You just disassociate. So once you disassociate, once the disassociation is finished, you'll find you don't have any associated instance here. Correct? Okay, so this is done. I also want to just tell you here, if you see your instance once again, if you see the instance once again, you'll find now the IP address of this machine has been changed. Correct? And you don't have now any EIP addressed to your instance. And this is the dynamic public IP address now your machine has. Correct? We are going back, and this is the time to release this EIP, because I'm not using this EIP anymore. So you will select this EIP, go to actions, and simply click on release elastic IP address. As you click on elastic IP address, release elastic IP address, this will be released. Now your account has no elastic IP address in this region. So this was about elastic IP addresses. So you did all these activities, and if you want, you can do at your end. And the topic is a snapshot. Very interesting. We are coming here. Snapshot. Okay, guys. So snapshot I'm taking. You please do understand what is snapshot through this slide. Then I'll just explain you more in detail. First of all, what is a snapshot? This is a backup and recovery method of data from your EBS volume. If you want to take backup of your EC2 instance, you can use this feature snapshot. The snapshot are point-in-time backup of your EBS volume, and the snapshot are incremental and cost-effective solution if you want to take the backup of your EC2 instance. and multiple backups can be taken of your EBS volume, and they will be incremental in nature. An incremental backup is type of backup method which copies files that you have changed since the last backup. The only changed data you will copy in your new backup. So this EBS data store process creates a volume from snapshot that can be further attached with EC2 instance. So once you take a backup of your EBS volume, that is known as snapshot. Correct? So, and they are incremental in nature. You please do understand, I'm just trying to explain you in one drawing. That will better you'll find here. Let's say this is the volume you have. Can you see my mouse pointer? This is 10 GB volume you have. And now you want to take the backup of this volume, which is known as snapshot. The very first time you are taking the backup of this volume. So the entire 10 GB data will be copied in the first time taken snapshot. Correct? So this is the first time you are creating this snapshot. The entire 10 GB data will be copied in this snapshot. But after a certain time, let's say after 1 day or 2 days, you are planning again to take the backup of the same volume again. However, you had a snapshot A earlier 2 days back. But if you are taking a snapshot, what will happen? In the last 2 days, you observe that the only 4 GB data was changed, not the entire 10 GB data. Only the 4 GB data was changed. So when you're taking the backup again, when you're taking the snapshot again, only the 4 GB data will be copied in the snapshot B here, not the entire 10 GB data this time. And the rest data, 6 GB data, which was not changed, it is referenced from earlier snapshot. Correct? So this way, if you're taking the multiple data backups here, only the incremental data will be backed up, not the entire 10 GB data. This way, you are saving your space to store your data because you are paying for the stored data. Secondly, it will take a less time to create a snapshot. Time as well as money, both are valuable and both are saved here because snapshots are incremental in nature. But what happens if you delete a snapshot A? Because the snapshot A was rolled as a reference for the snapshot B. If you're planning to snapshot A, and which is containing some data which is reference for snapshot B, it will copy that reference data from snapshot A to snapshot B, then only the snapshot A will be deleted, otherwise not. Let's say this is the machine you have, correct? You see, this is the machine, and this is your EBS volume, and this is the EBS volume. You please see. Please don't write anything. I'm not reading it here. And when you're trying to plan the backup of this volume, you always select a snapshot option. You always take a snapshot, and snapshot using S3 buckets to store your data. Snapshots are using S3 buckets by default, buckets to store data, to store snapshots. Correct? So let's say this is 10 GB data, the 10 GB volume you have, and you are taking very first time snapshot of this EBS volume. The entire 10 GB data will be copied here because you are taking the first time. But after certain time, let's say after 2 days, okay,
let's say after 2 days, that can be any time. I'm just assuming we are taking after 2 days. You feel that the only this data is changed. Let's say after 2 days, your machine will identify this service, this snapshot service will identify that only the 4 GB data was changed. Okay, so if you're taking the snapshot again, this only 4 GB data is copied here. You please do understand. The 4 GB data is copied in a snapshot B. So let's say this is snapshot A and this is snapshot B. And the rest data, which is not copied here, it is referenced from the previous snapshot. It is referenced. So this way you are saving time as well as saving space. You'll not create the entire 10 GB, then you will not take the entire 10 GB data in new snapshot. You will use only the 4 GB snapshot here. Correct. What happens if you try to delete this snapshot A? Before deleting the snapshot A, what AWS does, it will copy the entire data which was referenced for snapshot B from here to here. Okay, once the data is copied, then only the snapshot A will be deleted. This is just like a Windows servers, incremental backup. So if you are saying this is incremental in nature, this backup is incremental or snapshots. Correct? Snapshots are incremental in nature. Now, what exactly I need to tell you here? Let's say you have one volume. This is the EBS volume, and this EBS volume is attached with one instance, right? This EBS volume. I'm taking the EBS volume, whether it is a free, whether it is attached. You have an EBS volume, and if you take a snapshot, you always take a snapshot of EBS volume, not of your EC2 instance. Correct? So you take an EBS volumes snapshot here. This is snapshot. And once you have a snapshot, what you can do with a snapshot? You can create a new EBS volume from the snapshot, number one. Or if you want, second, you can also create an AMI from one snapshot. Or if you want, you can copy from what, because this is a region specific, correct? Let's say this is in region 1. If you want, you can copy the same snapshot in another region. You can copy. These things you can do. First of all, snapshot is the EBS volume backup. EBS volume backup. That's all. Number one. And AMI is a template. It's basically a template of an operating system containing machine information. Correct? Or volume, which contains everything, which contains operating system plus softwares plus configuration, everything. The only thing is, using AMI, you can create an EC2 instance. Right? And this volume, the snapshot, you can use to create a new volume. The snapshot can be used to create a new volume. Okay, what I did. Just a minute. So this is done. Yeah, I was trying to say, let's say if you have an EBS volume, this is your EC2 instance. and you have multiple volumes here. Let's say I'm assuming this is the root volume and this is your data volume. Okay, and this is the machine you have. Now you want to create a duplicate volume of this. What do you do? You have another instance. This is instance 1 and you have another instance.
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which one of the following is cloud platform by Amazon? A. Azure, B. AWS, C. Cloudera, D. All the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Correct. This is a root volume. A root volume always contain operating system. Correct or not? EC2 instance. 2. So what you will do, you will first create this snapshot from the EBS volume, and once you have a snapshot, you will create this EBS volume. You can create the EBS volume from the snapshot, and once you have this EBS volume, now you can attach this EBS volume with another instance. That can be done. So this kind of practice you can do. So the same data you will have now on another machine. So this is the one scenario. In this scenario, according to this scenario, what you were doing, you had one volume which was attached with one EC2 instance, and you need to create a similar kind of EBS volume to attach with another EC2 instance. So first of all, you will take the snapshot of that EBS volume, and using the snapshot, now you have an option to create an EBS volume here. Once you have an EBS volume in that region, then you can create an EBS volume. So you can attach with the EC2 instance, another EC2 instance. Okay, one more thing I need to tell you here.
Just a quick info, guys. Intellipaat provides online AWS certification training in partnership with Future Skills, mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
Sorry. Yeah, definitely you can create a snapshot of root volume even. Correct. Let's say, see, I'm taking a lab scenario here. Number 1, you have an EC2 instance, yes or no? Let's say the region is North Virginia, okay? And in this region, you are in a specific availability zone or in a specific subnet, correct or not? And every availability zone is a group of data center which has a specific resources. You please just do concentrate here, and please do understand what I'm. This is the EBS volume you have, right? This is the EBS volume you have. Let's say this is the EBS first volume. This is the volume 1, and let's say this is your EBS volume. EBS volume 2. Please do see. And we have some specific data in this volume. We have very important data in this volume, correct? Now, right now we are in, let's say, in availability zone 1. We have another machine. We have another machine in different availability zone. Let's say this is an EC2 second instance, and we already had this root volume. So we are not touching this root volume because the root volume containing operating system plus configuration plus some softwares, correct? So I'm not touching it. So, and my data should be in another volume. What exactly my company want me? So they want me to just transfer this data as a volume in this EC2 instance. What they will do? And both are in a different availability zone. Let's say this EC2 instance is in different availability zone, correct? So what you will do? First of all, you will take a snapshot of this volume. You will create a snapshot and then you will convert that EBS volume for availability zone 2 or some specific subnet, right? Once you have this, then the final step is you will mount this volume here. Then only this machine can read the data this volume has. So this way, you can create a new volume using a snapshot. And once the volume you have, you can attach the volume with a new instance. In order to read the data, in order to just transfer your volume from one availability zone to another availability zone. Maybe in this case, you have instances in different availability zones. So please let me know. So this lab is clear or not? Right. Now, please let me know. You must have two volumes. So first of all, this is the volume. Sorry. This is your EC2 instance, correct? And this instance has only one volume. Let me take a very simple question here. Let me take a very simple scenario. Then you will understand. One by one, we'll just move. We'll complicate the scenario then. Let's say lab. This is the EC2 instance, and this EC2 instance has one EBS volume. Okay, and this EBS volume contain operating system plus configuration plus softwares or application, whatever it is. Everything is there. Okay, this EBS volume is what fine. Sorry, this EC2 instance. This EC2 instance in a particular region is specific, and availability zone also is specific. Okay, so what you will do? So first of all, I want to create a snapshot. Once I have a snapshot, I'll use this snapshot to create AMI. Okay, and I'll tell you how you can create EBS volume. And once you have an AMI, this AMI further can be used to create a similar kind of EC2 instance, either in a same availability zone or in different availability zone, or even in a different region, right? So this is the EC2. You please do understand the purpose of AMI, why AMI is needed, and what is AMI, and how AMI is different from EBS or the snapshot. Snapshot is what? Is a backup, only the backup of EBS volume, backup of EBS volume, that's all. However, AMI can be used to create a new EC2 instance, but the snapshot cannot be used to create a new EC2 instance. But the snapshot can be used to create a new EBS volume, and this EBS volume now you can connect with another EC2 instance, right? This is the EC2 instance. You can attach this EBS volume with another EC2 instance. And please try to understand all these scenarios. So one by one, we'll just try to complete it. And for that, we must have one EC2 instance. We have an EC2 instance here, and this EC2 instance has one EBS volume. Shall we go now? Shall we start? Okay. So this is your, yeah, please just concentrate here. Yeah, this is your EC2 instance. You click on storage. In storage, you'll find EBS volume, right? So scroll down and select the EBS volume. So this is the EBS volume ID. Click on EBS volume. This is the EBS volume. I think you all are watching very carefully. So this is the EBS volume was connected with the EC2 instance. This was my server's name. And this is the EBS volumes ID. And the size is 8 GB. What you will do, you select the volume first, go to actions and create a snapshot. Do you see snapshot option here? You click on a snapshot here. You write the name of the snapshot. Let's say snapshot 001. This is a snapshot. If you want to give any tag to the volume, it's okay. As a snapshot, you can give or you can skip. It's up to you. Now click on create snapshot and close it. The snapshot should be created. So you need to confirm the snapshot is created or not. Left hand side, you have this navigation pane under Elastic Block Store, because this will be a part of the storage. After this volume, you'll find the snapshot here, and this would take a little time to complete activity because it will take 8 GB snapshot the first time you're creating, correct? You can write here like snap 001. And in the permissions, you can share, if you want to share this snapshot with another account holders or another account members, you can select this option, just like I did in AMI. I created and I just tried to copy it from one account to another account. In a similar way, if you want to share this snapshot with another account numbers, you can use the similar option here. And here, this is the snapshot. The snapshot is created. So you can find this is active. This is completed. The right hand side, you can find the status, right? This is done. This is completed. And then, well, you can find a timestamp of this snapshot here. This is a timestamp. Where has gone the timestamp? Yeah, this is the timestamp. Correct? What will we do next? So once you have a snapshot, what you can do? According to this, once you have a snapshot, either you can create an AMI or you can create an additional volume. That depends in which availability zone you want to use to create the additional volume. Let me tell you here, this is the EC2 instance you have, right? And this EC2 instance is created in which availability zone or in which subnet? Do you see information? In networking, yeah, this is in US East 1. Sorry, US East 1C. Do you see? Guys, can you see the machine is using US East 1C availability zone? Right. Let me create another instance in another availability zone. Or you can do one thing better to use this snapshot. You can use this snapshot to just create a new AMI. Yeah. So this is the AMI image.
let's say my Linux server AMI, right? Description like Intellipaat demo, right? And if you want to make any changes in volume type or volume size, it's up to you. I'm taking default one, and this is done. The AMI is created. Okay, if you need to confirm, you click on AMI, and you can easily watch it here. This is being created, right? Now, this is available. This is done. Now, can we use this snapshot to create a volume? Yes, this is a snapshot. And let me choose a volume. Create a new volume. All these are the volume types, and these are the parameters you can change while you are creating a volume. And my machine, earlier my previous machine was in the US East 1C. Let me choose this time US East 1A. I'll create a new machine in US East 1A. So I'm creating this volume for my new availability zone. So create a volume and done. The volume has been added. If you see left hand side under the elastic block store, click on volume. This time you have two volumes. So this volume belongs to the machine you have, right? You're using it, and this is the available volume. So this is not yet attached with any EC2 instance. And this volume you created in a US East 1A, and the earlier volume was in US East 1C. But the both volumes are 100% identical. You can write like US East 1 East 1A, correct? And this is my volume. Right. This is the name I want to give you. You can easily identify. This is the volume. And if you want to attach this volume with a new machine, you must have a machine in the same availability zone. You launch an instance. This is the instance. US East 1A, right? You please select a proper subnet here. Add storage, done. Security group, it's okay. In security group, it's okay. I'm not making any changes. You launch, and I have this key pair already. I'm using existing key pair, and the machine is done. Machine is ready. Once the machine is ready, let's say I'm just giving the name to this machine. Let's say VM under 1A. Okay. VM under 1A. Okay. VM under 1A. What's happening? VM 1A. My God, save. Just good. One. So this is the VM, right? And you can also confirm from networking that you are using US East 1A availability zone for this machine. Correct. Now this machine has only one volume. This machine has only one volume, and this is for your operating system. And we had another volume which I created. Yeah, this is the volume I created from Snapshot. So once you have a volume, you need to attach this volume. You click on this action, attach the volume, and select the instance. Yeah, this is the instance in a same availability zone. That's why you can see only one instance here, because you chose US East 1A, right?
and finally you attach it. Done. So if you see, you go to the instances back, and this is the instance you have. You refresh the screen. This is the VM 1A instance, and go to the storages. You go there. How many volumes you see here, guys? This time, how many volumes you can see here? What is the bootstrapping? Please listen me just a few minutes, hardly 1 or 2 minutes. I'll cover this topic. This is not a big deal, but you should have some pretty good idea about scripting. You should know scripting language either for Linux. For Linux, you should know shell scripting, and for Windows Server environment, you should know PowerShell. What is bootstrapping? First of all, the bootstrapping. You please do understand when you launch an instance using AMI, you notice that the launched instance is fresh and with the default configuration, means it is not configured for your application or for your requirement, but you have to install certain packages and want to do some configuration on the top of this. So this may take some valuable time and efforts. So in order to automate this installation, configuration, and uploading your softwares, you can pass some codes, we can pass some script at the time of the launch of the instance to initiate such a task. So this process is known as bootstrapping. So in short, the bootstrapping enables you to script software installation and configuration at the time of the launch of the instance. Correct? So if you know what you want to do once your machine is launched, so all those steps, all those tasks, you can write in terms of scripts, and during the launch of the instance, you can pass the script. You can save your time to further configuration or installation, a number of things you want to do later on in your machines. Okay, so you write a script to configure your machine, and then you can pass at the time of the launch. So what we are doing, I think the bootstrapping is clear. What is the meaning of bootstrapping? The bootstrapping enables you to script software installation and configuration of your machine at the time of the launch of the instance to save your time later on to configure a machine. Is it clear? Guys, what is the bootstrapping? So let me take one very simple example to configure your instance at the time of the launch. Let's say you want to configure an Apache server in a Linux instance. You want to create one index.html page, and you need to pass that script while the instance is being launched. Okay. So let me write here. So this is the lab. Write a script. First of all, write a script. So when I'm just typing a script, I'm always talking about either shell scripting or PowerShell scripting, because my machine is in Linux. So I'm talking about here shell scripting. Correct? You should have a pretty good idea about the shell scripting if you want to automate the job entirely at the time of launch. You must have a good hands in shell scripting. Correct. So you write a script to configure like HTTPD server. Sometimes you can call it as Apache server, right? Apache server in Linux instance. I'm just making this scenario just now so that you'll feel ease and create an index.html page and pass it while the instance is being launched. Right? Will it be okay? So this is the lab. So what is the script? The first of all, you should have a script with you. So I'm just trying to just write the script in a notepad. So it doesn't change the format here. Let's say, so what's the first line you use to write shell script? Hash bang. Is it okay? Visible? Hash bang bin bash. So this is the first line you write when you start your shell script program. And let's say the first command you write sudo su hyphen to switch as a root user. Then yum install httpd space hyphen and service start httpd. Right? Okay. Check. There should not be any mistake in this, right? Check config httpd on, and now you just writing line. This is my Intellipaat web server demo page. Okay, and now you are transferring. Yes, installing the httpd is one time for given. It will run only one time when you launch the instance. It won't run it again, right? So where www HTML, and you are just passing to index. Yes, index.html. The purpose, Snehanshu, the purpose of this, you see, this is a script. This is a bin bash. You are writing a shell script. So first of all, you are switching to the root user, and as a root user, you are installing this httpd, and later on you are starting the service. Later on, you are just making it available for the next login. HTTP check config HTTPD on, and now finally you are creating one index.html file. So all this configuration to an instance, basically you are passing at the time of the launch. Once this script is executed, your machine is configured as a HTTP server. Your machine is configured as your Apache server. So the purpose is to configure your machine as an Apache server. So in a similar fashion, if you have any other activity, if you have any other task, you can also include in that one. So the index.html is a kind of an application. I'm just trying to ensure that means once this is enabled, once this is configured, so this is properly accessible over the internet through this page, because you're configuring this HTTP. And HTTP, if you want to actually test this HTTP, you need an index.html page. Correct? Yeah, you can use any command which is executable on Linux machine. So instead of doing all these activity manually, you want to complete all these activities through this script file, and this process is known as bootstrapping. Correct? I think Snehanshu is clear. Okay, so you just copy it, and I just paste it at the time of the launch, and I'll share this with you also. Let's say I'm showing you how you can configure, how you can launch your machine. You please see. Please don't write anything. Yes, once it is done, you can convert it into AMI. And definitely, let's say, let's say this is the instance we have. Now we need to create a launch instance. We need to create a new instance here. Okay, I'm selecting Amazon Linux. Okay. T2.micro. I'm selecting like you. Yeah, this third step is significant, and this is vital to pass your script. So you are in step 3. Please ensure that you are in step 3. And once the number of machines and your network, subnet, and auto assigned public IP address is selected, you go down, scroll down on this page, scroll down on the step 3. Okay, under the advanced detail, this is the block, this is the box you have where you can paste the script. Either you can paste the script, or in case if you have a big file, you can also pass the file here. You have an option to pass the file. Do you see, guys?
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which one of the following cloud concepts is related to sharing and pooling the resources? A. Polymorphism. B. Virtualization. C. Abstraction. D. None of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Okay, you already done an assignment. Very good. Add a storage. So why I'm wasting my time here? You tag it, and you pass port number 80, and right, you launch it, and you're done it. Right, you've done it. So you do not require to take the remote of this machine to configure. It will configure automatically. This is the machine you have, right? You can set web server, right? Save it. This is the web server. Yeah. Okay, I think you already done it, Mala. It's a one-time, yeah. It's a one-time run. Okay, I think this is done. And this is the public IP address. And I'm using the public IP address, and let me see it is done or not. Sorry, it is not done. Why it is not done? Let me check. This is network interface. Just a minute. In security, this is the security group. Port number 20, port number 80 is okay. This is done. It's initializing. Maybe now this is okay. Let me see now. Should not take much time here. Something is wrong with the script, I think. What do you say? Sudo su yum install HTTP service. Oh. It should be HTTPD service, HTTPD start. If I'm not wrong, you didn't tell me, isn't it? This is right. Service HTTP start. Let me check. You should sudo service HTTPD status. This is sudo service.
Service. Yeah, this is the problem. Yeah, we did use here. I'm deleting this instance. Okay, I'm terminating the instance. I'm deleting my all instances, right? I don't require actually all these instances, and I'm creating a fresh instance here. This was the wrong. It should be the service HTTPD start. So this time I'll use different. This is the correct one. Copy. You just go to the instance, launch the instance, you copy. Okay. Next, you go to the last tab, you paste it here. Okay, HTTPD. Should not be any spelling mistake. And add and HTTPD. This should be on, launch, right, acknowledge, and done. No need to open it, no need to configure it, but please ensure that your script is perfectly okay. If you find some error in that document or in script, so it won't run properly. So I'm launching this instance here. Now this is pending. Give me 2 more minutes here. So this time, this is the public IP address. I hope this time it should work. There is no need to use a systemctl start HTTP, but if you know it, you can run it. Prepend. This also works. Okay, you go there this time, Control V and see, will it work or not? No idea, something is really wrong with my script. Oops, I should have taken the script from. Let me see whether it is working or not. Yeah, it's working. Yes, working now. You can also try at your end, pasting the IP address of this instance. You can check whether you are able to see this page or not. And please ensure. So with the help of script, without opening, without taking control of this EC2 instance, you can easily configure through the script. And this is not a new technique. You normally do the same kind of thing in your working environment, right? In Windows, it is called as batch or answer file. Is working? Correct. Good. So what I'll do, first of all, I'll just try to save this document, this drawing. Today is, according to me, this is day 3. Day 3, or you can say 19th December. You're saving it, right? Good. And this is your page. You save it. I'll just share this document with you. And this document contains, let me just connect this, start. So this is the script you have. This is the script, right? Good. So what you did today, now you have the knowledge of boot script. Second is snapshot and EIP.
Now let's talk about a very important topic, which is AWS pricing. So let's move forward and understand how the pricing model works in AWS, and if I'm using a set of services, how will I be charged? How much will I be charged? So guys, the AWS pricing options are among these 3, right? The first option is pay as you go model, which means whatever amount of time you will be using an instance for, or whatever amount of time you will be using a server for, that amount of time will be billed to you and will be given back to you. So whenever you will be launching any server, you will get a per hour basis charge on that particular service, right? So you can see that service, you can see what the charges are, and accordingly you will be charged whenever you terminate that instance or whenever there is a monthly billing cycle of yours which is ending, right? So the first model is pay as you go model, which is widely used. Second model is save when you reserve. Now, what do you mean by that? Let's say you're launching a website today, right? And that website is for your company, and you foresee that I will be at least running this website for the next 3 years. Based on it's just a startup, I might not see that much growth, but I will sustain it for 3 years. In 3 years, my website is gonna there, right? Let's say this is the scenario. So what you can do with AWS is you can opt for dedicated instances or reserved instances. So you can say that I'm going to use this instance for 3 years from now on, right? And I'm not going to back out. I am going to use this instance for 3 years. Then what AWS will do for you in that case is it will give you a counter offer. It will give you a discounted price, right? Reason being that it is no longer an on-demand service. It's a service that you have asked from AWS, which you will use for 3 years, which means that you will have two options in front of you to get this kind of a deal. One thing is you can do a full upfront payment of 3 years, right? You can pay all the whatever discounted price they deliver to you. You can just give the amount for 3 years and you can use your instance, right? Then you're locked in. Or what you can do is you can also do a partial upfront payment if that eases out the financial stress on you, right? For example, you do not have that kind of money to pay for 3 years. So what you can do is you can divide your payments into EMIs and then you can pay it to AWS. That's a partial upfront payment. So with this, you can get discounts up to 70% of the pricing which is there in pay as you go model, right? So the guys, that's very cheap. So if you have an application where you know the server that you're going to use is going to be there for like 2 or 3 years, then it's better to go for reserved instances where you can opt for taking a server and you'll get huge discounts on using them. Alright. The third kind of pricing is pay less by using more. What this basically means is the more you will be using your instance, for example, your instance, the type of pricing that you get for instance is on a per hour basis, right? The more you will use your instance, the less the hourly rates will become, right? So that's also an awesome feature by AWS which says pay less by using more. Alright. So guys, these were the pricing options in AWS. There's one more pricing option that you get in AWS which is called spot pricing. What is spot pricing or spot instances? Spot instances are basically idle instances which AWS is running, and what it does is it offers it to you in a cheaper price, right? So for example, it's 2 p.m. in the afternoon and I know that the load is less at this particular time. So what AWS will do is it will offer you some instances at a lowered price rate because those are just sitting idle over there, and if you want to use them, you can use them. So what happens in that case is you take that instance and you bid it, right? If you want to take that instance, you'll have to bid amount on that particular instance. The higher the bid amount is, obviously that bid amount will be lower than the actual rates, but the higher the bid amount is, that instance goes to that particular person, right? Now there is a catch in this basically, that if somebody bids higher than what you have bidded, in that case your instance will be stopped immediately and it will be given to someone else who has done the bidding higher. All right, so that's a catch over here, but it could be particularly helpful when you are dealing with workloads which are not that important, but anyways you have to do them, right? In those kind of scenarios, you can take up spot instances and you can just bid a particular amount which you feel you are comfortable in, and in case in future the price goes up, your instance will be stopped, but at least you're getting your work done in a cheaper rate, right? So that's the ideology behind spot instances. So I guess now it's clear with all of you what AWS pricing options you have. Now let me move ahead and let me tell you a very exciting point about AWS pricing, right? The free tier. So the free tier is basically one-time offer that you get whenever you sign up. So whenever you sign up on AWS, if you are using a T2.micro instance, which is 1 GB of RAM and 1 vCPU of computer, in that case, it will be totally free of cost to you, right? So what you do get in a month is 750 hours of usage. So you can launch 4 instances, 5 instances, all of them together collectively can be run for 750 hours. The moment you cross 750 hours, you'll be charged the normal price, but up till 750 hours of server usage, you will be not charged a penny, right? And this is what the free tier is all about. Now it is particularly helpful for people who are trying out AWS or people like us who are trying to learn AWS for our future careers, right? So I'll request you all guys, so whenever you're practicing on AWS, always be under the free tier, because that is literally not going to cost you anything. All right. So the 750 hours that you get are particular to EC2 and RDS. Apart from that, you get some other free tier limits as well. For example, in S3, you have, if you store data up to 5 GB, you will not be charged anything. Okay. Then in DynamoDB, if you have to store something, which is if the instance which you're running is under the free tier, and if you want to store something on DynamoDB till 25 GB, it is absolutely free. Okay, so guys, this is the kind of pricing that you get. These are the kind of perks that you get when you're using AWS for the first time. For more details on AWS free tier, you can just visit the aws.amazon.com official website, and they'll give you all the details. There are a lot of other services as well that they offer free tier in or free limits in. For example, the Amazon Connect service that we discussed, which was basically a one-stop customer support center setup. In that, you get in a month you will get the first 90 minutes of your calling for free. And the way you get charged for that particular service is not on the number of hours that you'd be using that service, but on the number of minutes a customer is speaking to an agent, right? That is how you get charged. That's, I think, pretty cool about Amazon Connect. Alright, moving forward guys, I think we have covered enough of theory. Now let's go ahead and do a hands-on where basically I'll show you guys how to set up your AWS services and how to migrate an application from your local computer onto AWS. So let's start off with our hands-on. So guys, what I've basically done is I have created a website using which we can upload data on S3. Okay, so this is how the architecture looks like. So basically my website can upload data on AWS S3, and that record is also saved in a MySQL database. Now, as of now, this MySQL database is on the local host, and also the website is on the local host. And right now my website cannot connect to S3 because it is not being able to authenticate itself. All right, so this is what we are going to, the first step that we're going to do is we're going to authenticate our website to AWS S3 to upload data. Once we have done that, we will migrate this website onto AWS infrastructure. All right, so without any ado guys, let me first show you how my website basically looks like.
Just a quick info guys. Intellipaat provides online AWS certification training in partnership with Future Skills, mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
So let me jump on to my browser, right? So guys, my website basically exists on localhost/new, right? So this is how my website looks like. The first thing that I would have to do is I will have to check if it is able to connect to a database. So basically whatever I will be uploading, I can view that over here as a list, but right now it cannot connect to the database. So what I do is I'll open up my MySQL on my localhost. Here it is, right? And now what I'll do is I'll create a database called images. So because that is what I have configured in my code, right? And now let me create a table with the name names, and let there be one field called name with the value as varchar, and let us give pretty big value so that any length of characters can fit in this particular table. All right, so it says no database selected. Oops, I'm sorry for that. So use images, and now let's create the table. So when I do a refresh over here, it should be able to connect, but now it will show you an empty list because there's nothing inside my database, right? If you want to show anything over here, it will basically be visible once the entry is made inside the database. Second thing is, right now if I try to upload anything, let me go to pictures and let's say this is the image that I upload. If I click on open and if I click on submit, my file basically will not be uploaded. Reason being, it will say the authorized header is malformed, which basically means authentication is not yet given to my account. Now, how can I give authentication to my website so that it can upload on S3? For that, I'll have to head on to my AWS Management Console, and as we have learned, there is a service called IAM. So I will go inside that IAM service, and over here what I'll do is I will create a user, right? And let's say the username is web demo, and what I will have to give this user is the programmatic access, so that by code this user will be able to access all the services on AWS. Now the kind of services that I want my website to access is only S3, right? So let us put an S3 over here, and as you can see there's a permission over here which is Amazon S3 full access. Let's give this access to this particular user, and let's review it, and let's finally create the user. Once we have created the user, guys, I will have the access key ID and I will have the secret key, access key. Now this is very important for my application to be authenticated. So what I'll do is I will just copy this access key ID. I will go to my terminal. I will create a new page, and this is my access ID, guys, and this is what my secret access key looks like. Okay, so this is my access key, this is my secret access key, and this will be used to basically connect my website onto AWS S3. Okay, now let me show you how my index or how my code looks like, guys. So guys, this is my code which I'll basically use to upload files onto S3. As you can see, the key and the secret key are not filled as of now. So let us fill the key first. So the key is this. Let us enter it over here, and the secret key is this. Right, so once I enter the key and access key, secret access key, my website will now be able to authenticate itself onto S3, and now it should be able to upload objects into a bucket. Right, which bucket are we talking about? Let me quickly show you. So there's a bucket that I've just created on S3, and that bucket name is basically test Intellipaat. So as you can see, there are no objects in this bucket as of now, right? And now what I'm going to do is let me refresh this website. And as you can see, now it says new record created successfully. That is, the image that I chose earlier should now be uploaded over here. So now if I do a refresh, I can see there's one image that has been uploaded. Let's upload one more image for the sake of understanding it. Let's upload this particular image and let's click on submit. So what happens is the moment it takes up a file, it changes the name of the file into a random name, and then it uploads it over here. So if I refresh, you can see there's one more image which just has been uploaded. Now what I can do is I can just go back to my website and I can just click on checklist. So this will give me a list of files which are uploaded onto my S3. If I click on this list, I can basically download the file from S3, and if I click on it, you can see the file. This is what I uploaded, right? Similarly, if I click on it over here, this is the file that I uploaded. Right. Similarly, let me upload one more file so that it's clear for everyone. Let's say I upload. Let us not take an image. Let us try to put something else. So let's say there's this app, this test.jar that I can upload. So let's just click on open and let's click on submit. So this is the file. I click on submit, and now if I do a refresh over here, I should have that file. Okay, so that file might be a little larger in size, that's why it's not uploading. So what I can do is let me take this particular image, right, and let me submit this. As you can see, a new record has been successfully created. If I click on checklist, there is a new image which has been added. If I click on this image, I can clearly see that this is the image that I uploaded. Similarly, if let us try some other file as well. Let's choose a file. Let's try to upload this Excel file. Let's click on submit. And when I do that, a new record has been created. Great. If I check the list, this is the Excel file that has just been uploaded. If I click here, the Excel file is downloaded. If I click open this basically file should now open, right? Great, guys. So I think our website is working fine, but the problem is this website exists on my local host, right? And right now it is basically feeding data onto my local MySQL instance. So if I basically would just do a select star from select star from names. This is the name of the table. You can see that this is all the values that are there in the table, and these are the values that you can see over here. So the first thing that I should do is basically let us deploy a database on AWS through which my website will basically be connected. For that, I will be heading on to RDS. Since this database that I'm using is MySQL, let us try to deploy a MySQL database on AWS. So for that, I will be clicking on create database. and the type of database that I want is MySQL. Let's select that, and now let's click on next. Next, I want to create a dev environment or test environment because this is just a POC. So I've selected this and I'll click on next. Next, I can select the MySQL version. So let it leave it at default right now. And I want to enable only options which fall under the free tier usage. Okay, so let's select this option. And everything is filled automatically. Let's identify our DB using a name. Let's say it's web-demo, right? The master username, let's say the master username is Hemant. Let's specify the master password as well. And now let's finally click on next. Right now it'll ask me which VPC do I want to put my instance into. So I have the default VPC where my instance is being launched in. That's great. Second thing is public accessibility. Do I want internet to be able to access RDS? So yes, I want public accessibility to be enabled. If I select no, in that case, there will not be any public IP which will be assigned to my RDS instance. Only the VPC in which my RDS instance resides in, only the instances launched in that particular instance or in that particular VPC would be able to access that RDS. So when I say VPC, it's basically a virtual private cloud, or it's basically a virtual network, right? So if I do not give public accessibility to my RDS, then it will only be able to connect to machines which reside in that particular network on which it is being deployed, right? Not on the internet. Okay, so but because our website right now is in my local host, from local host I should be able to upload data onto the database of AWS. So for that I will need public accessibility, right? Do I want to create a new security group? No, I don't want to. Let us select the default security group. Okay, what should be the database name? So the database name would be the same that I've given for my local MySQL instance, which is images. Rest you can just leave at default. Backup, I don't want any backup, so let's select 0. And disable monitoring, we don't want that. We don't want any upgrades made to my database, right? And I think that's it. Now let's finally click on create database. Now guys, the database instance, it takes around 3 or 4 minutes to create. Meanwhile, while this database is being created, let me tell you the next step that we have to do. Now, since this website exists on localhost, I want this website to be existing on basically AWS. I want this website to be uploaded on AWS. And for that, let us use Elastic Beanstalk, which is the platform as a service on AWS, right? So let's open the AWS Management Console, and now let's head on to Elastic Beanstalk. In Elastic Beanstalk, you can basically upload your website, and I'll show you how you can upload your website, and you don't have to configure anything on the instance. Every software, everything will be configured by Elastic Beanstalk itself. So as you can see, when you reach this page, you just have to click on Get Started, and now it'll ask you the application name. Let's say the application name is web-demo. Right? What platform is my website based on? So it's based on PHP. Do I want a sample application to be deployed previously? Yes, I do. So I'll just click on create application now. So guys, this will basically create a web app for me in Elastic Beanstalk. We have done this earlier as well. We're doing it once more so that we can upload our own website onto this particular Elastic Beanstalk application. Okay, so it'll again take guys 3 to 4 minutes for Elastic Beanstalk to get deployed. Meanwhile, let's check if our RDS is ready. I'll just head on to RDS. I can see there's an instance which is running. So it is still in the creation phase. So once the creation phase is over, you would be able to get an endpoint over here. So an endpoint is basically a URL through which you will be able to connect to your database. All right. So let us wait for this database to be ready. And once it is, I will try to connect to this database from my localhost and see how that goes. All right. So it's in the creating phase. Similarly, my Elastic Beanstalk is also being created. Let me show you my code, guys. Let me explain you my code a little bit, right? So this is my main file. So in this file, basically, I am using the PHP backend language on which I have basically imported the AWS SDK, right? This SDK, you can basically just Google AWS SDK for PHP and you would be able to download it. Now I have included this particular folder in my root directory of my website, which is over here. So this is the folder which has all the libraries, right? and my index.php will basically has included this particular library, and then the service that I want to connect to is S3. So we are using the libraries of S3 over here, right? My bucket resides in Oregon region. The code for that is US West 2. This is my key. This is my secret access key. Don't worry guys, I will be deleting the user account, so don't try using these keys. They will no longer work once I have the username deleted. Apart from that, it's pretty simple. It's a very straightforward code, guys. Right now, the database that I'm connecting to is on localhost. That's why the server name is localhost. When I would want to connect to my RDS instance, all I have to do is change this server name to the endpoint of RDS, and then it should work like a charm. Right, that's it. This is my index.php. My list.php, where I get a list, is basically I'm just connecting to that same database which exists on localhost, and I'm trying to read everything from the table. This is the field that I'm reading. On the front of that name, I'm attaching this URL. So this is the URL for my bucket, and this remains the same for each and every object which gets uploaded. Right, so I'm uploading, so I'm attaching this along with the name, and this I am basically storing in an ahref tag, which basically gives me a link on my website. Right, so if I can show you over here, as you can see, this is a list, right? And this is the link. So this link is basically a ahref link in which I have embedded this URL with my file name. All right, so once I've done that, it works great. It works like it is supposed to. Now I guess we should go ahead and check if my RDS is ready. Yes guys, so my RDS is now in the available state. So how do you connect to RDS? There will be a database which has been created on my RDS, but still the table is still not created, right? So first I'll have to create a table on this RDS instance, which would basically be exactly the table like what I have on my localhost. So how do I connect to my RDS? So just copy this endpoint, guys. And now you'll have to go on to CMD, right? So once you are on the CMD, guys, the next step is to go to the bin directory of your MySQL installation. So my MySQL installation is basically in WAM64. So I'm going to go in there, right? So I'm inside the bin directory now. Next thing would be that I will have to call in MySQL. -h would be the host name. The host name in my case is the Amazon's host name, which is this. The username for this RDS instance, it's Hemant. And the password is this. Let me specify it over here. Let's hit enter. And now, if everything has went well, I should be able to connect to my RDS instance. Let's wait.
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which one of the following is cloud platform by Amazon? A. Azure, B. AWS, C. Cloudera, D. All the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So while this is happening, guys, if it gets stuck like this, it could be that you're not able to connect to your instance, and the reason for that could be in the security group. So you'll have to check if the inbound rules for their security group are open to accept traffic. So let's click on inbound, and yes, so this is the problem over here. It's allowing all traffic, but it's only allowing to this particular security group. So what I'll do is I'll make it anywhere and I'll save it. Once I do this, let us come back here and try to run the command again. I'll enter the password and hit enter. So as you can see, I have successfully connected to my MySQL instance, which resides on AWS. Now this instance should have a database called images. Let's use that. And now let's create a table which would be the same as what I did on my localhost. So the table name would be names, and the field name would be name, and the type of information that can go in is varchar. Let's specify that. Okay, so my table is now successfully created, guys, and now my database is ready to basically take in data. Now what I'll be doing is let us go back to RDS and let's copy this endpoint, and now let's make our website maybe be able to basically interact with my RDS instance. So it's pretty simple. Just change the server name to the endpoint of RDS. The username in my case is Hemant, and the password in my case for my RDS instance is Hemant1994. Alright, that's it guys, that's all we have to do. And let's save this code. Similarly, in my list, I will have to change the values from localhost to these variables. I'll save it. And now when I go back to my website, let us open the local MySQL instance also. So this was my local MySQL instance. As you can see, there are only 4 entries over here, right? Now let's choose a file. Let's try to upload the same XLXX file, the Excel file that is, and let's now click on submit. So it says new record created successfully, but let us check here if this is where my data has been entered. So no, my data has not been entered over here. Let us check on my RDS if my data is being entered correctly over here. Select star from names. So yes, a data has been entered over here with the this particular name. And if I click on checklist, as you can see, even here I get the same value. So you can compare that this is the name that I'm getting over here and this is the name that I'm getting on my website. If I click here, I'd be able to download that Excel file successfully. Great guys, this is what I wanted. So now my website is basically connected to my database instance on AWS. It was that simple. Now the next step is basically to put this website on AWS for good so that everybody in the world can access it. Now how can I do that? This is my Elastic Beanstalk guys, and this is the dashboard that I get when I use the platform as a service instance, right? Now it says here upload and deploy. So that's what I'm going to do. I'm going to click on upload and deploy. And now it's going to ask me to choose a file. Now the way you can upload your website over here guys is you will have to go to your website codes, right? And then you will have to zip these files like this, right? So once the files have been zipped, this zip has to be uploaded over here. So I'll choose a file. Let me go into that folder where I have the zip. Here's the folder. Let's click on open. Version label, let's try to give this version label as 1.0. Okay, and now let's click on deploy. So now my website is now getting deployed to AWS Elastic Beanstalk. It will hardly take some 2 or 3 minutes for my website to be ready on this particular platform. And once it is, we'll be able to use it via this particular link. This link will basically be my application now that I've shown you on localhost. This will now be available on this particular link. So let me close all the unnecessary windows. And now let's wait for this to be ready. Okay, so it will take around 2 to 3 minutes, like I said, and whatever version that I've specified, that version will now be reflected over here. Okay, so it would be AWS 1.0. So let's say in the future I make change to my code, any kind of change to my code, I would be able to upload it over here in the same manner possible. That is, I will have to click on upload and deploy, and then I will have to increment the version. I will show you that as well. Let this complete and then we will go ahead and check. So as you can see, my running version is now AWS 1.0. Great. So this is what I wanted. Now it's the moment of truth. Let's try to go to this URL and see if our website is working or not. So great guys, my website is now available on this particular URL. Let's try to check if it is able to upload everything. So let's first check a list. So we have one file which is there in my database which is uploaded. Now let's choose a file. Let's try to upload the zip file itself, right? I'm not sure if it will be able to upload. Let's check. So the uploading has started. It says new record created successfully. Awesome. Let's go here. Let's refresh this. As you can see, a new entry has been made. Let's try to download this. So as you can see, the zip is being downloaded. And if we go to our S3, if we refresh over here, you can see the zip is present over here as well. And my zip is also downloaded. If you want to verify if all the contents are fine or not, let's do one simple step. Let's create a new folder here, right? And now let's try to paste this extract over here. It will extract all the files. Click on OK. So all the files are now being extracted. Let's do a Control X and let's paste here. Let's delete these files. So basically on my localhost hello, there should be a file. My website should be up and running. So localhost/hello. So as you can see, I can see my website over here, and if I do a checklist, if I do a list.php here, I should be able to see even the list. So that means these files that have now been uploaded to S3 are working correctly. And also I have successfully migrated my website, which is there on my local host, onto Elastic Beanstalk without even going to the terminal, without installing any software on the server, right? It is now up and ready, and anyone who will visit this particular URL will be able to access my website. Okay, and as simple as that, guys. And it's basically hosting my files as well. My files are now all available on this particular link. So anywhere in the world, if anybody would go to this particular link, they will be able to access these files. They just have to click on it and they'll be able to download it.
What is Amazon VPC? So guys, Amazon VPC is basically a service. It's basically a virtual private cloud, which is given to us by AWS when we deploy resources on its cloud platform. And what this Amazon VPC basically enables us to do is basically launch AWS resources into a virtual network that we define, right? So VPC is basically a virtual network that we define. This virtual network can have multiple subparts as well. It can have multiple configurable properties as well. And the whole service is called Amazon VPC, right? Now, the definition is not that important, but the working is the most important for Amazon VPC, through which you will be actually able to understand what you can accomplish and what all is possible when you are basically making use of the Amazon VPC service. So let's go ahead and understand how Amazon VPC service basically work. So guys, this is the skeleton diagram for Amazon VPC, and you can imagine how you can basically, how internet basically works at your home system or in your office system by looking at this diagram. So what basically happens is, first there is the internet, right? So you are first always on the internet, and from the internet, there is a request which comes in. So let's say you are at your home system, and if somebody has to, reach out to your computer, let's imagine it like that. How will it work? So first you have the internet, and from the internet there will be a request which will come in. Now in AWS, what happens is, like I said, you have a virtual network that you create. So first of all, any resource in AWS that you create is enclosed inside a virtual network. It could be EC2, it could be any databases. So it has to be enclosed inside a network, right? So we will have this network. Let's say this is the network of ours, which is called the AWS VPC service. And any network or any internet connection which has to come inside this VPC service will have to come in through something called as a internet gateway. Okay, so when you create a virtual network, for that virtual network to have internet access, you basically need to create a resource called internet gateway, and this internet gateway is going to be a single point through which internet requests are going to go out, and internet requests are also going to come in, right? So the internet can basically be accessed using the internet gateway, and whenever a request is coming in through the internet, the first place that it goes to after the internet gateway is to a resource which is called routing table. Now what is a routing table? Now when you create an AWS network, what happens is you also have something called as the subparts of the network, or sub networks, let's say, right? So let's say you create an AWS network, and in that AWS network you create two subparts which are basically called subnet 1 and then subnet 2. So these two subnets will have their own resources inside it. So let's say in subnet 1 you have a database which you have deployed, and in subnet 2 you have a EC2 machine or a virtual machine that you have deployed. Okay, now let's say if the internet has to reach to this machine which is there in subnet 2, the way it is going to work is, first the request is going to come in from the internet gateway. From the internet gateway, now the request does not know how to reach the machine. So what it will refer to is basically something called as a routing table. So in the routing table, basically you will have all the details with respect to which how can you reach the resource? So this resource will basically have a private IP address, right? And this private IP address can be reached out to using the routing table, right? Or in other words, you can also imagine it something like this, that how will the internet gateway know about these resources? The internet gateway knows about these resources when it is basically a part of the routing table. So when the routing table is visible to the internet gateway, then these resources are also visible, right? And from the routing table, basically you reach the subnet 2, and in subnet 2 you have that resource. Okay, so this is a skeleton of what AWS VPC is. First, the request comes in through the internet gateway. The internet gateway refers to the routing table, and from the routing table you basically go through the subnet where you have the resource, and from the subnet you go to the resource. Okay, now there are something called as firewalls in this architecture. Now you will ask, okay, you just told us that the request just comes in, so how is it filtered? So that filtering process happens using firewalls, and there are two kinds of firewalls in VPC. The first firewall is called NACLs, right? And this network access control lists, these are called, and these basically operate at the subnet level. That means that there is a firewall at a subnet level, and there is a firewall or the instance level, which is basically, or the resource level, which is basically called security group. So there are two levels of firewalls in a VPC network. Okay, so that basically means that when the request is coming in, there is no filter which happens on the AWS VPC level. The only filter which happens is on the subnet level, which is the network ACL. Okay, from the network ACL, if the request gets filtered, then it basically goes to the security group of the resource. So if I were to include these two firewalls in the diagram, it can be imagined something like this. That first the request will come from the internet. From the internet gateway, it will look for the instance that it has to go to in the routing table. From the routing table, once it gets to know where the resource is, it will go there. And in the subnet, it first has to basically go through the first level of firewall, which is the network ACL. From that firewall, it then goes in if the request is filtered out. And when that request is filtered out, then it encounters another firewall, which is basically called a security group. And if it filters that out, then only it is able to access the resource. Okay, so this is the flow diagram of how a request flows in a VPC. And now what I'm going to show you guys is basically how to create this kind of an architecture in AWS, right? So what we're going to do is I'm going to quickly jump on to my browser and let me open AWS Management Console. All right, guys. So first you have to basically go to aws.amazon.com, and on aws.amazon.com, you basically will sign in, and this is where you will reach your AWS Management Console. Now, on the AWS Management Console, what we have to basically work with is virtual private cloud, and let's try to now create the architecture. So this is how our architecture looks like. So first, what we'll do is we'll create AWS VPC, right? So let's go ahead and create a VPC. So we'll click on VPCs, we'll click on create VPC, and whatever I've explained to you guys, we will try and test it out by doing the hands-on. So that is what we are going to do. Okay, so first let's name our VPC something. So let's call it VPC demo 1, let's call it that. And now let's give it a IP address range. This IP address range will basically mean that all the resources in this VPC are basically going to have an IP from this particular range, which you are now going to define. So let's go ahead and define a range. Let's say it's 192.1.0.0/16, right? Let's say this is the range. And now we'll basically go ahead and click on create VPC. So our VPC has now been created, and what we have done is we basically went ahead and created a simple network. We have not defined any of these resources as of yet, right? We have just created an empty box, which is our AWS VPC. Now, whenever you create a VPC, guys, what happens is automatically when you will go ahead and create subnets, it will automatically create some resources, and I will tell you that. So right now, these subnets are of some other VPC that they are not of the VPC that I created, right? So what I'll do is I'll go ahead and create two subnets, which is subnet 1 and subnet 2. So let's go ahead and create that. So let's click on create subnet. Let's call it subnet 1-demo. And the VPC obviously is going to be VPC demo 1. This is the one that I created. Now, this subnet can be deployed in 3 availability zones. These are basically different data centers that AWS has in the region that we are working in. Let's deploy it in the first data center, 1A, right? And now we have to specify an IP range, which is basically going to be part of the main range, which is there of the VPC, right? So let's specify a range 192.1.1.0/24. So this is going to be the range of the subnet that we are basically creating right now. So we'll click on create. And now the VPC 1 subnet 1 has been created. Similarly, we'll create one more subnet. Let's say it's VPC 1 subnet 2. Right, the VPC is going to be VPC demo 1. This time, let's say the data center is going to be of 1B, right? And specify the IP range as well. So this is going to be the IP range. Okay, let's click on create. Okay, so my second subnet has also been created. So if we refer to our diagram again, so we basically created a VPC. We created 2 subnets, and now let's create the routing table. Okay, now right now I have not created any routing table, but if you go to your routing tables, you will be able to see that this is your VPC's routing table. As you can see, it's VPC-demo1, and this is automatically created. Okay, so this is whenever you create subnets, a routing table is automatically created. And this routing table, if you want to look, what subnets it is basically associated to, so you can just click on subnet associations. It is not, basically created by, or it is not basically connected to any subnet as of now, right? So a routing table is automatically created, and why is it created? Let me show you that as well. So if you go to routes in this, you will basically see that there is already a route which has been added, which basically says that all the IP address from this range can basically talk to each other in this virtual network. So this is the default rule, which basically says that if I deploy this resource and if I deploy this resource, they can talk to each other. Why? Because that is the default rule which is present in the routing table. Okay, so these two will be able to talk to each other. Why? Because this rule is present, and this rule is by default, and this rule you cannot delete as well. Okay, so this is one thing. Now what we want to do is, since these two subnets can talk to each other, but they cannot talk to the internet as of now. So that is something that we are going to configure. But how does the routing table know that which subnets can talk to each other? Okay, so for defining that, what you'll have to do is you'll have to click on subnet associations, click on edit subnet association, and include these 2 subnets over here. So when you do that, now this routing table says that both these resources can talk to each other via the routing table. And now what we want to do is we basically want internet to be available in this routing table as well, right? So we are going to configure that, but right now let's not configure the internet, and let's see what will be the behavior in case we don't add the internet, right? What we are basically going to do is let's go ahead and define the firewalls now. So let's first define the network ACL. So again, in this case, if you go to NACL, this is basically the subnet level firewall. So over here, you can see there's already a network ACL which is created for VPC demo 1, right? So this is also created by default. And if you look at the inbound rules or the outbound rules, so what is this firewall saying? That all traffic is right now allowed. So anyone who wants to have access inside this subnet, inside both the subnets, because both the subnets are associated to this NACL or this firewall right now, all traffic is enabled to all the subnets in this particular network. Okay. Similarly, if you look at the outbound rules, you can basically request anyone on the internet from within these two subnets. So that is what our network ACL is right now saying. Okay, so we're not going to touch that. So let's move on to security groups now. And when we move to the security groups, over here as well, you will be able to see that there will be a default security group which will be created, and which VPC is ours, we can basically make out by looking at the IDs, right? So our VPC is of the ID 69D, right? So that's what we have to look out in the security groups. So we'll go to security group 69D, right? This is the VPC ID of us, and this is the security group that is basically created by default. So let's name this as default security group or default demo 1. Let's name it that. So this is our security group which has been created, and if you look at this security group's inbound and outbound rules, they are going to be very limited, right? So all traffic is allowed, but it is only allowed from within the resources which are connected to this security group, right? So we can change this if we want. So we want anyone to be able to go through this firewall. So I'll just specify anywhere, and we'll click on save rules. Okay. So now what we have done is we have opened both our firewalls, that is the subnet level firewall and the instance level firewall, right? One last thing that we should do before we can go ahead and deploy these resources inside these subnets is basically to tell these subnets that these resources can have public IP addresses. Okay. So how do we go ahead and configure that? So just select your subnet. So let's say this is subnet 1 demo 1 that I have basically went ahead and selected. So what I'll do is I'll click on actions, click on modify auto assign IP settings, and here I will say auto assign IPv4 address. So by this, now what is going to happen, that any resource that I'm going to create inside this subnet, it is automatically going to have an IP address. Similarly, I'll do that for my subnet 2 as well. So let me specify the name correctly. This is subnet 2 hyphen demo 1. And in this, again, I will say that basically any resource which is deployed in this should have a IP address, a public IP address. Okay, all set. So now what we have done is we have not configured the internet gateway yet, but we have created a network. Inside this network, we have a routing table, and this routing table has a default rule, which basically is allowing both these subnets to talk to each other. We have created this firewall, which is allowing all traffic. We have created this firewall as well, which is allowing all traffic. Okay, so let's go ahead and test this architecture out. So what I'll do is I'll go to EC2, and now I'll basically go ahead and launch two machines, one in subnet 1 and the other in subnet 2. Okay, and there is a behavior that I want you guys to notice. So first I'll go ahead and create an Ubuntu machine. I'll create a t2.micro, which is basically going to be a part of VPC-demo1, right? It is basically going to be in, let's say, subnet 1. And other than that, everything can be left at default. In the security group, we are basically going to configure or select the default security group that we created, right? And now let's go ahead and click on review and launch. So now what we'll do is we'll basically select a key that we already have. So I'll select Mac-Mumbai. I already have this key, and I'll click on launch instances. So with this, I have launched a machine in Subnet 1. Now I want you to notice something. This is Subnet 1 machine, and this is being deployed. While this is being deployed, let's deploy the second machine as well, which is again going to be an Ubuntu machine, t2.micro. It is going to be a part of our demo 1 VPC. It's going to be in Subnet 2. Going to be a part of the default security group. Let's review and launch. It's also going to have a key pair, which I already have. And now this machine is also launched, and this is going to be a part of Subnet 2. Now, what is something that I want you to notice? So first of all, this will have an IP address because we specified in the subnet that the machine should have an IP address. But now if I try to connect to these machines, you will see that I will not be able to connect to them. So if I open my terminal really quickly, and let me try to go ahead and connect to these machines. You will see I will not be able to connect to them. It will basically give me a connection timed out kind of a request. And the reason for that is because I am on the internet, I'm trying to connect to these resources, but this internet gateway is not there. Right? This internet gateway is the only way that this VPC will be able to talk to the outside world. Okay? And because it is not there, you will see I'm getting a connection timed out kind of a thing. So how can we fix this? So now let's go back to our VPC console and let's go ahead and create something which we call as an internet gateway, right? So we'll go to VPC.
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which one of the following cloud concepts is related to sharing and pooling the resources? A. Polymorphism. B. Virtualization. C. Abstraction. D. None of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Inside VPC, we will go ahead and go to Internet Gateways. And in this Internet Gateway, I'm going to create this. This is a default Internet Gateway which is attached to the default VPC that we created. And what we're going to do is we're going to create one more Internet Gateway. Let's call it IGW Demo 1. Right? And let's create it. Once it has been created, what we'll do is we will attach it to our VPC. So right now it's in the detached state.
Just a quick info, guys. Intellipaat provides online AWS certification training in partnership with Future Skills, mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
So I'll have to do and click on Actions, click on Attach to VPC, and attach it to VPC-Demo 1. Attach it. So it's attached. So now that it's attached, guys, we should be able to see this internet gateway in our route tables, right? So if I go to my route table, so this is my route table. This is the demo 1 route table, right? So if you go to routes, we can click on edit routes, and now we can add a route for the internet gateway, which is IGW-Demo 1. We'll add that, and the whole internet can be accessed using this internet gateway. We'll click on save routes, and now if we go ahead and try to run the same command, you can see I'm able to connect to my machine. Isn't that great, right? So now, since we are able to connect to this machine, we should be able to connect to the other machine as well. So let me connect. And let's go to our second machine's IP address. So this is a subnet 2 machine. Let's connect to it. This is the IP address. All right. So now, as you can see, I have successfully connected to these two machines. And now let's see if these two machines are able to talk to each other, right? So how can we check if they're able to talk to each other? So if we try the public IP address, obviously they will be able to talk to each other because this is going to be via the internet. But what we want to see is whether they can talk within the network. And for that, we are basically going to make use of the private IP address. Okay. So this is the private IP address of subnet 2. So what we are going to do is from the subnet 1 machine, I'll try to ping subnet 2. And as you can see, I'm able to ping the machine in subnet 2. Why? Because in the route table, we have that entry wherein they're able to talk to each other. Great. So now let's try something out. So what we can do is we can go to, since subnet 1 is able to talk to subnet 2, let's go ahead and go to network ACL. That is basically the subnet level firewall. And there, let's try something out. So we'll go to VPC. And in VPC, we will now go to network ACLs. So let's create a new network ACL. It will basically be subnet 2-demo1. And this is going to be a part of VPC demo 1 VPC. Right, and let's say this is for subnet 1 and this is for subnet 2. So in this, what we can do is we can remove the subnet. Let's remove the second subnet. Let's say in this subnet, I go ahead and I specify that only network connection from subnet 2 is possible from subnet 1, but subnet 1 from subnet 2 is not possible. That means that let's say only this machine can ping to machine 1 and machine 1 is able to ping to machine 2. Now, how is that possible? I will just specify that all traffic from machine 2 is allowed, but from machine 1 is not allowed. So we'll specify something like this. So 1 second. Okay, so I basically just have to add /20 over here, save it. Okay. So now what I've specified is that only subnet 2 is able to ping into the network ACL. Now, what does that mean? That basically means that if somebody is trying to go ahead and ping subnet 1 to subnet 2, it should not be able to do it. Let's try it out. And now you can see, since I have edited the network ACL, I am not able to use these machines from my personal system as well. And the reason for that is now the subnet is not allowing my machine as well to connect to these machines. Okay, so let me make you understand that using the diagram over here. So what we did is basically these firewalls, these subnet level firewalls, have only allowed connection from machine in subnet 2. Only this IP address I have added in this firewall. Now, because of that, what is happening is from the internet, I'm not able to reach this subnet. Why? Because this firewall is blocking me. So I'll not be able to SSH into this machine now. Okay, so let's try to change what we were doing. Let's again go back to network ACL. So I'll go to VPC and we'll again click on edit inbound rules. We can again make it 0.0.0.0/0. Save it. And now again, if I come back to my terminal, I should be able to connect, right? Similarly, I should be able to connect over here as well. Okay, so instead of, let's say, changing the subnet level firewall, let's go ahead and change the security group firewall, right? So in the security group firewall, what we can do is we can tell that only my machine should be able to ping it, right? And then only subnet 2 should be able to ping inside it. Subnet 2 machine should be able to ping inside it. So how can we do that? Let's go to security groups. So our security group is this one, 69D. So let's go inside it. Click on edit inbound rules. And all traffic is allowed only from my IP. This is my machine's IP. And only from, let's say, I want to go ahead and allow only subnet 2 to be able to ping inside it. Subnet 2 machine to be able to ping inside it. Okay, let's click on save rules and let's see how this is going to work now. So now in this case, my SSH is going to work perfectly fine, right? So if I will try anything over here, it will work perfectly fine. If from my first machine, I try to ping machine 2, let's see what happens. So according to the rules that I have configured as of now, if I try to ping subnet 1 to subnet 2, according to the rules that I've configured, it should not connect, right? But let's see if our assumption is correct or not, and then I'll explain whatever the behavior is happening over here. Can you see we are not able to ping the first machine, that is subnet 1 machine to subnet 2 machine? Okay, this is the subnet 2 private IP. This is not able to ping, or on the diagram, this machine is not able to ping this machine, right? And why is that so? Because in the firewall for these machines, what I've configured is that only this machine, the subnet 2 machine, can go ahead and ping the other machine, or only this machine's IP address is allowed in the firewall and no other machine can ping, which basically means if I go ahead and go to my second instance, and if I try to ping the first machine, I should not have any problems. So if I select subnet 1 machine over here, select the IP address from here, come back, set the IP here, hit enter, you can see the ping is working, right? And why is that so? Because in these security groups, I have specified that only my subnet 2 machine connections will be allowed. So if I go ahead and change this, if I go ahead and make this 192.1.0.0/16, if I make that to basically work, now what will happen? So let me just verify if this is a CIDR range. Yes. So this is a CIDR range for all the instances or all the resources in this VPC. If I click on save rules now, you can see that this ping now again started to work, right? Why? Because this particular rule is now allowing everyone inside the VPC to be able to ping each other, right? And hence this ping started to work. Again, if I go ahead and if I change it to, let's say, only subnet 1 machine being able to ping each other, then it will be a different story. Just give me one moment. Okay. All right. Okay, guys. So now if I go ahead and change this to only subnet 1 machine's IP address, what is going to happen then? In that case, only subnet 1 machine will be able to ping subnet 2 and the other way will not be possible. So if we save the rules, so now you can see both of these are working, right? So let me clear the screen once more and let me start this command. Right? So now if I go ahead and save the rules, you will see that this is going to stop now in a few moments. So what we have now added, that we have added that only subnet 1 will be able to talk. So if we try this out. So subnet 1 connections are allowed and subnet 2 connections are not allowed. So if I try to ping from subnet 2 to subnet 1, this should not be allowed now. Can you see? The ping has now stopped. And why is that stopped? Because we have changed the firewall rules so that only one machine should be able to talk to each other. All right. Great. So guys, I hope this particular diagram is clear. So what we have done so far is we have created a VPC. We created 2 subnets. These 2 subnets, we basically had a routing table associated with it, which is created by default. This routing table did not have access to internet. So we created an internet gateway and we included that internet gateway in the routing table. And then we were able to basically access both the subnets from the internet. All right. Then we went ahead and configured the 2 types of firewalls that we learned. First, the network, the subnet level firewall, and then we try to configure the instance level firewall. Right now, let's go ahead and understand the different kind of subnets right now. So the only thing that we understood is that we could create 2 subnets, But there can be two types of subnets which you can basically go ahead and create. The first subnet is basically called a public subnet, and the other subnet is basically called a private subnet. So a public subnet is a subnet which can basically be accessed by the internet, and a private subnet is a subnet which cannot be accessed by the internet. Now, what do we mean by that? So right now, both our subnets are being able to be accessed by the internet. But what I want is only one subnet should be able to be accessed by the internet, and the other subnet should not be able to access by the internet. Now, how is that possible? So it is possible using an architecture like this. So what we are basically going to do is we are basically going to have two subnets. We are going to have an internet gateway, but from the main routing table, we are going to not associate that routing table to our subnet 1, right? We are going to create a separate routing table for our subnet 2, right? Which is not going to be associated with the internet gateway. So all in all short, in the first routing table, the main routing table, we are going to remove the subnet 2, and we'll only have subnet 1, which is basically going to access internet. And we are going to create one more routing table so that our second subnet can associate with it and then be able to talk to the first instance or the subnet 1 instance. Okay, so let's go ahead and implement an architecture like this. So what we need to do in our existing VPC is, here nothing will change. Subnet level, nothing will change. In the routing tables, what we're going to do is, this is my demo 1 routing table. Let's say this is going to be my public routing table, since this already has the internet gateway attached, right? Let's create one more routing table. Let's call it as demo 1 routing table, but this is private. Okay, and this will be associated to VPC demo 1 VPC. Let's create it. Okay, this is created. Now in the demo 1 public routing table, we are basically going to go ahead and edit subnet associations. And I want to remove subnet 2 from over here, which is this. Let's remove this. So only subnet 1 I want to associate. So I'll just click on save. So now only one subnet is associated, which is subnet 1, which basically means if I try to access my instances, now let's try to SSH. This is subnet 1. Let's try to SSH into it. This is working perfectly fine. Net, save it. Okay. And now you can see that this instance has stopped working. I can just quickly go ahead. And try connect to the subnet 2 machine, which is this IP. You can see I'm not able to connect now, right? And why am I not able to connect? Because for my second subnet, it is now not having any route for the internet gateway, right? But for my first machine, it is having a route for the internet gateway. So that's why if I exit this and try to connect again to my first machine, the subnet 1 machine. I'm able to connect, but for this machine, it is giving me an error now, or it is not connecting. Why? Because this machine no longer has internet access. Okay, but what we can do is we can try connecting to this machine, the subnet 2 machine, from within the VPC, which basically means that if I come back to my diagram, okay, so in this now what is basically happening is that from the internet, I am from the public route table, I'm able to connect to subnet 1 machine, but from the internet I'm not able to connect to subnet 2 machine. So what I can do is and observe the reaction over here, that I will be able to go inside this VPC and I will be able to connect to subnet 1. From subnet 1, I will be able to connect to this machine. Right now, from this machine, I can basically go through this route table and then connect to this machine. Do you understand this network architecture? Right? So from this route table, obviously I cannot connect to this subnet because this route table does not have any details regarding this particular subnet. Okay, but this particular route table, the private route table, has basically allowed connections between these two subnets, and because of that, what we can do is we can basically go ahead and connect to this machine, and from this machine I can SSH into this particular machine, but it obviously has to be using the private IP addresses. Okay, so let's try that. Let's try that over here. So what I'm going to do is, first I need on my subnet 1 the key pair. So let me go ahead and copy the key pair. So I'll just go ahead and copy the key pair on this machine. Done. Let me again go inside it. So I'm inside the first machine now, and I have this key pair over here. Let me give it the required permission. It has it. And now let's try to go inside the second machine. And that we will do now using the private IP. And as you can see, I'm inside the second machine now. So you can see the IP address is 192.1.2.96. This IP address is 192.1.2.96. However, if I try to go through the public IP address from my machine into it, I will not be able to do that since there is no internet connection. But because there is a possibility, or there is a connection between this machine and this machine, I'm able to SSH from this machine into the subnet 2 machine. Okay, and that is what we have just done. Great. So now we saw how to create a machine with no internet access, and I can show you guys that there is no internet access. So since this is subnet 2 machine, if I try to curl google.com, you can see there is no response, right? It basically just hung. Why? Because google.com is not reachable. However, if I go back to my subnet 1 machine, so I have just exited the SSH of the second machine, and I'm now inside the first machine. As you can see, the IP address has changed. So if I go over here and try to do curl google.com, you can see that I'm able to see some content from the internet. But in this case, I was not able to see any content. Why? Because the second machine does not have internet access and the first machine has internet access. Now, in what cases will it be beneficial? It will be really beneficial in cases wherein the, let's say in Subnet 2, I have a resource which I do not want anyone from the internet to be able to access. Okay. Why I don't want that? Because probably it's a very critical machine for me. I don't want this machine to be hacked in any sort of way, right? So that's why I do not want anyone from the internet to be able to reach it out. So in that cases, what we do is we create private subnets, right? Now, there is a use case wherein probably somebody from the internet should not be able to reach out to this subnet, but from within the machine, if the machine wants to access internet, that should be possible. So how can that be achieved, right? So that can be achieved, giving internet access to private subnets, that can be achieved using something called as NAT gateways. So what are NAT gateways? NAT gateways are basically resources which help private subnets to use the internet. Now, how does it help it? By basically giving a proxy connection to the internet gateway.
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which one of the following is cloud platform by Amazon? A. Azure, B. AWS, C. Cloudera, D. All the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So what's going to happen is, it's basically going to help us connect to the private or the public subnet, and from the public subnet, we will be able to access the internet. So basically, you can imagine it like this, that a NAT gateway is going to be a machine which will be deployed in the public subnet, and our system is going to ping that machine to access the internet, right? So that is what a NAT gateway is. So how can you create a NAT gateway? You can basically just go to the VPC menu, and then you can go to something called as NAT Gateways. Here it is. And you can click on Create NAT Gateway. Let's call it demo1 -NAT. Which subnet do you want it to be used in? We want it to be used in subnet 2. And subnet 2, it needs an elastic IP to work. So let's allocate it. So it has to be, it has to be associated with a public subnet, because this has to be deployed in a public subnet. And then we will try to reach out to this NAT gateway from our private subnet, right? So we will deploy it in subnet 1, which is basically having internet access. And then we are going to click on Create NAT Gateway. And now what is going to happen is, basically it is going to create a machine in the public subnet. And this machine, we are going to reach out from our subnet 2 for internet. Okay, so NAT gateway was created successfully. So if you can see, the state is pending. It will take some time to get deployed. So let's give it that time. You can refresh. State is pending. So now what we need to do is, once it is deployed, we can go to route tables. We'll go to a private route table, go to routes. And now we can just click on edit route. So now what we want to do is, we want to add a route to the NAT gateway so that they can connect to each other. So we'll click on add route. We will give all connection to what? To the NAT gateway. And since it is being deployed, it will take some time. So let's give it that time. If we go ahead and again check our NAT gateway. Still in pending state, it will take some time. So it usually takes around 3 to 4 minutes to deploy. So let's give it that time. Because like I said, this is a machine which is launched, right? So this machine is launched and the software is deployed on it. So it takes some while to get deployed. And once it is deployed, you will be able to see it in your route tables. So if we look at the details for this NAT gateway, you can see that this is the private IP address for this NAT gateway. Oh, I think we have deployed it in some other VPC, guys. We have deployed it in custom VPC. Sorry for that. So we'll have to click on create NAT gateway, NAT-demo1, new, and this has to be okay. This has to be a part of 69D. This is the one. So we basically connected to VPC subnet 1. This is some other subnet that I created earlier. We basically wanted to connect it to subnet 1 demo 1. This is our VPC, right? This is the public subnet for us. And let's allocate an IP address. Click on create NAT gateway. Okay, really sorry. So I selected the wrong VPC in this case. So this is the one which is being created now. So you will see that this failed. So why did this fail? This failed because in the custom VPC that there is one more VPC which exists, right? So there is no internet gateway which is connected to that particular VPC, and that's why it failed, right? But if we see ours, it will basically get deployed in some time. So if we select the details for this NAT gateway, now let's verify if everything is correct. So the VPC-demo1 subnet is subnet 1-demo1. This is the IP address. So this IP address is according to the CIDR range of subnet 1, which is again correct, right? Okay, this looks good. Okay, so as you can see, the NAT has been created now. And now if I go to route tables, if I go to the private route table, click on edit routes, click on add route. Here, if I go to NAT gateway, I can see the NAT demo1 new. I can add the destination as 0.0, click on save routes. This is done, right? Now, what has changed? So now if I try to access the subnet 2 machine, I will still not be able to SSH into it from my terminal, from the outside. So if I try this out, this will still not work. Why it will not work? Because this subnet still does not have outside internet access, but from within it, it can go ahead and use the internet. So now if I try to SSH into my second machine, this is now my subnet 2 machine. And from here, if I now do a curl on google.com, you can see that the internet can be accessed, right? So how is that possible? That is possible using NAT gateways. Finally, let's go ahead and understand what is VPC peering. Now VPC peering is a very simple concept. Now what it says is, if you have two VPCs and if they want to be able to interact with each other, you basically just have to create a peering connection. That's about it, right? You could create two VPCs, and if these two VPCs want to interact with each other, not on the internet, but using the internal network, you can do that by creating a peering connection. Now, how can you create a peering connection? So first of all, what you can do is, let me go to VPC. Let me quickly go ahead and see the three VPCs that I have. So I have a default VPC, which everyone has when you create an AWS account. So what I'll do is, I'll basically go ahead and launch an EC2 machine in the default VPC. So I click on launch instance. Select the Ubuntu server. And I want to deploy it in the default VPC, which is correct. Select the default security group. Launch it. So this is my default instance, which is there in the default VPC. Now what I want is, this instance should be able to talk to subnet 1 machine and subnet 2 machine via the private IP addresses. So if you see, the private IP address for this is 172.range, right? And the subnet 1 and subnet 2 machine are in the 192.range. So I want these two machines to be able to talk to each other. So right now, if I go ahead and this is my subnet 1 machine now. If I go ahead and try to ping this particular machine, the default machine, using the private IP, obviously I will not be able to ping it. You can see the ping is not happening. However, if I go ahead and connect to this machine using the public IP, I'm able to connect, right? But this machine is not able to ping this machine over the private IP. Now we are going to change this. So how can we change that? Come back to your VPC console, scroll down to the VPC pairing section. Okay, so there is something called as VPC pairing. Pairing connections. Let's click on create pairing connection. And let's say this is VPC, or let's say this is demo 1 to default. So who's the requester? Let's say demo 1 is the requester. This is the CIDR range. And what I want to go ahead and connect to is the default VPC. And I want to click on create pairing connection. Okay, so you can say, it says pending acceptance. Okay, and now what you can do is click on actions, click on accept request. And now you can see this pairing connection is now active. Okay, but that does not mean the ping is going to work. The ping is not yet going to work. What you have to do is, you have to go to route tables. So since this is subnet 1 machine, I'll have to add a route in the subnet 1 table. Let's add a route that anyone should be able to connect to the pairing connection. So if I add this range, click on save routes. Okay, 1 second. So 192.1.1.0/24, save routes. And here I think we'll have to add this CIDR range, which is 172.31. Okay, the route has been created. And now same I will have to do in the default route table as well, which is this one for the default VPC. So I'll select this, edit routes, add a route. This will be for 192.1.0.0/16 pairing connection. This is the one. Click on save routes. And now you can see the ping has started to work. So now what is it being able to ping each other? So basically this is my subnet 1 machine. My subnet 1 machine is now able to ping the default instance that I created in the default VPC. Why? Because we have created the pairing connection. Similarly, from here, I will be able to ping the subnet 1 machine. So it will take some time. Let me check. Okay. I think in the security group I have not enabled, so I'll have to just change the security group settings quickly. This is the default one, demo 1 security group. I'll have to go to inbound rules, and here this small rule I'll have to change, and I basically want to allow everyone to be able to connect. And once this is done, even my second instance is able to talk to my other VPC, which is there in the other instance, right? So guys, this is what VPC pairing means, that two VPCs are now able to talk to each other by creating a pairing connection and having their connection details in the routing table. So guys, this is how you go ahead and create a VPC pairing connection.
Just a quick info, guys. Intellipaat provides online AWS certification training in partnership with Future Skills, mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
So, introduction to AWS DevOps. The first thing is, why DevOps on AWS? So, you can use DevOps on any cloud service or even on your on-premise environment. So, if you have a business running, you will have an on-premise environment. You might have an infrastructure for yourself. You can run it on it also. But why AWS DevOps? That we'll see moving on. So first, what is AWS DevOps? AWS DevOps is a set of developer tools which is provided by Amazon Web Services. This allows us to create a CI/CD pipeline from the scratch to the deployment stage, that is from the source. For example, a version control tool, maybe GitHub, maybe Azure repos, maybe AWS code commit. So from the source stage till the deploy stage, we can do everything. It is the same as any DevOps tools, any DevOps lifecycle, or any DevOps process, but the tools are provided by AWS. And then, so why AWS for DevOps? What are going to be the benefits of using DevOps on AWS? So the first thing is fully managed services, guys. So we know why do we use a cloud service? Because we don't want to manage our tools or the VMs we have launched, the data we have stored. We don't want to manage it, or we don't have to install softwares on it. We don't have to do anything. It is all taken care by AWS. They take care of our infrastructure. So that is the first reason, guys, fully managed services. And then built for scale. Because AWS DevOps, you will be using it on existing services like EC2 or Lambda. So when you use on them, they already have a scaling feature within them. So obviously it is built for scale. So you can easily scale it up or down. And then programmable. You can write scripts, you can write shell scripts, you can create a program which you can implement inside AWS developer tools, which can actually impact your DevOps lifecycle. And then automation. So DevOps is mainly automation. So automation is one of the main reasons, and automation is available in everything like Azure DevOps, AWS DevOps, even in GCP. If you are implementing DevOps, automation will be available over there. Or if you manually use DevOps tools to create a DevOps lifecycle, even then automation is required. So DevOps main motive is automation. And then secure. Yes, AWS provides security and it is their first priority. And then pay as you go. Pay as you go model is that whatever you use, you only pay for that, nothing else. For example, you will launch a virtual machine using code deploy. So that virtual machine is running for 2 hours and then it gets terminated. So you'll have to only pay for that 2 hours time. You don't have to pay for creating a virtual machine and running it. You don't have to pay a month's fee. You just have to pay the money for that particular 2 hours. So moving on. Now we've discussed what are the benefits of having DevOps on AWS. Now we'll see what are the tools provided by AWS. So these are the 4 tools provided by AWS, guys, and these are the most basic tools. There are still more tools for developing, but these are the 4 most basic tools for creating a DevOps lifecycle. So the first one is code commit, and then code build, and then code deploy and code pipeline. So let us discuss them. Let's discuss these developer tools in detail now. So first let us discuss code commit. So the name suggests that code commit is a version control tool. It is like GitHub. So it is like Bitbucket. It is a version control tool, guys, but it is provided by AWS and it also provides the same features GitHub provides or Bitbucket provides. You can do all of those stuff which is available over there, like committing, pull requests, merging branches. You can do all of it even using code commit. You can also see over here code commit allows 5 active users per month. So basically this is going to be your private repository. So it allows 5 users per month. For if you have a startup and you only have 5 members, you can actually use code commit and you won't be charged even a single rupee. And also you will be given 50 GB of space every month. So for example, our repositories maybe maximum of a size of 1 MB or 2 MB, but 50 GB, they provide 50 GB of space for the repository, guys. And also 10,000 Git requests per month, like pull or push requests. So this is code commit. It is a tool. It is like GitHub. It is like Bitbucket. It is the same kind of tool, but it is provided by AWS. And then AWS code build. So the name suggests that this tool is for building your application. So it provides a fully managed CI service, that is continuous integration service. It will compile your source code. You can run tests, you can run unit tests, and also provide software packages and store it in AWS S3 so that you can take out those packages and use it to deploy your application. So you can see here AWS code build, 100 build minutes. That is, if you run a build, it might run for 20 seconds. So like that, you can run any number of builds which come up to 100 build minutes, and also it runs using build.general 1.small compute type usage. So it runs with this, and for every month you get 100 build minutes free. Moving on, AWS Code Deploy. This is one of the important service, guys. This service is used to deploy your application on any service you choose, like EC2 or Lambda. So it is an automated deployment tool which can deploy services like EC2, Lambda, Beanstalk. So even if you launch Beanstalk, it will be launched in an EC2 instance or Fargate, and also your on-premise setup. So these are the 4 benefits provided by AWS Code Deploy. So first is automated deployments, and then minimized downtime, centralized control, and easy to adopt. So the first one is automated deployments. Is when you set it up, whenever there is a change in your repository, it automatically runs again, it builds your code again, and it gives it back. So that's what automated deployment means. It doesn't build and it stores, it actually deploys it again. Whenever there is a change in your code, it deploys and the change will be visible in your website. And then minimize downtime. So whenever the code is changed, it takes very less seconds. Your website will be down for maybe 1 to 2 seconds, and the change will be on your website, guys. So it minimizes the downtime. For example, when you do it manually, you will have to go to your system or your server where your website is launched, and you will have to change your code over there. When you do that, the downtime increases, but using Code Deploy you can minimize that. So I'll show that in the demo, guys. And then centralized control, you can just use your command line interface of AWS or the management console, and you can control all of the operations happening in Code Deploy, Code Commit, and Code Build. And then easy to adopt, you can see works with any application, and same experience whether you are deploying it on EC2, AWS, or Lambda. That means whatever service you are deploying it to, maybe EC2 or Lambda or Fargate or Elastic Beanstalk, it provides you the same UI with the same experience. So it doesn't change, it is the same thing, but the deployment environment is different. So this is Code Deploy, guys. And then finally, AWS Code Pipeline. So we are going to use Code Pipeline. We can use Code Pipeline to create a CI/CD pipeline, guys. We can use all those services to do that. So first thing, it is a continuous delivery tool. That's why it is called a CI/CD pipeline. So it is also fully managed by AWS. As I told you, that is one of the benefit. And also you can automate your website, or you can automate your application which is running on Code Deploy. So when you create a pipeline, whenever there's a change in code, it automatically pushes it to Code Deploy and the change will be made. So that's how you use Code Pipeline, guys. You can see over here, take it as an example pipeline. You have some website over in your source, that is your GitHub. So you build it and you test it using some programs. So after testing it, you can give any number of stages. This is staging. This means you will be seeing this deployed, but you will be seeing it in a IP address which only you might see. You might have given the security group like that. But in production, when it gets deployed in production, then you can view your website using the IP address or the DNS name from any other computer, guys. So this is how you use AWS Code Pipeline. And then, so you can see over here, easy to integrate AWS Code Pipeline with GitHub or with your own custom plugin. So you can integrate GitHub and Code Pipeline easily. You can just click on connect to GitHub. There is an option for that. Or you can use your own custom plugin, like you would have created something in Bitbucket or any other version control tool. You can even use that. And then also it is pay for what you use. It's the same thing, guys. And also there is no upfront costs or long-term commitments. So it is basically free. Whatever services you launch using it, for example, the EC2 instance, so those are charged, not these services like Pipeline or Code Deploy. And also rapid delivery, which basically means whenever there is a change in your code and it is applied to the master branch, it will be applied to your website directly. And then configurable workflow. The workflow, you will have an UI. You can configure your workflow, how it should happen, which is the deployment server, which is the production server, which is the QA server, or you can mention builds or you can skip builds. So you can create a workflow for your own advantage and then get started fast. This basically means it's pretty easy. They have a lot of documentation, guys. You can just go on, create your own pipeline in no other than like half an hour. So it takes only that much time. And then it is easy to integrate. You can integrate AWS code pipeline with any service. You can integrate with even Jenkins. So this is what they say, easy to integrate. So right now let us move on and let us create a CD pipeline using code pipeline and code deploy, guys. So let me open my GitHub repository. So let me close this. So this is the GitHub repository which I am going to use, guys. So you can see over here index.html, abspec.yml, readme. This is the readme file, and then I have some scripts. So first I'll show the index.html file. So it is basically a hello world HTML. And then the next thing, the most important thing is abspec.yml. So this is a YAML file. So what it does is, you can see over here, the source is index.html, destination is this. So this is where Apache 2 installs its
Just a quick info, guys. Intellipaat provides online AWS certification training in partnership with Future Skills, mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
index.html file, but we'll be deleting that file and launching our hello world application. So you can see here, before install, script/install dependencies and script/server, start server. So I'll show that what actually is there. I'm going to scripts, install dependencies. So in install dependencies, you can see, guys, it updates the instance. After updating the instance, it will install Apache 2. And also, guys, in your script, make sure to provide -y. This means yes, because you cannot go inside and click enter yes. So whenever you provide -yes, it will automatically take the command as yes, and it will install the whole software. So whichever software needs a yes, provide a -y, guys. So if you don't provide, it will fail. And then it will remove the index.html file in. So it will remove the index.html file in this location that will be created by Apache 2, and that will be the Ubuntu default page created by Apache 2. But I don't want that page to be launched. I want my page to be launched. That is my hello world page. So these are the stuff I wanted to show you. Abspec.yml, I'll show why we need that, where it will be used. So now let us start off with our management console. So the first thing we'll be doing is, we'll have to create a code deploy, guys. So I'll go to code deploy first, and also I'll open. So if I go to code deploy, basically you can see all of this over here. You can see source, repositories. You can actually create a repository, guys. To create a repository is very simple. You can just provide a name, for example, website. And then if you want, you can provide a description, or you can just create. That's it. But one more thing, you cannot use your repository from your root account. You will have to use it from your IAM user, which you can create, but you cannot use it from your root account, guys. So I'm not going to use this. I'm directly going to use from my GitHub. So this is it's actually pretty simple. And then build is for as I told you, it is for building your application. But right now I'm launching my website, so I'm going to use only code deploy and code pipeline, guys. So first thing we'll have to do is, we'll have to create a, here you can see EC2, then AWS Lambda and ECS. I'm not going to use Lambda or ECS. I'm going to use my EC2 instance. So you'll have to click on EC2 and then create application. You'll have to select it over there, because we'll be creating a deployment group which will be targeting the EC2 instance which we mention using tags. If you want to use Lambda, you can choose that also, but I want to use my EC2 instance, guys. So now we'll have to create a deployment group. But to create a deployment group, we will need a EC2 instance. But currently I don't have an EC2 instance, guys. So because we'll have to mention EC2 instance over here, I'll have to mention my tag over here. So before moving on with creating a deployment group, I'll create a EC2 instance. So first, what is deployment group? So deployment group is, it directs or it targets to which instance should this particular code deploy application should deploy the application to, that is the website. So deployment group. So let me create the EC2 instance first. Let me teach you how to do that, and also how to install code deploy agent in that, because without installing code deploy agent in your instance, you will not be able to use code deploy for your instance, any instance which you use. So I'm going to use a Ubuntu server, guys. So I'm going to EC2. So I think you would have learned how to launch an instance from our other videos which are available in our channel. So currently I'll not be explaining each and every step in creating an instance, but I'll teach how to create an instance which will benefit in using code deploy. So the first thing you'll have to do is you'll have to go to EC2 dashboard and then go to instances, click on launch instance, guys. So you can see over here, choose AMI. AMI is Amazon Mission Images. Basically this means the ISO file. That is, you can see this is Amazon Linux, this is Red Hat, this is SUSE Linux, this is Ubuntu, and also you'll be having Microsoft Windows. So you can choose any of this and launch the server. But I want a Ubuntu server, guys. I'm going to launch my website in my Ubuntu server. So I'll be selecting this. And then these are instance types. You can choose any instance, but I'm going to go with free tier eligible instance, t2.micro, which doesn't cost me any money up till 750 hours every month. So you can use this particular instance, you can run this instance for 750 hours every month. So I'm going to go with t2.micro. Next. And here number of instance, I just need one instance. And then one more thing, guys, this is the most important thing. You will have to include a IAM role. So why an IAM role? Because the code deploy agent should access your EC2 instance, and also the EC2 instance should be connected to your code deploy agent. So to give a connection between these two AWS services, you will have to attach an IAM role. I already have created an IAM role, guys. So I'm just going to go to EC2 code deploy. If you don't have one, you can just go over here. I'll tell the basic how to create a role. So role, create role. You will have to choose the service which you are creating the IAM role for. So EC2, next permissions, and here you will have to provide code deploy. So you can see Amazon EC2 role for code deploy. You can just choose this, and next you can provide a name over here and create the role, guys. So I already have created a role. So you can see over here EC2. So I already have created a role using that particular permission. So I have created, if you want you can create it. If you already have, you don't need to. So I have it, I chose the IAM role. And then also I'll have to enter user data. So what does user data mean? So basically user data is the commands or scripts which you want to run while the instance is being created. Once the instance gets created, these commands and these scripts will be automatically run. So we don't need to open the instance and run all of these. This will be automatically run if you enter the user data over here. So I have the user data over here, guys. You can see over here, basically it will update my instance. It will install Ruby. Actually Ruby is required for code deploy. And then if you want, you can install wget, or wget is already available in your EC2 instances. And then I'm going to this location, and there I'm going to install my code deploy. After installing that, I'm just modifying my permissions, and after that I'm installing code deploy, which got downloaded. After it gets downloaded, now I'm starting code deploy, guys. After installing code deploy, I'm going to start the code deploy service. Only if it is started, then I can connect my EC2 instance and code deploy. So I'll copy these and enter it in code deploy, guys. That's it. So this is what we have to enter, and you can see over here it asks for, I've given -y. So basically -y means yes. So when you install Ruby, it basically asks yes. So providing -y doesn't affect that. It will provide yes automatically. So we've done all of the required things over here, and then adding storage, 8 GB is more than enough. And then you'll have to add a tag, guys. So to add a tag, hit on add tag, then I want to, the key is going to be name, and my value is going to be web server. So this is going to be my value. Why I am creating this tag? Because I'm going to use this tag so I'll have to enter this tag over here so that this code deploy identifies this particular instance, guys. So moving on, next, configuring security group. So already SSH is available, but I actually don't need to SSH into my instance. But right now, I'm going to allow an HTTP rule, because I need HTTP because I'm launching a website, guys. My website needs HTTP. Without HTTP, my website will not be able to be seen using a URL, and also it can be seen from any IP address across the world. If they are using my IP address from any browser from anywhere in the world and through internet, they can see my website, guys. So reviewing and launching it. This is just for making sure if everything is right. So I'm good with it. And you'll have to choose the key pair, guys. If you already have a key pair, you can just choose the existing key pair and move on and click on launch instances. And now your instance has been launched. So you can just go to view instance. You can see my instance is being created right now. It's in pending state. So only if this is running. So right now I think I can see it over here. So right now I'll go back. And now let me start creating this deployment group. So my instance, let it get created. So my deployment group name is going to be web server deploy. So web server deploy 1. And one more thing, you'll have to enter a service role, guys. This service role allows this code deploy to connect with EC2 and other services like S3 or whichever you mention. So I have this service role. You can also create a service role for code deploy. So I showed you how to create a service role for EC2. So this shows how to create a service role for code deploy, guys. And then let it be in place, and then environment configuration. In environment configuration, you will have to mention whether you're going to connect your auto scaling group or your individual EC2 instances or your on-premise instances. I'm going to connect my EC2 instance, which is running right now. It is initializing, guys. So right now, if I just hit name, and you can see many values. My value was capital W web and capital S server. So I'm going to choose that. So now you can see there is one matching instance. If I click here for details, you can see over here, and my instance is showing. So this is the instance and it is showing, so that I have connected this code deployed group. So it is connected with this particular instance, guys. My deployment group targets to that instance. So now I'm good to go. And here you can see deployment settings, deployment configuration. So one at a time, half at a time, all at once.
Why should you become a cloud engineer? Now guys, let's start off with a basic necessity. What is the salary that a cloud engineer actually earns, right? So let's talk about that. So what we have done is we have basically collected data from a lot of sites which basically do job postings. We have done it from ZipRecruiter, we have done it from Indeed, we have done it from Glassdoor, and this is what we have seen. So in the US, a cloud engineer, an average cloud engineer basically earns $128,000 per annum. In India, an average cloud engineer earns around 7 lakh rupees per annum. And in the UK, you have around 60,000 pounds per annum. Okay. So guys, this is an average salary. Now, based on your experience, let's say you have a 10 or 12 years of experience in the IT domain and you plan on to shift onto the cloud sphere. In that case, you might even get a salary up to 20 plus lakhs per annum in India, right? I'm just talking about with the limited experience that I have. So I have friends who have salaries for 25 plus lakhs per annum, but that given that they also have a very strong background in the IT domain, right? I also have seen people who have basically shifted from non-IT domains and they have started in the cloud sphere. And even in that case, given that, you can implement what you have learned in your past experience in the cloud domain, they easily can grab a salary of around 12 to 15 lakhs. based on their experience, right? So these are the two things that I talked about. The other thing is it also depends, like I said, on your experience. And if you're a fresher and you're just starting out,
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which one of the following is cloud platform by Amazon? A. Azure, B. AWS, C. Cloudera, D. All the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
and you're thinking of basically starting off with the cloud domain, you can easily earn around 4.5 to 5 lakhs per annum if you are a fresher, given you don't have any experience in the industry and you are just starting off as a cloud engineer in this space, right? So this is the salary that you get when you basically become a cloud engineer, and based on your experience, you can expect a different or a varied salary exposure. Okay, moving forward, guys, now let's talk about the things which are important for you to get a higher salary. Now, how do you differentiate yourself from the people who are also there appearing for the same profile and are there in the interview room? So what differentiates you is your certification. So what are you certified with? Are you certified from AWS? Are you certified from Microsoft? Or are you certified from Google Cloud? Now, these are the top 3 cloud providers in the market right now. And each and every company who works on cloud would have their product on any of these cloud, right? And basically that is the reason any company who is basically expecting a cloud engineer in their firm, they would expect you to have a certification from either of these 3, right? And once you get certified, that basically tells the company, okay, so now you're certified in this particular domain. We now know that you know cloud up till a particular proficiency, and then they start asking questions from that particular level. Now, this might not be helpful for some people who have a hybrid kind of a profile wherein they are working as a software developer full-time and they also work on cloud for some part of their project, right? But if they try to shift their domain, they might get a job even without getting certified. That is also possible. But usually certification helps you when, let's say, you are working in a domain where cloud is not at all used, right? Let's say you're working as a system administrator, and let's say you're working for a company like IBM which have their own private cloud. So what you don't have experience in, or what you cannot put in your resume, is that you have worked on AWS, you worked on GCP, you have worked on Azure on certain projects. That you cannot put. So for people like these, for people who don't have the working experience in these domains that are AWS, Microsoft Azure and Google Cloud, if you are planning to become a cloud engineer, you would be to get certified in these cloud domains, right? So once you get certified, that basically tells the company, even though this person has not worked on production for these clouds, this guy has been basically certified by a parent body of the cloud provider. For in our case, let's just talk about AWS. So in case of AWS, the parent company is Amazon. So Amazon certifies this guy that he's proficient in their cloud infrastructure, right? And this is what the certification tells me. Now, on this certification, obviously, you'll have to also do some projects that you would be doing independently, and that you'll have to add to your resume. And that is how you will tell the company that you're appearing for that I have done some projects in cloud, although I did not get the time while I was working in my company in the production environment. But this is what I've done in the side time of mine, right? I've done these projects, and I've also got a certification from this company that I am a solution architect or a developer or an administrator, whichever certification you do, right? So a certification is very important, and with the certification you can expect a salary hike, right? And the average salary which we have discussed, this 139,000 is just a number, but whatever we discussed, you can aim for those salaries given you don't have the experience in a current company with the certification. So you will have to get certified if you want to become a cloud engineer and you don't have the relevant experience right now. Okay, moving forward, guys, now let me tell you some of the average salaries based on the certifications. So if you are an AWS certified solutions architect in the US, you can expect around $130,000 per annum. If you are a AWS certified developer, you can expect around $130,000. And if you are a Microsoft Azure certified solutions architect, you can expect around $121,000. Now, all these salaries are basically the average salary. So what I can tell you is from $120,000 to $130,000 in the US, you can earn once you get certified by these companies and given you have the relevant experience. Okay. Now, you might have noticed over here that you have something called as a solutions architect, or you have something called as a developer, and all of these are basically certified by AWS. So what are these? Now guys, for the people who are from the IT domain, and if they want to make a shift to the cloud, and you also want to bring along with you the experience that you have in the IT industry, what you can do is, let's say you are a developer right now. Okay, and what you want to do is you want to become or you want to do development in AWS with, let's say you have an application on Node.js and you want that Node.js application to interact with some services on AWS. So what will you have to know? You'll have to know some SDKs, you'll have to know how to interact with AWS APIs. So all that knowledge is basically gained by a person who is a AWS certified developer. When we compare him with the solutions architect, the solutions architect job is not to code. So most of the people that I've trained or that I know basically are solutions architect. The reason for that is when they started off in their IT journey, they did not know much about cloud. And they started off as a normal software engineer or a system admin or something like that. And now for the people who don't know coding, right, and they still want to be in cloud, people can easily crack the solutions architect profile. The reason for that is in the solutions architect profile, what you have to know is how to plan things. What you have to know is how to architect applications without knowing the actual implementation of the code. So that is what the solutions architect profile is. But mind you guys, this profile is super tough as well as you progress in your career. So you will find architects who were developers before, who were system admins before. They have the complete knowledge of the inside and out of the product. They can code also, and they also know how to plan. So those kind of people are also solutions architect, and obviously their salary are on the higher range. If I talk about a solutions architect who knows coding, who knows in and out of the application and knows multiple clouds, his salary can go up to 40 plus lakhs per annum as well in India, right? So that is the kind of scope that you have when you get yourself acquainted with AWS. It's a journey that you'll have to start with, right? But you will even find solutions architects who are sitting at 4 or 5 lakhs per annum. And those people are basically freshers who have joined the industry and they just know AWS, right? You will also find solutions architects who are around 14 or 15 lakhs based on the experience that they had and now they have shifted to cloud. So based on your experience, you can go up the ladder, right? The Certified Solutions Architect Associate is just a certification, but what matters is what experience you're bringing to the table, and that just makes everything change, or that makes the dice rolling when you're basically applying for a job. Okay. Moving forward, guys, now let's talk about what is the cloud engineer role. So we have talked about why you should be a cloud engineer, where I talked to guys about. We have talked about the money aspect. Let me also give you one more aspect, guys, that Forbes or some independent body, we are going to discuss about it in the future, in the next couple of slides. But they have predicted that whatever revenue cloud is earning right now in 2019, by 2023, that revenue itself of the whole cloud industry is going to double, right? So that basically means whatever number of job postings that I'm going to show you today, they are going to basically double or triple by the year 2023 or 2025, right? So that's the kind of growth that cloud is going to see in the future. And if there is any time to shift to the cloud domain, it is right now, right? So if you are thinking about moving to the cloud domain, or if you want and are intrigued with what cloud is and you want a job in the cloud domain, right now is the time that you should migrate from your current job role to cloud, right? Now, what will you do when you become a cloud engineer? What exactly will be your role? Let's discuss that. Now, guys, a cloud engineer, or like for my friends who are not acquainted with what cloud is, guys, cloud is nothing but, in the most simplest terms possible, it is the use of remote servers on the internet. Okay. So if you have remote servers on the internet and you use them from the comfort of your own laptop, you are basically on cloud. You're basically using servers which are not there in your premises. You're using servers which are away from you. So that means you're using the cloud. So don't get confused with what cloud means. Cloud basically means you don't know where the server exists. You just have an IP address, you have the username and the password, and you just type that and you can see the desktop of that machine and you can do anything you want. That is cloud, right? In the most simplest terms. But it gets a little complex when we talk about, so I talked about a server that you would be existing on cloud that you can connect with, right? Now you have specialized servers in cloud which can do a particular task. For example, you have backend servers, you have front-end servers, you have database servers, and you can do a mix and match of these servers and create a whole ecosystem of application around you. So this is what a cloud engineer knows. He knows how to use the services provided by a cloud provider in the most optimum fashion possible and create a highly available and highly reliable application out of it, right? Doesn't matter if you code the best application in the world, but if your infrastructure is not supporting your application, you won't get the kind of performance you want out of your application, right? And that is exactly why you need cloud engineers, because they know how to deploy your application. They know which server to deploy it on or which service to use on cloud provider to deploy a particular application. If I were to give you an example of how it works from the top of my mind is, there are two backend languages. I'm not sure if everybody of you would have heard of it, but just hear to the example and you'll know what I'm talking about. So there is a programming language called PHP and there's a programming language called Node.js. Now Node.js basically works on single thread while PHP works on multi-thread, right? So what happens is when you have to choose between PHP and Node.js for your application, let's say you work in a company and that company has made an application, the development team has made an application, and now they come to you asking, or they are planning to make an application and they come to you asking which programming language should we use? Should we use PHP or should we use Node.js? Now you as an architect, you tell them that, if you're using PHP, it's a multi-threaded language. If you use Node.js, that's a single-threaded language. Now this is something that you will find in any of the documentations. But what an architect needs to know is what are the advantages of using single-thread language and what are the advantages of using a multi-thread language. When you use a single-thread language, you cannot give that language processing intensive tasks. For example, if there is one task that requires a lot of processing, that would not function well on Node.js, given it's a single-threaded language, right? While on PHP, if there are multiple threads which can run at a single time, that particular language can accept process, an application which involves a lot of processing, right? But if your application does not have that much of a processing, it's just about doing CRUD operations on databases, right? In those kind of scenarios, you can use Node.js because it performs way better than PHP. Now, this knowledge which I just told you is a knowledge that an architect should know, right? Or a person who is handling a team or who's going to deploy your application on a particular infrastructure or in a particular environment should know. And this is similar to this knowledge in infrastructure, a cloud engineer should also know, right? For example, if my application is process intensive, if it requires a lot of processing, how much of RAM or how much of CPU would a single server require? That I have to plan. Which service on the cloud, like for example in AWS, there are 3 types of compute services. Mainly, right? You have EC2, you have Elastic Beanstalk, you have Lambda, right? So where to put which application you have to know. For example, Lambda requires backend or basically does backend processing for you, right? So backend part of your application would go on AWS Lambda. Now, obviously, if it's going on AWS Lambda, you'll also have to make it highly available. So AWS Lambda handles it for you. But when we talk about your front end, where a lot of users are going to ping your website, that task will basically requiring a lot of scaling up and down because the traffic is not the same at every time. What I basically mean by that is, let's say you are running a company and at around 4 p.m. you get the maximum traffic, right? So in that case, you need a server capacity of around 9 or 10 servers at that time. And at 6 p.m. the traffic drops. Okay, at that time you don't need those many servers. So how to configure the auto scaling properties in cloud providers, right? That and all this knowledge is what an architect gains when he he basically gets certified, or when he roasts himself by doing work day in and day out as a cloud engineer, right? So guys, a cloud engineer role, to sum it up, is to know what application would go on what service of the cloud and what would be the best practices of deploying an application. That is what a cloud engineer should know, right? Now, he has to work on planning, he has to work on architecting, then he also has to work on managing the infrastructure once it's deployed, and obviously he also has to look at how we can monitor and support this particular application. All this planning, all this implementation is done by the architect or the administrator or the developer, but essentially they are known as cloud engineers. And this is what your role would be when you shift into the cloud domain. So to sum it up, if you are applying the best practices and whatever principles you have learned in cloud, then that profile would sum up to become a cloud engineer profile. Now, moving forward, guys, let's talk about the skills that a cloud engineer should have, right? So a cloud engineer, or a person, if I'm a company and if I'm hiring a cloud engineer, I would expect certain skills out of a person. So I would expect he should know some programming language. I would expect he would know some Linux scripting skills that he should have. I would expect him to have some troubleshooting skills, and I would expect him to know multiple cloud domains. Now, this is not what I think the companies would expect. This is basically the research that we have done, and I'll show you in some moment, guys. I'll show you some job descriptions from companies who are basically hiring cloud engineers, and I'll show you what kind of skills that they ask, right? So how to become a cloud engineer? So I told you guys, some companies expect some skills. Now, how to get yourself acquainted in those skills? But before that, let me show you actually what are the requirements and skills that are expected from a cloud engineer. So guys, a job description is what we will be looking at. So in this particular section of job roles and responsibilities, I'll be showing you some job descriptions from multiple companies, and then we'll sum it up and see what are the required skills which the industry is demanding right now to become a cloud engineer. Okay, so let's start off with the first job description. So this is a job description which is by Cisco, right? And they are basically hiring a cloud infrastructure engineer, and what they expect this guy to know is DevOps. He should know how to resolve customer issues. That is, he should be customer centric, right? He should know how to deploy cloud applications on AWS. He should know about VPCs, which are basically services in AWS, EC2, again a service, etc. Right? So these are the skills that they expect from a cloud engineer. You would be wondering, what is DevOps over here, right? So I will explain that in a few moments. But as you can see, these are all the skills that they expect from a cloud engineer in the Cisco company. Now let's go ahead. Let's talk about Amazon. So Amazon is also hiring cloud engineer, and what they expect is they should know troubleshooting. They should have experience with AWS, Google Cloud, Rackspace, software layer management, etc. They should know a programming language among Java, Perl, Ruby, or Python. And they should have experience in managing full stack applications, right? This is the expectation from a cloud engineer by Amazon company. Then there is a company, McAfee, which I'm sure all of you know. Now, in this, you are expected to know AWS, you're expected to know Azure, you're expected to know Google Cloud, right? You're expected to know CloudFormation, which is basically a service in AWS. You are expected to know Puppet, Ansible, and Chef, which are basically DevOps tools. You're expected to know Python, right? So all these skills are required. So what I'm trying to tell you is, it will not work if you just know one cloud provider. It will not work if you just know one programming language. You have to know a combination of multiple things, and only then this cloud engineer profile can be taken on. Okay, and more skills and more relevant you become with the job descriptions. For example, I'm not focusing on any one company. What I've done is I have generally taken out skills from multiple cloud engineer profiles, and then I have accumulated them together. Let me show you how that looks like. So the required skills are these. So if you were to sum it up, if you want to become a cloud engineer, you should have knowledge of AWS, Azure, and GCP, right? Then you should have an experience in any of these programming languages: Python, Java, Go, R, Clojure. I would recommend you, if you are planning on to learn a programming language, you should basically either learn Python or Go, basically, because they are huge when it comes to the demand that they have right now. You should have a little experience in Linux operating systems. not a little actually, I'll say you should be an intermediate in your Linux skills. Then you should also have know tools like Puppet, Chef, Git, Docker, Kubernetes, Nagios, Terraform, etc. Right? So don't get scared, guys, with all these big words. I'm not only telling you the problem or what the companies expect, I'll also give you a solution as to how you can prepare for this. Okay? So, and you should also have an understanding of APIs and web services. Okay? So these are all the skills that are required to become a cloud engineer, and I would say even if you gauge around 60 to 70% of these skills, you can apply for a cloud engineer job. This is basically job description for a generic company which is out there. Now, how relevant you become to become a cloud engineer is this list. The more and more you know this list, the more and more you become relevant, and you can apply for any cloud engineer job as you move along. Okay. Now, let's talk about what are the skills that we have summarized. So I've told you guys that you should know Linux. So first off, when you start on the journey of becoming a cloud engineer, you should start off by learning Linux. If you know Linux, you can skip this. But if you don't know Linux, first you should learn this, right? Then you should start off with all the cloud providers, that is AWS, Azure, and GCP. You should start learning that. Once you are done with Linux and cloud providers, you now know how things work on cloud. Okay. Now what you have to know is how companies implement or upload or basically help their development team to integrate their development tools with cloud, and that is exactly what DevOps is for. If I were to give you an example, let's say there's a developer in a company, and what he knows is basically a place where he can upload your code, right? For example, a developer's best friend is basically a version control system. Let's assume he's using GitHub, right? So all he knows is how to code and how to upload it on GitHub. But from GitHub, how do you test that application? And if the test is complete, how do you make it available on production? That life cycle is basically what DevOps caters to. Okay. Now, how does cloud fit in DevOps is when you have deployed an application on, let's say, your production server, most of the companies now are basically using cloud, right? Which basically means they don't have any infrastructure of their own. Probably the developer's machine would be there in the company, but the server on which the application is deployed is not in the company. It's on the cloud. So I think you got the idea that whenever your applications are either getting deployed on testing server or on the prod server, these servers are nothing but these are servers which are deployed on the cloud, which could be either AWS, Azure, or GCP. So how to create the DevOps lifecycle on the cloud is what you'll have to learn. And that's why you also have the DevOps tools as a skill when you want to become a cloud engineer. Then you should also know a programming language. The reason for that is, I told you guys, a cloud engineer should also know how to code. The reason for that is, let's say an application stops working, right? And now the developers have no clue why it's not working. So it's your job to understand the code and understand where exactly the problem is occurring. And that's why it is recommended that you should know a programming language. Otherwise, if you're planning to aim for the cloud developer role, in that case, what you'll be doing is you basically will be implementing your application with the cloud, right? And if you're integrating your application with the cloud, which basically means you have to interact with the services of the cloud, then you have to know how to implement SDKs, right, in a programming language. And that exactly would be covered when you know a programming language, right? And finally, because today in today's world, we are no longer working with monolithic applications. What are monolithic applications? There is no one code which will basically run my whole application. You basically have different parts of the application deployed separately, and these different parts interact with each other. And these are what APIs are in the most simplest terms. Okay. So if you did not get that, let me just tell you in a brief sentence that earlier all the applications had one single code base and they were deployed and the application used to work. But what happened was, as we progressed in the software development journey, we realized that, let's say I'm using the Uber app and I have to add a feature in the payments section. So I'll have to open the whole code base again. I'll have to go to the payments section of the code and I'll have to make changes and then upload the whole code again. This unnecessarily broke something or the other in the whole code base. And now what we follow is a microservices architecture. And in the microservices architecture, what we do is we basically break the application into multiple parts, and then these parts interact with each other using API endpoints, right? So as a cloud engineer with the modern applications that we deploy, you should also know what are APIs. Okay. So these are the required skills for you to become a cloud engineer, and you should follow this particular fashion when you are basically preparing for a cloud engineer role. Okay, now I told you guys how you can prepare for a cloud engineer role. Right now, if you were to do it on your own, this is the way. If you want help from us or from any e-learning company, I'll tell you a way as to how you can learn that as well. Okay, but before that, I'd like to tell you guys the present is good. I mean, if you want to become a cloud engineer right now, it's the best possible time you can become. If you become right now, what is the future that lies in front of you? It should not be like that in 2-3 years the demand goes down, right? So let me tell you the future of a cloud engineer. So guys, these are basically some statements that I have picked up from these companies. Like Forbes says, cloud engineer or cloud architect profile is in the Forbes top 15 list of highest paying tech jobs right now, right? Forbes says around $146,000 is the median salary for a cloud professional, which is basically a jump because when they did the survey in 2016, it was $22,000 less than the figure that you see right now. So as the number of years are passing by, the obviously the inflation is also there, but $22,000 is not the kind of inflation that you would see, guys, right? So it's a huge jump in the median salary, in the average salary of a cloud engineer. Then according to Glassdoor, in the last month alone, right, we are talking right now in August 2019. So in July 2019, there were 5,765 jobs posted in India just for a cloud engineer. And there were 33,272 jobs which are posted that were in the US. Okay. So this is the huge demand that you can see that is there for a cloud engineer profile. Similarly, there's a company called Canalys. So they say AWS, which is the biggest cloud provider in the market right now, it owns around 31.5% of the cloud market share. Now you would think that 31.5 is not a huge number, but when you compare it with Azure, which is the second largest cloud provider, it has around 14 or 15% of the cloud market share, which is actually the half of what AWS owns. And it is the second largest cloud provider, Microsoft Azure. So as you can see, AWS has a whole lead. And the reason for telling you this is when you're planning to learn about the cloud providers, which I basically told you three, which are AWS, Azure, and GCP, you should always start with AWS, given you don't know AWS yet, right? The reason for that is once you learn AWS and let's say, you plan on going on with the other skills like the DevOps skills and the programming languages skills, you can actually skip Azure and GCP for a while, because when you apply for jobs, 31 out of 100, 31 companies would be using AWS, 16 companies would be using Microsoft Azure. And if I were to go by my memory, around 8 to 9% or 6 to 7% is actually by the GCP. So out of 100, 31 companies AWS, 16 companies Microsoft Azure, and 6 to 7 companies would be Google Cloud. So this is the current figure. So if you go by probability, you are likely to get a job as a cloud engineer if you know AWS, then if you know Microsoft Azure and GCP. But our aim is to know all the three. But if you were to plan as to how to learn all the skills that we have discussed today, you should start with AWS. So this point is specifically for that. And finally, according to Report Linker, so this was the fact that I was talking about in the beginning of the session, that right now the cloud industry has the revenue of around $258 billion annually, right? So by 2023, this is going to become $623.3 billion. That's more than the double of what the cloud industry is gaining right now, right? So this basically just tells us how much the cloud industry is going to grow in the future. All right. Moving forward, now let's talk about the job roles that you have in cloud. So I told you can become a cloud engineer, but actually a cloud engineer is basically a generic profile which companies post on the job portal. It is basically built up with a combination of job roles. So what are those job roles? So the first profile is solutions architect, which I told you about, wherein you have to plan, you have to know the in and out of your application. You should know which part of your application should be deployed on which service of the cloud. That job is basically the solutions architect job. Then you have the cloud developer. So cloud developer is a person who knows how to develop applications and also how to write SDKs so that the application can interact with the cloud services. So that's a guy who is a cloud developer. Then you have a person who is a SysOps administrator. A SysOps administrator is a person who basically manages the infrastructure once it has been deployed by the architecture, right? So once the infrastructure has been either designed or applied by the architect, the SysOps guy's job would be to implement that architecture or handle that architecture according to the norms that has been specified by the solutions architect. So this is what a SysOps administrator is. So for all my friends who have an experience in development and they feel that, I want to stay in development right now, I don't want to become a full stack cloud engineer, I basically want to be in development, but I would want some of my job to include cloud, then your profile that you're aiming for is cloud developer. For my friends who are already system administrators and they basically want to skill up themselves by becoming system administrators for particular cloud provider, they can basically aim for the SysOps administrator profile. And for the people who want to move up the ladder, they basically have around 14 to 15 years of experience either, or basically they are from a non-IT background and they want to shift in the cloud domain. You should start off with the solutions architect profile. Okay, there are some more profiles which are basically cloud network engineers. So people who are focused on just networking aspect of cloud, if you want to become a network guru, then in your case, you should opt for the cloud network engineer profile. And then you have the cloud DevOps engineer, which is basically a profile which basically expects you to know cloud in and out, which expects you to know DevOps in and out. And this is basically the profile that I was telling you about that you should aim for, right? You should know all the skills that are basically expected from a person who is a cloud engineer and basically then would become a generic cloud engineer who can apply to any company. So this is that guy. So your aim is this. If you want to start off from a particular point, your point would be this. You become a solutions architect first, get yourself certified in that, then work your way up for cloud DevOps engineer. And similarly, you can become a cloud developer or a SysOps administrator, and then you can get certified in cloud DevOps engineer. Similarly for cloud network engineer as well. Okay. Now we discussed all the jobs which are there in cloud. If you want to become a full stack, if you want to implement cloud in your job, I just showed you some profiles which you can get certified in. Now, some of my viewers today would be wondering, like, the current job that I am in right now, can I implement cloud in that? So let me show you some stats. So guys, the top 15 tech jobs which have the cloud related skills in the job description, that is what we are going to discuss right now. So guys, a software engineer, if you go by the generic job descriptions that we see every day, more and more software engineer job descriptions are expecting the software engineers to know cloud, which basically means if you are a software engineer right now and you are aiming for the future and you still want to be a software engineer, then almost 8 to 9% currently job description expects you to 8 to 9% of your job description. That means, let's say you have 100 skills, out of those 10 skills should be in cloud, right? So this is what the 7.92 number means. Then you have the senior software engineer profile, which basically again expects you to have around 6.7% skills in cloud. Software architect expects you to have 6.21%. So basically the aim is to show you guys that all the profiles that you see over here, although they do not coincide with any cloud profile, still they have some elements of the cloud skills in their job description, which basically means most of the companies which are related to IT today are doing something or the other thing on cloud, and that's why they expect all their employees to know cloud, right? So what I'm trying to tell you from this slide is whatever profile you are in, if you want to be relevant to the industry, you should know or you should start upgrading yourself with cloud today. Okay, then these are some of the other profiles that you can have a look at. For example, a cloud engineer profile, a generic cloud engineer profile, a data engineer profile, a Java developer profile, system engineer, data scientist, then a system administrator, Java developer, .NET, front-end developer, back-end developer. All of these people, they have some element of cloud skills in the job description, and that is what you should aim for. If you are currently sitting in these profiles and you don't have this cloud skill, you should get started today.
Just a quick info, guys. Intellipaat provides online AWS certification training in partnership with Future Skills, mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
So what I'll be doing is, first of all, let me go ahead and show you how a network like this is possible, where you do not have internet connection in one part of the network and you have internet connection in the other part of the network. Okay. So first of all, you'll have to sign up on AWS
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which one of the following cloud concepts is related to sharing and pooling the resources? A. Polymorphism. B. Virtualization. C. Abstraction. D. None of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Okay, so let me just quickly log in. And when you have signed up on the cloud, this is how your dashboard is going to look like. This is how your dashboard is going to look like. These are all the different kind of services that AWS offers, and we are going to make use of some today to do what we have to do. All right, great. So now that we are on this management console, the next thing that I'm going to do is I'm going to choose a service. So when you want to deploy any kind of server, if you want a machine from AWS, the kind of service that you have to make use of is called Elastic Cloud Compute, right? So the short form of this is EC2. So you will have to make use of a service called EC2. So EC2, you can choose, you can go to all services under compute, you will find the EC2 service, just click over there. And this is the management console that you will get. Okay, now my job is to deploy a server. I will do that, but first I need the network that we were talking about since the past 15-20 minutes. We need the network ready first, where we will be deploying our servers. Okay, so the EC2 service is for deploying your servers. Now for getting your network or deploying a network on cloud, there's again a service, and that service is called VPC, which is called Virtual Private Cloud. So we are going to type in VPC, and you will get isolated cloud resources kind of a service over here. Just click over it, and here you can deploy the kind of network that you want. Okay, so now let me brief you about what we are going to do. So first of all, whenever you talk about networks, guys, networks, the word network is can be a very big architecture, but networks have subparts to it as well, which are basically called subnets. So if I have let's say your office network, so you guys must be working in offices, you might be in colleges, so your office will have one network. Then in that one network, you will have, let's say, a network for the HR department. You will have a network separate for the developer department. Then you will have a separate network for, let's say, your leadership team. So everyone will have different access to the different part of the network, and every network will have its own access. Okay. So first of all, let's deploy the big network. Let's deploy a network for our whole application, right? And our whole application, I'm not restricting it to say that this whole network will have internet access or not. This is the overall network that we are deploying right now. And inside this network, then we are going to create subparts where we are going to uh, uh, define the functions that each subpart can have. For example, some parts will have internet access, some parts will not have internet access. So that is something that we are going to do now. Okay, so first let's go ahead and create a network. For example, let's create a network for your office. So let's call this network as Netflix. Okay, this is where all my resources are going to be. So I am going to name it as Netflix, and let me give an address. So everything that you deploy on a network has an IP address. For example, right now, if you're accessing the internet, your computer has an IP address. Why? Because you are connected to a network which is called internet. Similarly, if you are connected to your office network, you also need to have a separate IP address which will make you recognize on that network. Okay, so now what we're going to specify in this IPv4 CIDR block is
the range of IP addresses that I'm going to have. That is, let's say if your computer connects to my network, what is the kind of IP address which will be assigned to you? So let's say I specify over here that anyone who's trying to connect to this network will have an IP address which will look something like, let's say this. So this is the range that I'm specifying over here. So here in this range, so your IP address will always begin with 10.1, and then this number will change according to what your network configuration is. So this is the range that I'm specifying over here, and this range is where my application is going to be deployed in. Okay, so let's click on create, and what you have now done is you have created an office network, or you've created a network for your application. Okay, now inside this network I'm going to create subparts. Okay, because some resources I want to give internet access, and some resources I do not want to give internet access. So let's see how we can go ahead and specify that. Okay, so I have created a network called Netflix. Now inside this network, let's create some subparts. So for creating the subparts to a network, what you do is you create subnets. Okay, so I'm going to click on subnets. So let's create some subnets for my Netflix network. So I'll click on create subnet. Let's say what I'm creating right now is for a network which is going to have internet access. So let's call all the networks which will have internet access as public, and all the networks which will not have internet access as private. Okay, so let's call this network as public. And when you're deploying servers in AWS, you can deploy it in many data centers. Okay, so right now what we are dealing with is the Oregon region. So Oregon is basically a place in the US where AWS has many data centers. And how many data centers are there? There are almost 4 data centers that you can choose from. So let's create a public subnet in 2A data center. Okay, and let's call this public subnet as 2A. And this subnet will be deployed obviously inside my main network, which is Netflix. So let me select that, right? And it is going to be deployed in the 2A data center. And let me specify the IP address range, which is going to lie obviously between this particular IP range that I specified earlier. This will be the IP range where I will have, my resources will be assigned the IP address from. Okay, so let me specify it as 10.1.1.0/24. So these numbers that you see /16, they basically denote a range. 20. If I specify something called as /24, that's a smaller part of a range which is /16. Right? For example, if I specify, so just assume it like this: if I specify /16, there are going to be around 65,000 IP addresses that I can give using this range. Okay. Now, when I specify something as small as /24, I will have an IP range of around 256 to 256 servers. So I've just created public 2A, which is basically a part of my Netflix network, and it is deployed in the 2A data center, right? Similarly, let me create one more subnetwork. Let me call it as public 2B. This is going to be a part of the 2B data center. It is going to also have internet access. It is going to be a part of my Netflix. What do you say? It will going to be a part of the Netflix network, right? And the range is going to be 10.1.2.0/24. Okay, let's go ahead and create it. Okay, so now what we have done is we have created two subparts in the data center 2A and in the data center 2B. Now let's go ahead and create private subnets which are not going to have internet access. So let's create them. So let's call this as private 2A. It's going to be part of my Netflix main network. It's going to be a part of the 2A availability zone. And this is going to basically have this IP range. Okay. Now, similarly, let me create a private 2B as well. /24, and let me go ahead and create it. Okay. So, okay, there's a small change over here that I'll have to do. So once you have deployed it, guys, you can verify if it has been deployed in the correct data center or not. For example, private 2A has been deployed in 2A data center. That is great. But when we talk about public 2B, it has again been deployed in 2A data center itself. So what I can do is I can delete it quickly and I can create public 2B once more. Okay, so let me create public 2B, and VPC is going to be my Netflix network. It's going to be part of my 2B network, and this is going to be 10.1.2.0/24. Okay, so now I have private 2A, I have private 2B, I have public 2A, I have public 2B deployed, and these should be now in the respective data centers. If I've named it 2A, it's in 2A. If I've named it 2B, it's in 2B. If it's in 2B, it's in 2B, and 2A is also there in the 2A data center. Great. So I have my network deployed. Now let me go ahead and define their functions. So what I've decided is my public subnets will have internet access and the private will not have internet access. Okay. So what I'm going to do is first I need internet connection to my network. So how can I give internet connection to my network to these public subnets? Let me go ahead and tell you. So for example, if you need a Wi-Fi at your home, or if you need internet at your home, what do? You contact an internet service provider. They basically bring a modem to your home, and then that modem you connect to your Wi-Fi router, and by connecting to your Wi-Fi, you're able to use your internet, right? Similarly, if I want to give internet to my network, what I'll have to do is first I will have to go ahead and request for something called as a internet gateway. So let me create an internet gateway. Let me call it as Netflix network internet gateway. Let me create it. Okay, so it has been created, and now you see it in a list. So I've created the internet gateway. Now I will attach it to my Netflix network. So here you can see, you can find something called as attached to VPC. Let's click over here. Let's select the VPC that we want to connect to, which is Netflix. Let's select it, and let's click on attach internet gateway. Okay, so my internet gateway is now attached to my network. Okay, but still the resources that are going to be in my network, they will not be able to access it. The reason for that is whenever you deploy a resource in a cloud, it is not directly deployed in the main network that you created. It is always deployed in a sub part of the network, which is basically nothing but the subnets that you created. So the subnets that you have deployed, you have to configure them to connect to this internet gateway. Okay, now internet gateway is part of your network, but your subnets are not knowing about that internet network. So In a simpler way, if I were to tell you, you have Wi-Fi at your home, but you are not connected to your Wi-Fi. So your laptop does not know if it can connect to that Wi-Fi or not. Okay. So what I'll be doing now is I will go ahead to something called as route tables. So route tables basically specify which IP addresses can connect to a particular resource in the network and which IP addresses cannot. Okay, so let me go ahead and show you guys how the route table is basically going to be configured. So right now, there is one route table which is automatically created for your Netflix network. Let's call this route table as the internet route table. So whichever subnets or whichever part of the network are going to be connected to this route table will have internet access. And let's create a route table which is called non-internet route table. Right, and let's also deploy it in the Netflix network only. So this route table that I have created over here is going to have all the resources which do not have internet access. Okay, so to this non-internet route table, let's go ahead and attach the subnets which will not have internet, and to this internet route table, let's attach the subnets which are going to have internet. Okay, so first let's attach subnets to the internet route table. We'll click on subnet associations, and here, as you can see, there are no subnets attached to it as of now. We'll click on edit subnet associations, and we will attach all the public subnets where we need internet to this route table. Okay, so now the route table have been attached. The subnets have been attached to this route table. And now what you will do is you will specify a route to the internet gateway in this route table. And then what will happen is all the subnets which are connected to this route table will be able to see that internet gateway. Or in other words, whichever laptop is at your home will be able to connect to that Wi-Fi. Okay, so let's click on edit routes. Let's click on add a route. And here, let's say everyone in this network should be able to connect. So when you have to say everyone, you give a destination or IP address like this. Okay, so all the IP addresses which are there in this subnet should be able to connect to my internet gateway, which is this, right? And let's click on save routes. So now what have we done? Let's revise. So we connected two subnets to this route table, which basically I named them to be public subnets. And these public subnets, I have given a property to them that they can connect to the internet by using an internet gateway. Okay, so now that we have one network which is going to have internet with us and the other network which is not going to have internet with us, now what I'll be doing is so I think I've not connected the subnets to my non-internet route table. Let me go ahead and connect. I'll go to subnet associations of my non-internet and let me connect the private subnets to it. So private 2A and private 2B. Let me connect. Okay, so now I have the two route tables configured and I have my network configured in the fashion that I've just explained to you guys. And now one final setting that we will have to do is we will go to subnets. Now the resources which can talk to each other on the internet or which will basically have internet access, they will need a public IP address as well. If they don't have a public IP, be outside from the Netflix network will not be able to talk to them. Okay, so how do we configure our resources which are being deployed in the public subnet to have a public IP address? This is a small setting that you have to do. So you will be clicking on your public subnet. You will be going to actions. You will have to go to modify auto assign IP settings. click on enable auto assign public IPv4 address and click on save. So now all the resources which are going to be deployed in public 2A are going to have a public IP address. Public IP address is basically an address which can be reached out from the internet. Okay. All the 10.1 IP address ranges that I specified earlier are basically going to be a part of the local network, that is the Netflix network. But when we talk about the internet is also a network, right? So internet also has its own IP addresses which are given to people when they want to connect to each other, right? So for example, if I am connected to the internet, if I go ahead and see what is my IP address, this is the IP address that I have, right? And this IP address is basically given to me by my internet service provider. So similarly, if I want to deploy a resource on AWS which is connected to the internet and to which I want to connect to, it should have this public IP address. Okay, so that is what we have configured, that all the resources in my public 2A will have a public IP address, and even in public 2B, I will specify that they can have a public IP address. Okay, great. So now all the resources that I'm going to deploy in public 2A and public 2B will have an IP address. And now we can simply go ahead and go to my service EC2, which we talked about earlier, which is going to rent me servers. I will go to that service. And let me deploy some servers now. So what I'll do is I'll click on running instances. And let's click on launch instance. Okay. So the moment you click on launch instance, now let's see what are the kind of options that we see on the screen. So now when you want to rent a server from cloud, the first thing that you need to decide is what is the kind of operating system that you want to run on that server. Okay. So let's say I want to run a Linux server. So let me select Ubuntu. I want to run the Ubuntu operating system on my server. Okay, so I'll select it. And now it will ask me what is the kind of processor, what is the kind of RAM do you want for your server. So here's a list that you can select for. Now, if you want your server to be a part of free tier, you can see this green highlighted text over here which says free tier eligible. Select that. It will give you 1 core CPU and it will give you 1 GB of RAM. Okay, let's go ahead and click on next. Next thing it will ask you is what network do you want to deploy this resource in. So I want to deploy it in my Netflix network, right? And since this is going to be a public instance that I'm deploying, because first what I want to do is I want to configure my server that I'm deploying on AWS, and later I'll shift it to a private network where we will not be able to access it from the internet. Okay, so I am going to deploy it in the public subnet as of now, and what I'm going to do is rest I'm going to leave everything at default. I'm going to click on next. Now it will ask me what is the kind of space or what is the hard drive space that I want for my server. So when you deploy a Linux server, it has minimal requirements. So a Linux server with 8 GB of RAM will work, 8 GB of storage space will work. So I'll just click on next again. And now this is the place where people were referring to, will it have any firewalls? So when you talk about firewalls, you basically are referring to security groups in AWS. Okay, so my instance will basically, or my servers will be governed by a firewall which is called security group, and I can create a firewall or I can choose an existing firewall as well. So when you create a new network, what happens is automatically there's a firewall which is created, which is basically called the default firewall. So it's called the default VPC security group. Okay. If you select that firewall, what are the kind of things that you can configure over here? Let's see. So first of all, what you can configure is the kind of traffic which is allowed in this firewall. Okay. So right now it says all traffic is allowed. Good. What protocol is allowed? All protocols are allowed. Okay. So we'll have to restrict this firewall in a little while. We'll do that. What port range is allowed? Any port from any traffic is allowed. Okay. And who can connect to this firewall?
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which one of the following is cloud platform by Amazon? A. Azure, B. AWS, C. Cloudera, D. All the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Only the people who are part of this security group can connect. So this we will have to change, since I want to connect to the server to configure it. So I will have to put my IP address over here in the source. We'll do that in a little while. But for now, this is the firewall that you all were referring to, right? And this is something that we are choosing as default over here. You can create it as well. If you create it, you will again get the same options, but you will have to configure them. Okay, so let's click on review and launch. And now you can just review all the settings that you have done. If everything looks good, you can just click on launch. Now, AWS as a security option, it does not give you a simple password based authentication to your server. What it gives you is a file which you can use to connect to your server. Okay, so that file is basically called a private key file, which you will have to download from over here, right? So I have a file that I already created. It's called Mac Oregon. So I'm going to select that. I already have it on my system. If you don't have it, you're creating it for the first time, you will have to choose create a new key pair. Let me create it since we are doing it over here. Let's specify as Netflix demo. This is the file that I will be using to authenticate to my servers. Once you specify the name, just click on download key pair. This will be downloaded to your system, and then later you can use it to connect to your server. Okay. Now I click on launch instances. And with this, my server has now just been launched. Okay. And I've launched it inside a public subnet. Okay. So now I've just launched a server, right? And this server is now a part of my public subnet, which means this has internet access. So let's see what all things we have available for this server. So let's call this as Ubuntu server. Okay, so this has a public IP address. Great, I can use this IP address to connect to this server, right? It has the private IP. Private IP is basically the IP which is given inside the network. So as you can see, the range is 10.1, which is exactly what we specified, right? It is a part of the 2A data center, which is good. The firewall attached to it is default. So we will have to change the default rules for this firewall. And others you can verify whatever you configured, exactly those configuration you can see for your server over here. Okay. Now what I'll be doing is I will be selecting the security group, which is the default security group. And let me change the settings over here. So first of all, I'll be changing the inbound rules. So the inbound rules of my firewall right now are these. So let me change this. So I click on edit inbound rules. And now, first of all, let me tell the server that only I can connect to it. So I will specify my IP. And as you can see, this is my IP address that has been specified. So only my system will be able to connect to this server. And right now you can see this is the public IP that has been attached to my firewall. Okay. So any kind of traffic from my IP address will be allowed to this server. Okay. So this is the setting that I'm specifying right now. I'll click on save rules. And this setting is done. Now, this will be changed later when we will be deploying our full stack application. But for now, this is the IP range that I have specified. Okay. Now I'll go back to my dashboard. go back to my server. I select the server that I want to connect to. So this is the Ubuntu server. So you will notice I have some other servers, EC2 demo, which have been created over here. So this account is used by a lot of people. So you don't have to worry about the other servers which are being launched. Just select the server that you want to use. So in my case, it's Ubuntu. Now I'll be connecting to it. Okay. So this is the IP address that I'll be connecting from. Let's copy it. And now to connect to it, I will make use of my terminal. Okay. Now here is something that will be different, that can be different on your system. What is different on mine? So I am using a Mac operating system. So I have something called as a terminal, right? So this is a bash terminal that I'm going to use to connect to my server. Okay. Now, when you might be on a Linux, sorry, you might be on a Windows system. So in that case, if you want to connect to your server, you will have to basically make use of a software called Putty. Okay. So there's a software called Putty, which will basically make you to connect to your server, right? So what we basically make use of is the SSH protocol to connect to a Linux server. So this tool, the Putty tool, will help you connect to your server using the SSH protocol. So just click on the first link that you see. You can see it says you can download Putty over here. Just click over it. And here you can download, the Putty version. So you have to download the 64-bit version. In case your processor is 64-bit, if you have 32-bit architecture, then you will be selecting the 32-bit version. Okay. Once you download it, there is one more software that you have to download, and that is called Putty Gen. Okay. Download this as well on your system. Now, once you have Putty Gen and Putty downloaded, what you have to do is, you remember the key pair file that you got? This is the PEM file. This is the key pair that you got, and this is only for Windows system that I'm telling you right now, guys. So this PEM file is not compatible with your Putty software. Okay. So what you have to do is you have to convert this PEM file into PPK, and that can be done using this Putty Gen software that you will be downloading. Okay. So how you can use the Putty Gen software? Let me show you some screenshots. So this is how your software is going to look like. You don't have to enter any values in key comment key phrase. So what I'll do is, okay. So this is how your Putty Gen will look like when you open it for the first time. So what you have to do is you have to click on load. Okay, it will open a dialog box. Select the PEM file that you downloaded. Click on OK, and then click on save private key. Okay, what this will do is it will save a PPK format file on your system, and that is basically the file which you will be using now to connect to your server, right? So PEM files are compatible with Linux systems, but PEM files are not compatible with Windows systems when you're using the Putty software. So you have to convert it to PPK. Okay. So with that done, once you have the PPK file, next you will be opening your Putty software. So your Putty software will look something like this. Okay, this is the UI that you will get. So the IP address of your server will go over here in hostname. So this is my Ubuntu server. This IP address will go over here in this dialog box, the hostname. Okay. So once you put the IP address over here, next what you have to do is you have to click on SSH, right? And once you open SSH, you will find something called as auth under it. Click on auth, and then you will get a browse window over here. Okay, so if you click on SSH, you will click on auth, you will get a browse button over here. Click on this browse button, select the PPK file that you downloaded earlier, and then all you have to do is click on open. That's it. So once you click on open, you and I will be on the same user interface as what I'm going to show you as of now. Okay. So this is the only difference that is going to be there while I am doing this demo and while you will be doing this demo. So first step, you have to convert PEM to PPK using the Putty Gen software. put the PPK file over here in browse section of SSH auth, and then put the IP address over here by going to session, click on session, put the IP address over here, and finally click on open, right? So now a terminal will open just like this, and then I'll tell you what has to be done from there. Okay, so now what I'll be doing is, let me pass in the command. So this is the command that you will be using when you're on Linux. Okay, so people who are there on Linux, first you have to go to the folder which will basically have your PEM file, then pass in this command. So ssh-i basically means the server that you want to connect to. Sorry, the PEM file that you want to connect to. This is the PEM file that I'll be using to connect. And then now people on Putty, you will see a dialog box which will ask you for login as. It will ask you for username. So if you have launched a Linux machine which has Ubuntu operating system, the username would be Ubuntu. Okay, Ubuntu @ now when you just have to specify Ubuntu, hit enter, you will be logged in. People on Linux, you have to specify username @ of IP address of your server, and then hit enter. Okay, so it will ask you whether you trust the server. This will also be the same for people who are going to work on Windows. You have to type on yes, hit enter, and Windows people will be able to connect then and there to the server. People on Linux will find this kind of a warning which will say unprotected private key file. Okay, so you will have to pass in a command sudo chmod 500, which are basically going to change the permissions of your file, right? And then just change it with 500, and this should do the trick. Now pass in the same command, and there you go. I have connected to my Ubuntu server on AWS. So people who will be doing it on Windows, you will also see the screen as you are seeing right now on my screen, right? And this is how you connect to a server which is deployed on AWS. Okay, now that we have connected to our server, what I'll do is I will basically make it a web server, and then once our website is ready, we will deploy it in my private subnet, which is not going to have any internet access. Okay, so when you want to create a web server, first thing that you have to do is anything that you want to install on a Linux machine, first you update that machine. Okay, so I'll just type in sudo apt get update. It'll take like a minute to update the machine, or even less than a minute. So it took 10 seconds to update the machine. Now what I'll be doing is, so this is the command that I passed to update the machine, sudo apt get update. Next thing that I'll be doing is I will be installing a web server. So sudo apt get install Apache 2. So this is a web server which is now getting installed. Okay, so I just choose yes. Okay, so web server is now being installed. And after this, we'll do a very cool exercise, guys. So you will be able to see that if I go to the IP address of my server now, so I just type the IP address over here in the browser. You can see I can able to access this page in my browser. Okay. Okay. So now what I'm gonna do is, guys, I'm gonna basically go ahead and define a web page over here. So let me show you how we are going to go ahead and define our web pages. Okay, so what I'm going to do is this is the architecture that we are going to deploy now. So I will have a separate web page for streaming servers. One second. So I will have a separate web page for my video page, and I will have a separate web page for my home page. Now let me show you why we are going to do like this. So let me go ahead and open the website called netflix.com and just see what is the behavior. So if I go to netflix.com, I automatically go ahead and get routed to netflix.com/browse. Okay. And if I select the account that I want to use, it's still the URL over here. It's netflix.com/browse. So netflix.com/browse is taking me to the homepage of Netflix. I hope everybody is clear here. Okay, now what happens if I play a video? Okay, so let me play this series over here. So now what you can see is the URL changed to netflix.com/watch, and then you have some numbers over here, which probably would be the numbers for your video. Okay, so you have connected to netflix.com/watch. One second. You have connected to netflix.com/watch in order to get to this page where you're playing this video. Okay, now let me show you what happens when you play some other video. So I'll again click on back. Let me play some other video. So let me play, let's say, this Space Force. Can you still see? It's still netflix.com/watch, and then you have these numbers which are after this URL. So these numbers basically are referring to the video which is playing on this page, but this page is same all the time. The page is always netflix.com/watch, which is basically referring you to this video player. And then to this video player, what you're doing is you're providing this number, which is basically now going to play the video that you are launching over here. Let's see if we remove the track ID, what happens. Okay, so this is the number which is associated to the video that you are playing, right? And this is the page that you're going to. You're always going to netflix.com/watch. So if you go to netflix.com/watch, you open the video player, and to that video player you tell, okay, so this is the video that I want to play, and that is what is being played over here. So let's see if I just type in watch, what happens. Okay, you can see they have.
Just a quick info, guys. Intellipaat provides online AWS certification training in partnership with Future Skills, mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
Routed me to something else because they do not want me to, just access the web, the video player. So when I go to netflix.com/watch, they basically reroute me to some other URL. But you now understand the working of Netflix. What they do is, if you go to netflix.com/browse, they are routing you to the home page. And if you go to netflix.com/watch, and some video ID, if you specify, it will take you to that video which is being played. Okay, so now let's see how we can mimic this architecture on our system. So what I'm going to do is, if I go to netflix.com/home, I will be taken to the home page. And if I go to netflix.com/stream, or let's make it watch. So if netflix.com/watch, if I go to, it will take me to the video player. Okay, so this is something that we are going to configure now, and this we are going to do using the AWS infrastructure. Okay, so first of all, let's create a home page. Let's create a page that we will be routed to if you go to /home. Okay, so what I'm going to do is, this is my web server where I'm able to go and see this page. Let's change this page to look like a home page. So what I'll do is, so once you have an Apache 2 server which is running, you can go ahead in this path /var/www/html, and this will have a page called index.html. Okay, so this index.html page, if you change this, your HTML will change over here. Okay, so for now, let me first delete this index.html page, and now let's create a new index.html page which says, let's say, welcome to home page. So I will create an HTML page which will, this is a very simple HTML code that I'm writing over here, which will says welcome to the home page. Okay, so this is what I've created, and if I refresh over here, you can see it says welcome to the home page. And even you guys, if you refresh, you will be able to see this particular web page which says welcome to the home page. Now our web page, our web server, our home page is now ready, and now what I'll be doing is I'll be deploying this inside a private subnet. So let's see how we can do that. So for doing this, I will first go to my dashboard, and this is the server that I created. So let me create a copy of this server first, and then that copy I will deploy it in the private subnet that we created earlier. So I'll just select the server that I created, click on actions, then you have something called as image. So let's create an image. Image is nothing but it creates a copy of your server which can be deployed multiple times then. So we'll create an image. Let's call this image name as homepage, home, Netflix-home. Let's specify this. Right, let's click on create image, and now my image is getting created. Okay, and that image will basically have this web server already deployed. Great. So now that it is happening, I think it will take a minute or two to create that image, and you can see that image in the under the image section in AMIs. So if you go to AMIs, you can see that a Netflix home image is being created, and it is in the pending state as of now. So I think if we refresh it a couple of times, you can see it will change to available. So let's wait. So while this is happening, let me explain you how the other things are going to work out. So as you must have noticed, right? So if you want to have a home page which is going to be separate, and if you want to have a watch page which is going to be separate, you will be dealing with two servers, right? And if you're dealing with two servers, you obviously will have two IP addresses, right? But as you can see from the behavior of the Netflix website, the URL always remains the same, right? Only the web page is changing. So how do we accomplish that? So we can accomplish it by having a common medium in the middle, which can connect to both my watch page and my home page. Okay, so this resource, which is the elastic load balancer that we're going to deploy in a minute, is going to have a URL which is always going to be the same, And this load balancer we can configure to understand if the URL is /watch or /stream, it is always going to route my request to the streaming servers. Whereas if my request is /home, or let's say just slash, or just say no URL at all, in that case it will be routing my request to the home page. So this is possible using the elastic load balancer, right? And this is something that we are going to go ahead and deploy now. Now I think we are ready to now understand how our architecture is going to be deployed. So now what I'm going to do is all my servers, they are going to be a part of my private subnet where I do not have internet access, right? But as we have known from the previous from our previous understanding, we know that everything within a Netflix network will be able to interact with each other. Okay, so in my Netflix network, I have a public subnet, I have a private subnet. So private subnet does not have internet access, public subnet has internet access. So in my public subnet, I'm going to deploy my load balancer, right? In my private subnet, I'm going to deploy all my servers, right? And these servers can only be accessed by the load balancer and nothing else. Okay, nobody else will be able to connect to these servers directly. Only through my load balancer they will be able to access my servers. And this is a very good architectural practice when we talk about having security for our servers. Why? Because you can control which protocols can you interact with in your load balancer. For example, let's say a hacker wants to go ahead and make use of servers. They want to pass some commands, as I did on this terminal. Okay, so if you want your load balancer to restrict that, your load balancer will only allow HTTP traffic. What is HTTP traffic? HTTP traffic is the traffic that you get from your web browser. So only the web browser's traffic will be enabled through your load balancer. If somebody is trying to pass some command, if somebody is trying to connect through some other protocol, it will not be allowed. Okay, and even in that case, your load balancer will only allow some URLs. So only if you type in /home, you will be allowed. If you are typing something else, you will not be routed to my server. That again is a very good security aspect, that if your URL is pointing to netflix.com/home, only then you will be reaching my home server to access that content. You cannot access my content from any other medium from that particular server. Okay, so this is how you can restrict hackers or restrict attackers from accessing your server, and it's a very good architectural practice to have your architectures deployed like this. Okay, as I said earlier, we are inside one network, and the Netflix network that we created, right? That is the big network that we created. Inside that big network, we created small networks, which were public and private. Public had internet access, private did not have internet access. Okay, so all these resources which are a part of the big network, which is Netflix, all the resources can talk to each other. Now imagine this rectangle is my private subnet. Okay, and this rectangle is my public subnet. And what is the difference that I told you between the two is the public subnet has internet access. The private subnet, it does not have internet access. Okay, so if I connect to a server which is there in my public subnet, right? Because I'll be able to connect to it. Why? Because it has internet access. If I connect to a server in the public subnet, I can then connect my private server through this public server, right? If I connect to this Ubuntu server on my terminal like this, and then in this server which is there in the public subnet, if I enter the SSH command again, and I enter the IP address this time, the private IP address of the private server which is deployed in the private subnet, will I not be able to connect to it? if I have a private machine which is deployed in this private subnet, if I have to connect it from my machine, what I'll be doing is I'll be launching a machine in the public subnet, and through that I will be connecting to it. So coming back, now we have our homepage image ready, right? Now let's create an image for our streaming server as well. So what I'll do is, again, let's create one more image from this server itself. Let's again go back to this directory. Let's change the index.html, and this time let's say welcome to the streaming page. Save it. Okay, and now if you go to this IP address, you will see it will now say welcome to the streaming page. Okay, and now let's create an image out of this as well. So again, we'll go to EC2. So in our Ubuntu image, we'll go to image, we'll go to create image, and let's call this image name as Netflix stream. Okay, so now the image will be created for that as well. Now what I'll do is I will go ahead and launch my home page in my private subnet. So let's see how we can do that. So I click on launch instance, and I will choose my AMIs over here. I'll not choose any operating system now. I'll just choose my AMIs. And now I will choose the Netflix home image, which I created earlier. Let's select it. I want to launch it in the free tier server. Everything is going to be the same that we did earlier. Just that now I will be selecting a private subnet which I'll be deploying it in. So I'll be choosing the private 2A network. Let's deploy it over here. And this is our home page that we're deploying. Security group, we will select again the default security group. And we're going to restrict it. Don't worry about that. We're going to restrict that security group. And let's choose the same key pair that we used earlier, Netflix demo. Acknowledge that we have it and click on launch instances. So this is now getting launched in US West 2A. It's going to be launched in the 2A data center. This is basically now called Netflix-home. This is the home server that you have launched, home page that you have launched, and it will take a little while. And as you can see, it is now running. Now, if you have a look at the settings of this server, you will see that it will not have a public IP address, right? Why? Because we deployed it inside a private network, right? But it will have a private IP address. But this private IP address can only be reached out within the network. It cannot be reached out from outside of the network. Remember this, okay? So this is the IP address that we will be connecting through from our public instance, which is nothing but this instance that we connected to earlier. All right. Okay. So we have launched our home page. Now let's go back. Let's see if our streaming page is ready. So even streaming page is now ready. Let's launch this as well. So I'll just select the streaming image, click on action, click on launch. This is another way of launching it, right? This is the server that I want to launch. I want to launch it under the free tier. It will be deployed in the Netflix network. And this time I'm going to deploy it in private 2B data center. Okay. Everything else going to be the same. Security group, I'll select the default one. Click on review and launch it. Select the same key pair that I selected earlier, acknowledge that I have it, click on launch instances, and with this, my streaming page.
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which one of the following cloud concepts is related to sharing and pooling the resources? A. Polymorphism. B. Virtualization. C. Abstraction. D. None of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Has also been launched. Okay, great. So now I have two servers which are now deployed inside private subnets, and as you can see, I do not have a public IP address over here. Okay, and hence I will not be able to access them from the internet. These are not having any internet access, and I will prove it to you in a little while. Okay, so I have the home page which is now running. I have the stream page which is now running. I have, let's name it as proxy server. So I have a proxy server which is running in the public subnet, which has internet. Now what I'll do is, using this proxy server, I will be connecting to this home page and the stream page server. So let's see how we can do that. So first we need to copy the PEM file that we have on this proxy server. So let's copy it. So the way you can copy it is, use a command called SCP, which is called secure copy. So first you will have to authenticate yourself using, the proxy server's PEM file. Then you will have to specify the file that you want to copy. So the file name is again this PEM file I want to copy, right? Where do I want to copy it? I want to copy it on the proxy server, which is this IP address. And I want to copy it in this particular file location, which is /home/ubuntu. Hit enter. Since I specified sudo, it is asking me for my computer's password. Specified that. And now the file has been copied successfully. So now if I SSH into my server again, you can see that the file has been copied, netflix-demo.pem. It has been copied onto my proxy server or my public server that I launched earlier. Okay. Now people on Windows, if you want to do the same, what you can do is follow a simpler method. You can download a software called FileZilla. Okay. So FileZilla helps you to copy files from your local system to your specified server, right? The next thing that I will be doing is I'll be connecting to my private server. Now, where is my private server? My private server is this. Let's connect to a Netflix home server. Okay. So Netflix home server, this is the IP address, the private IP address for my Netflix home server. Let's try to connect to it. So I will be typing in SSH-I and then the PEM file, the username, and then the private IP address. So as you can see, earlier my IP was 10.1.1216. Now it has changed to 10.1.3.193. And that is the IP address of my Netflix home server. As you can see, the private IP address of my Netflix home server is 10.1.3.193. So this basically means I have successfully connected to my private instance. Now, for some of you who still have a doubt whether, if I pass this on my local machine, what will happen? So right now I'm inside the AWS server, right? But let's say, this is the terminal for my local machine. If I pass the same command over here, okay, first let me go to the folder which has the PEM file. Okay, so if I pass in the same command over here, you will be able to see it will not recognize what this address is. Can you see it's not connecting? It's not doing anything. Why? Because it does not know what this IP address means. Why? Because my local machine is not a part of the Netflix network, which is there on AWS, right? But this machine is, and that's why when I passed this command, it was able to connect to this Netflix home server. Now what I'll do is I'll just check if the web server is running. Yes, so it is active, it is running. That means if I curl, so this is something that I'm just doing for my checking, guys. If you don't understand, it's fine. Okay, so that means my Apache server is working on Netflix home, which is great. So let me just exit. So I've exited, and now I'm back to my public server. You can see the IP address changed. And now let me log into my Netflix streaming server as well. So I'll just change this IP address to my stream server. So my Netflix stream server has the IP address as 4.167. Let's specify that. So as you can see, I have connected to my Netflix stream server now. And if we check if the web server is running over here, yes, it is running over here as well. Great. So both my servers are running fine, and I've just showed you how to if some maintenance is required, how to do maintenance on your private machines. Right now, what I can do is once maintenance is done, I can just delete this proxy server, and then I'll not be giving any access to my uh, private machines. One thing that I forgot to show you was, let's say this is my public machine that I've launched on right now, right? This is my proxy machine that I've connected to, right? This has internet connection. How do we know that? First of all, we are able to access it from my local machine. At the same time, if I type in curl google.com, you can see that there is a response that I get, right? But if I, let's say, go to my private machine, right? And if I do a curl google.com over here, you can see that I'm not getting any response over here. Why? Because this machine does not have internet access. Okay, and this proves that. Great. Let me exit. And now that our web servers are ready, they are ready inside, a private subnet. Let's configure our load balancers to connect to this machine. Let's create a load balancer. So I'll just scroll on my EC2 console, and I will be able to see something called as load balancers over here. Let's click over it. So let's click on create a load balancer, and I will be creating an application load balancer. So application load balancer basically works on the application layer, and it basically helps us to do path-based routing, which is something that we are trying to accomplish, which is if I go to netflix.com/stream, I should be going to my stream server. If I go to /home, I should be going to my home server. So we'll be creating an application load balancer. Let's name it as Netflix-demo. This is going to be an internet facing load balancer, right? And the protocol that we are going to use is HTTP protocol. Okay, so here, as you can see, this is very important. So the only protocol that this load balancer is going to allow is HTTP protocol, nothing else. All right. Which VPC will this load balancer be a part of? It will be a part of the Netflix VPC, and this has to connect to 2A and 2B servers, private servers. So if they have to connect to private servers in 2A and 2B, this load balancer has to be deployed in public 2A and public 2B. Only then it will be part of the network, and then it will be able to connect to your machines. Okay, so what is the configuration that we did here? So you have configured your load balancer to connect to your private machines only using the HTTP protocol, nothing else. Okay, let's configure the firewall for this. So firewall, we'll be using the default firewall only, will not be making any changes. Let's specify routing now. So for routing, you will have to specify which servers to connect to, right? So right now, let's go ahead and specify a target group. Let's name it as public-server. And now let's go ahead and specify the public server IP address. So the way I can do that is by specifying the the servers that I'll be able to connect to, right? So what I'll do is target group is nothing but the set of servers that you can connect to, right? So let's specify the name of this to be, let's say this is the home page server, right? Let's click on next. And now what I can do is I can select the home page that I want to connect to. So this is the home page that I want to connect to. And let's click on next again. So this is the target group that I've just created for my home server. I'll be creating one more target group. Don't worry about that. So let me first create it and then I'll explain you what I've just done. So let's create this load balancer now. Okay, so load balancer is now created. Next thing that we will be doing is we will be creating one more target group. So we have created one target group for homepage server. Let's create one for streaming server. Okay, this streaming server will also be a part of the Netflix VPC. And now let's go ahead and click on create. Okay, so now my target group has been created. So I have a homepage server and now I have a streaming server as well that I would want to connect to. And in this, so homepage server should have the homepage server connected to it. So it is not connected. Let's connect the homepage server over here, which is Netflix home server. Let's register it to this target group, save it. And similarly, in my streaming server target group, let's connect our stream server, register it, and click on save. Okay, so both of these now have the targets attached to them. And now what we can do is, now we will be specifying the rules for our load balancer. So let's go back to our load balancer. And now what I can do is, so now I have to specify this routing rule, which is if I go to /stream, then it should connect to the target group of my streaming server. And if I go to /home, it should connect to the servers of my home server, the server of my home page. Okay, so let's see how we can configure that. Okay, so you will have to go to listener and then you will have to specify rules. So let's go ahead and edit these rules over here. Okay, so right now what is happening is anything which is going to this server, it will be routed to the home page server. Okay, so let's add a route over here. Let's click on insert rule and add a condition. So we'll be adding a condition for a path, and the path will be if it goes to /stream or let's say /watch, right? It should then forward this request to the streaming server. All right. So if the path is /watch, the request will be forwarded to the streaming server. Okay. If there is no path specified, it will be routed to my homepage server. If there is, let me specify one more thing. Let me first save it, right? And let us add one more rule. So if the path is /home. Okay, let's try and see if this works for us. So if I'm going to /watch, yes. So the star was missing over here. So now if I'm going to my load balancer /watch, I'm going to the streaming page. And similarly, what I'll also have to do is, let me exit and let me go to my home server as well. Okay, so here as well, I will have to add a home directory. Let me quickly do that. Okay, and now if I go to my load balancer, let's say I'm going to /home, you can see I'm being routed to the welcome to the home page. And if I'm just going to the URL, then also I'm being routed to welcome to the home page. Okay, so now what we'll be doing is, now we will be connecting a custom URL to our load balancer. And so first things first, what you need is a URL first. So what you need to do is just go to your Freenom website. So there's a website called Freenom. It basically gives you free URLs. Okay. So just sign up on Freenom. Okay, I'm connected. Let's go to my domains. So right now I have some domains, but I'll be showing you once you sign up, how you can create your own domain. So what I'll be doing is, as you can see, these are some domains that I have. I'll be creating a new domain, just like you guys would be doing when you sign up. So I'll just go to register a new domain, go to services, go to register a new domain. And in register a new domain, just specify the name of the domain that you want. So in my case, I want Netflix-demo. Let's check the availability. So as you can see, these are all domains which are free and I can get them. So let's get this domain, check it out, continue. And just agree to the conditions and click on complete order. So with this, your order has been confirmed and you can now go ahead to my domains. You have the Netflix demo domain registered to you. You can just click on manage domain. And here you will have to go to click on management tools and then click on name servers. Okay, and what you have to type in is custom name servers. So these are some name servers that you have to fill in. Now, how can you fill these name servers? Again, go back to your AWS Management Console, click on services, type in Route 53. Now, once you're inside Route 53, you will have to choose a hosted zone. Let's click on create hosted zone. And over here, just type in the domain name that you created. So it's Netflix-demo.tk. Give the same name over here, click on create. and this will create a hosted zone for you. Now, as you can see, these are name servers that you will have to enter over there in Freenom. Okay, so just select this, copy these name servers one by one. Go to the second name server, again copy it from here. Third name server, again copy it from here. Fourth name server, again copy it from here. Okay, so that's all the changes that you have to do on Freenom. You can close it now. Now in Route 53, you just have to do one small change. Click on create record set, right? And now what you'll be doing is you'll be pointing. So what have you done so far? You have mentioned these name servers in your Freenom website, right? So now your domain will be pointing to these name servers, which are basically the Route 53 service that you have. Now this Route 53, you will have to point to your load balancer. So how will you do that? You will find this section called alias, click on yes. And here you have to select your Netflix demo load balancer. Okay, click on create. So entry is made over here. Similarly, one more entry you have to create with the similar settings, just that in name you will have to enter www as well. Click on alias yes, select the load balancer, click on create. Okay, so with this, now your Route 53 is ready. And now what you can do is just go to a browser, type in netflix-demo.tk, hit enter, and it will now route you to the home page directly. And now if you go to the URL /watch, it is now pointing you to the streaming page. And this is exactly what is happening on your Netflix website as well. So let me quickly show it to you. Okay, so if we go to netflix.com/browse, it'll take you to the home page. If you type in netflix.tk/home, it'll take you to the home page. If you type in netflix.com/watch and then the video title, it will take you to the video player, which will play the video file for you. And similarly, if here you go to netflix.com/watch, you will be taken to the streaming page. And guys, this is how you mimic the architecture for Netflix on AWS.
What's new in AWS? First, AWS is the #1 cloud provider according to the market share and the growth rate. AWS basically hosts 1 out of 3 websites on the internet. That basically means any company you're looking into might be using AWS and you can get a job easily. It provides a high salary as well. So now let's start with the main part of this session, which is what's new in AWS. So the first thing I wanted to talk about is the availability zones, because whenever a company wants to go global, when they're using a cloud service, they'll basically look for a cloud provider who has an impact globally, who can reach every single country in the world. So that is done exactly by AWS. So AWS has 77 availability zones in 24 different geographical regions. So geographical regions in the sense different countries and different locations in countries, and they have 77 different data centers running across the entire globe. Okay, so this basically means if you are having an application and want to host it from your country, let's say you're in India and you're hosting an application for India, but right now your application is growing pretty well and you want to move your customer base into a little bit of Southeast Asia, let's say Singapore and some areas of let's say Japan or something, so you can move your applications architecture to those data centers as well. And right now, as of 2020 December, they have 77 availability zones and they are continuously growing. Next is the Gartner report on cloud services. So I already told you Amazon Web Services are the top leaders in the cloud provider platform. So now, according to the Magic Quadrant of 2020, AWS are in the top right corner, which basically means that they are the best in what they do. So they are leaders and visionaries. Basically, what they are telling is that in terms of execution and in terms of completeness of what exactly they have to do or their vision, they are the top among all the other 7.
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which one of the following is cloud platform by Amazon? A. Azure, B. AWS, C. Cloudera, D. All the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Vendors which are named over here. So Amazon Web Services is the top right. Next comes Microsoft, then Google, then Alibaba Cloud, Oracle, IBM, and Tencent Cloud. So now again, this is the 2020 Magic Quadrant and AWS tops that as well. And coming to the next part, which is something exciting, which are local zones. So local zones is not a 2020 thing, but the first local zone was launched in December last year, that is 2019 December, in Los Angeles, and in August of 2020 another local zone got launched in Los Angeles itself. So first of all, let me give you a brief about what is a local zone. So you have an idea about a region and an availability zone, right? So a region is a location in which AWS has its data centers. In that particular region, the AWS has multiple data centers. It can have 3 or more data centers in the same location. So now local zones are not basically covering a huge area. Local zones are a type of AWS infrastructure deployment that basically places all the available resources provided by AWS like compute, storage, databases to select services close to large population industry and IT centers. So basically the local zones especially concentrates around the city and around a large population where there is an industry or there are IT centers which they can collaborate with to bring the application speed really up. So they just wanted to reduce the latency of the applications. While you're using a local zone, the people in the city can actually use the application in really fast speeds. So that is the main motive of an AWS local zone. So now you can basically extend your VPC into a local zone as well. So let's say you are having your AWS VPC in one region, let's say North Virginia in USA, and right now you want to move it to a local zone. So you can do that by enabling AWS local zones in your console, and you can build your applications and run them on both the actual data center and also the local zone to give a faster access to the people in that city who are constantly using that application. Okay, so this is a new feature and it's getting popular right now because they already opened 3 in December 1st. So they're going to launch 3 more and it has already been done, and they are going to bring 12 more new local zones in 2021. So local zones are increasing. So right now they are concentrating on USA, and once it is successfully established in USA, they'll bring local zones to other countries as well. Now the best services came out in 2020. Best AWS services which came out in 2020. So there is Amazon Honeycode, there is Code Guru, there is Snowcone, and IoT Sitewise. Now coming to Honeycode, it basically allows the customers or the clients to basically build mobile and web applications. So you don't need to write any code, but it helps you build mobile and web applications. So it basically helps you bypassing hiring developers. Instead, you can just do the simplest tasks. Let's say you want to email your Excel files to someone and automate that. You can do it with Honeycode, and you can do it without the help of a developer. You can do it by yourself. That's exactly the purpose of Honeycode, and it's a new service which came out in 2020. Next is Code Guru. So it's basically powered using machine learning. So it basically helps the developers to create better applications by providing automated recommendations So basically, let's say you have your Java code or your Python code or whatever code it is on Code Guru. So now while you're having that code in Code Guru analyzes it and gives you recommendations of how to improve your code or how to remove certain lines of code which could be expensive for the application. Next comes Snowcone. So there was Snowball and Snowmobile previously. So Snowball was a bigger box where you can load data from your own on-premise setup and you can just ship it to AWS and they'll upload it in the AWS data centers. And there was Snowmobile, which was basically a truck with servers and storage units within it, and you can upload your entire on-premise data into that and it'll again get shipped to the AWS architecture. So like that, AWS have introduced a new tool called Snowcone. So it is basically the smallest member of the Snow line. So there is Snowmobile, which is the largest one. There is Snowball, the intermediate, and right now this is the smallest one, which is Snowcone. So it's basically, again, it's a portable device and it has rugged edge computing. It can be used for collecting, processing, and transferring data to the AWS cloud from disconnected environments outside traditional data centers. So basically you can buy or order this from AWS, and once it arrives, you can basically copy the data from your traditional data centers and send it back to AWS, and they'll basically take it and upload it to your AWS storage. Next, finally comes IoT Sitewise. So now IoT Sitewise is a managed service. It basically collects data from sensors and industrial equipments, whatever it is, whatever service or whatever tool you name it, it will collect data from it, and it will basically help the customers who are using IoT Sitewise to make better business decisions. So basically it's a recommendation engine for IoT. So now customers can use AWS IoT Sitewise to also monitor the operations occurring at those IoT facilities, and it can prevent costly equipment issues and also the production gaps, because it provides you data in real time and you can understand where the problem exists and you can correct it in real time. So these are 4 new exciting services provided by AWS in the year 2020, which are going to get carried over to 2021 because Honeycode is still in beta and soon it will become the official version. CodeGuru, IoT Sitewise, Snowcone are already available, which are currently in usage, and these are some of the new tools. There are also so many other new services. There are so many other new features within applications itself. For example, EC2 released new set of instance types, so you can go check that out because they keep releasing new instance types each and every month. You can just go check that out and I'll show you exactly where you can check it out as well. So now the monthly spending on EC2. So this is just the spending on a single AWS service, EC2, and I've just put in the top 4 companies who are using EC2 right now. So Netflix is using EC2 and they're paying around $19 million per month just using EC2 because Netflix uses more than 100,000 servers at any given point in time. So they'll be using 100,000 servers plus in any given point in time because they have a large customer base and they'll have to provide fast and quick streaming services to every one of them. So next comes Twitch. Again, it's a live streaming platform and obviously it needs a lot of server compute power, and in that case they are paying $15 million. LinkedIn, a huge job portal and also connecting multiple people across the same or different skills. So it pays $13 million. And Facebook, we already know what Facebook is, and it pays $11 million for EC2 each month. So these are the top competitors, or these are the top companies who are using AWS EC2, and obviously use other services as well, because if they're using EC2 they would need other services to accommodate it, and they're obviously spending a lot on AWS, and that basically means AWS is worth it instead of an on-premise setup.
Just a quick info, guys. Intellipaat provides online AWS certification training in partnership with Future Skills, mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
So the first question says, what is the difference between an AMI and an instance? So guys, an AMI is nothing but a template of an operating system. It's just like a CD that you have of an operating system which you can install on any machine on the planet, right? Similarly, an AMI is a template or is an installation of an operating system which you can install on any servers which fall into the Amazon infrastructure. All right, you have many types of AMIs. You have Windows AMI, you have Ubuntu AMIs, you have CentOS AMIs, etc. There are a lot of AMIs that are present in AWS Marketplace, and you can install them on any servers which are there in the AWS infrastructure. All right. Coming on to instances, what are instances? So instances are nothing but the hardware machines on which you will install AMI, right? So like I said, AMIs are templates which can be installed on machines. These machines are called instances. And again, instances also have types based on the hardware capacity. For example, a 1 CPU and 1 GB of machine is called T2.micro, right? Similarly, you have T2.large, you have T2.extra large, then you have IO intensive machines, you have storage intensive machines, you have memory intensive machines, and all of these have been classified in different classes, right? Depending on their hardware capability. So this was the difference between an AMI and an instance. Our next question asks us, what is the difference between scalability and elasticity? Alright, so guys, scalability versus elasticity is a very confusing topic, and if you think about it, so scalability is nothing but increasing the machine's resources. For example, if your machine has 8 GB of RAM today, you increase it to 16 GB. Therefore, the number of machines are not increasing. You're basically just increasing the specification of the machine, right? And this is called scalability. When we talk about elasticity, we are basically increasing the number of machines present in an architecture. We are not increasing the specification of any machine. For example, we choose that we require a 3 GB machine with say around 8 GB or 10 GB of storage, right? So any replica which will be made or any auto scaling which will happen, it will only happen to the number of machines. It will nowhere be related to the specification of the machine. The specification of the machine will be fixed. The number of machines will go up and down, and this is called elasticity. On the other hand, scalability is basically termed as the change of the specification of the machine. That is, you're not increasing the number of machines, you're basically just increasing the specs of the machine. For example, the RAM, the memory, the hard disk, etc. And this is the basic difference between scalability and elasticity.
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which one of the following cloud concepts is related to sharing and pooling the resources? A. Polymorphism. B. Virtualization. C. Abstraction. D. None of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Moving forward, our next question is, which AWS offering enables customers to find, buy, and immediately start using software solutions in their AWS environment? Now, you can think of it as, say, you want a deep learning AMI, or you want a Windows Server AMI with specific software is installed on it, right? So some of them are available for free, but some of them can be purchased in the AWS Marketplace. So the answer for this is AWS Marketplace. It's basically a place where you can buy all the AWS systems that you, or all the AWS or non-AWS softwares that you require to run on the AWS infrastructure, right? So the answer is AWS Marketplace. Moving on, our next question would fall under the domain of resilience architecture. So all the questions that we'll be discussing henceforth in this domain will all be dealing with the resiliency of an architecture. All right. So a customer wants to capture all client connection information from his load balancer at an interval of 5 minutes. Which of the following options should be chosen for his application? All right. So I'll read out the options for you. The option A says enable AWS CloudTrail for the cloud balancer, for the load balancer. Option B says CloudTrail is enabled globally. Option C says install the Amazon CloudWatch logs agent on the load balancer. And option D says enable CloudWatch metrics on the load balancer. All right. Now, if you think about it, CloudTrail and CloudWatch are both monitoring tools. So it's a bit confusing, but if you have studied it deeply, or if you understand how CloudTrail works and how CloudWatch works, it is actually not that difficult. All right. So the answer for this is A, that is, you should enable AWS CloudTrail for the load balancer. Reason being, option B is not correct. CloudTrail is not enabled by default or is not enabled globally to all the services. Option C says install Amazon CloudWatch. So option C and option D, you will not even consider, reason being that you're talking about the log of the client information, right? What all people are connecting to the load balancer, what IP addresses are connecting to the load balancer, etc. CloudWatch deals with the local resources of the instance that you are basically monitoring. For example, if you are monitoring EC2 instance, CloudWatch can monitor the CPU usage or the memory usage of that particular instance. It cannot take into account the connections which are getting connected to your AWS infrastructure, right? On the other hand, CloudTrail deals with all these kind of things wherein client information or any kind of data which can be fetched from a particular transaction, all of that can be recorded in the logs of CloudTrail, and hence for this particular question the answer is enable AWS CloudTrail for the load balancer. Moving on, our next question is, in what scenarios should we choose classic load balancer and application load balancer? All right. So for this question, I think the best way to answer this question would be to understand what exactly is classic load balancer and what exactly is application load balancer. All right. So a classic load balancer is nothing but, it's an old-fashioned load balancer which does nothing but round-robin based distribution of traffic, which means it distributes traffic equally among the machines which are under it. It cannot recognize which machine requires which kind of workload or it requires which kind of traffic. Whatever data will come to a classic load balancer will be distributed equally among the machines which have been registered to it. On the other hand, application load balancer is a new age load balancer which basically deals with identifying the workload which is coming to it, right? It can identify the workload based on two things. It can either identify it based on the path. For example, you can say that you have a website which deals in image processing and video processing. So you can say it might go to intellipaat.com/images or /videos. So if the path is /images, the application load balancer will directly route the traffic to only the images servers, right? And if the path is /videos, the application load balancer will automatically route the traffic to the video servers. And this is application load balancer. So whenever you are dealing with multivariate traffic, that is traffic which is meant for a specific group of servers, you would use application load balancer. On the other hand, if you have servers which do the exact same thing, right? You just want to distribute the load among them equally, then in that case you would use a classic load balancer. Our next question says, if you have a website which performs two tasks, that is rendering images and rendering videos, both of these pages are hosted on different parts of the website but under the same domain name. Which AWS component will be apt for your use case among the following? Alright, so this I think is an easy question, reason being we just discussed this, right? So the answer for this is application load balancer, reason being the kind of traffic which is coming is specific to its workload, and this can be differentiated easily by an application load balancer. Okay, so we are done with the resilient architecture questions. Now let's move on to the performance architecture domain, where we'll be discussing about how to about architectures which are performance driven, right? So let's take a look at the first question. So the first question says, you require the ability to analyze a customer's clickstream data on a website so they can do behavioral analysis. So your customer needs to know what sequence of pages and ads their customers clicked on. This data will be used in real time to modify the page layouts as customers click through the site to increase stickiness and advertise click-through, which option meets the requirement for captioning and analyzing this data. All right. So the options are Amazon SNS, AWS CloudTrail, AWS Kinesis, and AWS SES. So let's first start with the odd one out options, right? So we have Amazon SNS, which deals with notifications. So obviously, because we want we want to track user data, right? So SNS would not be the apt choice for it, because sending multiple notifications in a short amount of time would not be apt. Similarly, SAS would also not be the apt choice, because then we will be getting emails on basically the user behavior, and this would amount to a lot of emails. So hence it's not an appropriate solution, I think. Then we have AWS CloudTrail and AWS Kinesis. Actually, both these servers can do this work, but the keyword over here is real time, right? You want the data to be in real time. So since the data has to be in real time, you will choose AWS Kinesis. CloudTrail cannot pass on logs for real-time analysis. Kinesis is specially built for this particular purpose, and hence for this particular question, the answer will be AWS Kinesis. Moving on, then our next question is, you have a standby RDS instance. Will it be in the same availability zone as your primary RDS instance? Okay. So the options are, it's only true for Amazon Aurora and Oracle RDS. Second option is yes. Third option is only if configured at launch. And the fourth option is no. Alright, so the right answer for this, I want you to think about it like this, that whenever you want a standby RDS instance, it will only be there when your RDS instance stops working. Now, what could be the reasons that your RDS instance could stop working? Probably it could be a machine failure, or it could be a power failure at your at the place where your server has been launched. It can also be probably a natural calamity which would have struck your data center where your server exists. So all of these could be reasons which could lead to disruption in your RDS service, right? Now, if your standby RDS instance is also in the same availability zone as your primary, these conditions cannot be tackled, or these situations cannot be tackled. All right. So it is always logical to have your standby machines in some other place, right? So that even if there is a natural calamity or if there is a power failure, your instance is always up and ready. And because of that, AWS does not give you the option of launching your standby RDS instance in the same availability zone. It always has to be in another availability zones. And that's why the answer is no. Your RDS instance will not be in the same availability zone as your primary instance. All right. So our next question is, you have a web application running on 6 Amazon EC2 instances, consuming about 45% of resources on each instance. You are using autoscaling to make sure that 6 instances are running at all times. The number of requests this application processes is consistent and does not experience spikes. All right. So the application is critical to your business and you want high availability at all times. You want the load to be distributed evenly between all instances, and you also want to use the Amazon AMI for all instances. Which of the following architectural choices should you make? Alright, so this is a very interesting question. So basically, you want to run 6 Amazon EC2 instances, and they should be highly available in nature, and they would be using an AMI, of course, because they are autoscaled. So which among the following would you choose? So you have the options: deploy 6 EC2 instances in one availability zone and ELB, deploy 3 EC2 servers in one region and 3 in another region and use ELB. You should deploy 3 EC2 on one AZ, that is availability zone, and 3 in another availability zone. And you should deploy 2 EC2 instances in 3 regions and use an elastic load balancer. All right. Now, the correct answer for this would be C. The reason being that AMIs are not available across regions. Right? So if you have created an AMI in one region, it will not be automatically available in another region. You will have to do some changes and only then, or do some operations and only then it will be available in the another region. So this is reason number 1. So the region options mentioned over here get casted out because of this reason. Second, if you look at the first option, which says deploy 6 EC2 instances on one availability zone, that defeats the purpose of high availability. Because like I said, if there is any natural calamity or a power failure at a data center, then all your instances will be down. So it's always advisable to have your servers distributed. But since we have that limitation of using an AMI, and therefore and also the limitation that it is not accessible across regions, we would choose distributing our instances among availability zones. And I'd say we just had the option of 2 availability zones, right? It could be 3 availability zones, and we could deploy two servers in each, and this would also amount to high availability. All right. And of course, because you want to load balance traffic, if you apply an ELB on top of 3 availability zones, it will work like a charm. Regions, across regions, it can become a problem, right? And but in availability zones, it definitely works and it will work perfectly. All right. So the answer for this question is you would be deploying EC2 instances among multiple availability zones in the same region across an ELB. All right. So our next question is, why do we use Elastic Cache and in what cases? All right. So the answer for this is basically related to the nature of the service of Elastic Cache. So Elastic Cache, as the name suggests, is basically a cache which can be accessed faster than your normal application. For example, if you talk about...
Just a quick info, guys. Intellipaat provides online AWS certification training in partnership with Future Skills, mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
A database instance from which you are gathering information, right? If you're always dealing with the same kind of query, for example, you're always fetching the password for particular users, right? So if you're using an Elastic Cache, that data can be captured or can be cached inside Elastic Cache. And whenever a similar request comes in which is asking for that kind of data, your MySQL instance will not be disturbed. The data will directly be relayed from Elastic Cache, and that is the exact use of Elastic Cache, right? So you use Elastic Cache when you want to increase the performance of your systems, right? Or whenever you have frequent reads of the similar data. So if you have frequent reads of similar data, you'll probably be querying the same kind of data every time, and basically that will increase the load on your database instance. But to avoid that, you can basically introduce an Elastic Cache layer between your database and your front-end application, and that would not only increase the performance but also decrease the load on your database instance, right? So this was all about performant architectures, guys. Our next domain would deal with secure application and their architecture. So let's go ahead and start with the first question of this domain, which talks about a customer wants to track access to their Amazon simple storage service buckets and also use this information for their internal security and access audits. Which of the following will meet the customer requirement? So basically you want to just track access to the S3 buckets. Now if you want to track access, let's see what are the options. So you can enable CloudTrail to audit all Amazon S3 buckets. You can enable server access logging for all required Amazon S3 buckets. Enable the requester page option to track access via AWS billing, or you can enable AWS S3 event notifications for put and post. All right. So I would say the answer is A. And reason being, why is the answer not B? Because server access logging is actually not required when you want to deal with tracking access to the objects present in the S3 bucket. Requester pays option to access via AWS billing. Again, it's not required because there's a very simple feature of CloudTrail which is available to all the buckets across S3. So why not use that? And using notifications for S3 will not be apt. Reason being, there will be a lot of operations that would be happening. So rather than sending notifications for each and every operations, it is better that we log those operations so that whatever information we want out of that log, we can take, and rest we can ignore, right? So the answer for this is Amazon using AWS CloudTrail. Okay. Our next question is, imagine if you have to give access of AWS to a data scientist in your company. The data scientist basically requires access to S3 and Amazon EMR. How would you solve this problem from the given set of options? Okay, so you basically want to give a particular services access to an employee, and we want to know how would you do that. Okay. So the options are we should give him credentials for root. Second option being create a user in IAM with a managed policy of EMR and S3 together. Create a user in IAM with managed policies of EMR and S3 separately. Give him credentials for admin account and enable MFA for additional security. Okay, so a rule of thumb, guys, never give root credentials to anyone in your company. Even yourself, you should never use root credentials. Always create a user for yourself and access AWS through that user. All right. This was point number one. Second, whenever you want to give permissions to services or permissions of services to of particular services to people, you should always create or use policies that pre-exist in AWS, right? So when I say that, I basically mean never merge two policies. Okay, so for example, if you are using EMR and S3 together, that basically means that you create a policy that gives you the required access in one document. That is, in one document you mention the access for EMR, and in the same document you mention the access for S3 as well. Well, this is not suggested. Reason being, you have policies created by AWS, which are basically created and tested by AWS, so there is no chance of any leak in terms of security aspect. Second thing is, see, needs change, right? So if tomorrow your user says he doesn't want access for EMR anymore, he probably wants access for EC2. Right? So in that case, what will you do? If you had the policy in the same document, you would have to edit that document, correct? But if you created documents separately for each and every service, all you have to do is remove the document for EMR and add the document for the other service that he requires, probably EC2. You just add the document for EC2 and your S3 document will not be touched, right? So this is more easier to manage than to, writing everything in one document and editing the code later to give permissions of specific services that he requires now, right? So that is something that is not much manageable. So the answer for this is create a user in IAM with a managed policy of EMR and S3 separately. All right. Let's move on to the next question. So how would a system administrator add an additional layer of login security to a user's AWS management console? So this is a simple question. The answer for this is enable multi-factor authentication. So multi-factor authentication basically deals with rotating keys, that the keys are always rotating. So every 30 seconds, a new key is generated, and this key is required while you're logging in. So once you've entered your email and password, it will not straight away log you in. It will again give you a confirmation page for a code that you have to enter, which will be valid for those 30 seconds. Now this can be done using apps. So you have an app called, if you have an app from Google, you have apps from other third-party vendors as well, right? So these apps are basically compliant with your AWS, right? And you can use them to have access to the keys which are changed at every 30 seconds, all right? So it is better. If you want to enable multi-factor authentication, it is the best way of adding a security layer over the traditional username and password information that you enter. All right. So our next domain deals with cost optimized architectures. So let's discuss these questions as well. So our first question is, why is AWS more economical than traditional data centers for applications with varying compute workloads? All right, so let's read out the options. So we have Amazon Elastic Compute costs are billed on a monthly basis. Okay. Amazon EC2 costs are billed on an hourly basis, which is true. Amazon EC2 instances can be launched on demand when needed, true. Customers can permanently run enough instances to handle peak workloads. All right. So I'll say, because this question is talking about the economical value of AWS, option B and option C are correct. Reason being, you're charged according to the hour, and at the same time you can have them on demand. If you don't need them after 2 hours, just pay for 2 hours, and then you don't have to worry about where that server went, right? So this is very economical as compared to the fact that when you buy servers and their need finishes, say after 1 or 2 years, when their hardware gets outdated, so it becomes a bad investment on your part, right? And that is the reason AWS is very much economical in terms of Reason being that it charges you according to the hour, and also gives you the opportunity of using servers on the basis of on-demand pricing. All right. So this would be the answer. So option B and option C would be the right answer for this particular question. Moving further, our question says you're launching an instance under the free tier usage from EMI having a snapshot size of 50 GB. How will you launch the instance under free usage tier? So the answer for this question is pretty simple. It is not possible, right? You have a limit on how much of snapshot size you can use that would fall under the free tier. 50 GB is not the size, is basically a size which will not fall under the Amazon free tier rules, and hence this is not possible. All right. Our next question says your company runs a multi-tier web application. The web application does video processing. There are two types of users which access this service: premium users and free edition users. The SLA for the premium users for the video processing is fixed, while for the free users it is indefinite, that is a maximum time limit of 48 hours. How would you propose the architecture for this application, keeping in mind cost efficiency? Alright, so to rephrase this question, basically you have an application which has two kinds of traffic. One is free traffic and one is premium traffic. The premium traffic has an SLA that the task should be completed in 1 hour or 2 hours. The free traffic, they do not guarantee it when it will finish, and it has a maximum SLA of 48 hours. So if you were to optimize the architecture for this at the backend, how would you design the architecture that you get the maximum cost efficiency possible using this architecture? All right. So the way we can deal with it is there is a thing called spot instances in AWS, which basically deals with bidding. So you bid for AWS servers in the lowest price possible, and as long as the server prices are in the range that you specify, you have that instance for yourself. So all the free users who are coming to this website can be allotted to spot instances because there is no SLA. So even if the prices go high and the systems are not available, it does not matter, right? You can wait for the applications for processing if you're dealing with free users. But for premium users, since there is an SLA, you have to meet a particular deadline. I would say you use on-demand instances. They are a little expensive, but I think because premium users are paying for their membership, that should cover that part. And spot instances would be the cheapest option for people who are freeloaders or people who are coming free on your website, because they do not have any urgency of their work and hence can wait if required if the prices are too high for you. Alright, so our next domain will talk about operationally excellent architectures. So let's see what all questions are covered in this particular domain. Alright, so imagine that you have an AWS application which is monolithic in nature. So monolithic applications are basically which do not which have the whole code base in one single computer, right? So if that is the kind of application you're dealing with, it's called a monolithic application. Now this application requires 24/7 availability and can only be down for a maximum of 15 minutes. If had your application been not monolithic, I would say that there would be no downtime. But since it's a monolithic application, the question has mentioned, there is an expected downtime of 15 minutes. How will you ensure that the database hosted on your EBS volume is backed up? Now, since it's a monolithic application, even the database resides on the same server as that of the application. So the question is, how will you ensure that your database is backed up in case there is an outage?
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which one of the following is cloud platform by Amazon? A. Azure, B. AWS, C. Cloudera, D. All the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So for this answer, I'll say the answer is pretty easy. You can schedule EBS snapshots for your EC2 instance at particular intervals of time, and these snapshots would basically act as a backup to your database instances which have been deployed on EC2. So hence the answer is EBS instance snapshots. Alright. Our next question is, which component of AWS global infrastructure does AWS CloudFront use to ensure low latency delivery? Now, AWS CloudFront is basically a content delivery network, which basically means if you are in the US and the application that you're accessing has servers in India, it will probably cache the application in a US server so that you can access that application faster than to send traffic packets over to India and then receiving them back. All right. So this is how CloudFront works. It basically caches the application to your nearest server, and so that you get the maximum the minimum latency possible, and it is possible using AWS Edge locations. Okay, so edge locations are basically the servers that are located to near your place or near a particular availability zone, which basically cache the applications which are available in different regions or are at far places. We are going to discuss the top DevOps interview questions that can be asked to you in your next DevOps interview. Continuous development, and let's see what our first question is. So our first question asks us, can we explain the Git architecture? Now, this is fairly an important question, reason being, only if you understand the underlying basics of how Git works, will you be able to troubleshoot a problem when you face it and when you are working in a company as a DevOps engineer. All right. So let us try to explain what Git basically is and how its architecture is. Now, most of you might know that Git is a distributed version control system. Now, what is a distributed version control system? Let us explain it using a diagram. In a distributed version control system, basically your repository is distributed among the people who are contributing to that repository, and that is why it is called distributed. So that means that anyone who wants to make a change in the code that is present in this repository has to first copy this repository on his local system, commit the changes to the local file system of this repository, and only then he can push this repository onto push the code changes or the feature additions and everything to the remote repository, right? Nobody can work directly on the remote repository, and this is the main principle of how Git works, and that is the reason it is called a distributed version control system. Right? If you were to talk about the life cycle as to what are the steps to implement if somebody wants to say upload or change some code present in our remote repository. So the first thing that they have to do is pull the repository from the remote system. Once they have pulled the repository, it becomes their local repository. Change whatever files they want to change, and then once they have done with the changes, they will have to do a git commit, or they'll have to commit the files to the local repository. Once the files have been committed, they will have to be pushed to the remote repository so that it becomes visible to anyone and everyone who will pull this project the next time. All right. And this is how the whole Git architecture works. Now, I hope you guys understand what is the working of Git and what exactly is the architecture of Git. Moving forward, now let's talk about the next question, which says, in Git, how can you revert a commit that has already been pushed and made public? Right? So basically you have done some changes in the code, you committed those changes to your local repository, and now you have also pushed the changes to the GitHub repository. Now, if you have a CI/CD pipeline in place, which basically means that the moment you commit to Git, it automatically takes the code and deploys it on a server. If that is the kind of configuration that you have done, then probably the code that you have pushed has also been deployed on a server. And that is when you come to a sense that the code is wrong, and you quickly have to change the code so that everything becomes working again. Right? Now, this is a very hot fix, or this is a very quick fix that probably every DevOps engineer employs whenever there is a problem in the production server. Right? So what is that quick fix? The quick fix basically says that whatever last commit was working perfectly, just roll back to that so that everything becomes normal until and unless you have fixed the new commit. That is basically the intention behind the revert procedure. Now, how can you implement the revert procedure? It can be implemented using the git revert command, and let me show you a quick demo of the git revert command so you know how you can implement it in a computer. All right. So this is my terminal, guys. Basically, I will SSH into an AWS server and I'm in. So I have a GitHub repository that I have created for demo purposes. So like we discussed, the first stage in the lifecycle of Git is to clone the repository. So we'll just copy this address. So we'll just copy this address. 1 second. Yes. So we'll just copy this address and then we'll come here and we'll type git clone and then the address. Okay. Now this project is basically a website that I created. It's a small website that I created. Now, in order to see that website, we will have to paste this code inside our Apache folder. So let us go inside our Apache folder, which is present in this directory. All right. Now I'll do a quick git clone along with the repository address, hit enter. And now if I do an ls, you can see that there is a folder called DevOps IQ, which has been created inside this folder. I will go inside DevOps IQ and do an ls. And you can see there's one more folder called DevOps IQ. All right, so let's go inside that. And now if I do an ls, these are the two files which are present inside my code base. Okay. Now, if you were to see what this website actually looks like right now, I can just go here and I can type in the IP address. So it's 18.222.123.58/DevOps IQ and /DevOps IQ. All right. This is how the website looks like for now. Now I have to make some changes so that the background becomes a little more better. So what I can do, I'll just go back here. I'll go do a nano and change the code of the website and say I'll change it to, I have an image in the images folder. Let me change it to 1.jpg. All right, let us save it. And once you've saved it, the next thing that you have to do is commit the changes to your local repository. And let us do that. So first I'll have to add the files to the repository. Now I'll have to commit the changes. And the message should say changed background. All right. So the changes have been committed, and now I'll push these changes to the remote repository. So it's HSHAR and the password is this. Now before making these changes, let me quickly show you the code that you are currently going to see before I push anything on this repository. So can you see the code is images/2.jpeg. I've changed the code to be 1.jpeg. So let me hit enter and let's see if our code gets changed over here. So now if I do a refresh, let me do a refresh. You can see the code has been changed just now. So it says 44 seconds ago, the code was changed. Awesome. So now because my code has been changed, if I go to this website now and hit enter, you can see the background is now changed. It is now a different background. Now what I want to do is I realize that this change that I did is probably wrong, and I want to revert to a particular commit, to the older commit that was actually working. All right. So what I can do is I'll just come back to my terminal. Let me clear the screen. First thing that you do is do a git log. So now you get a log of all the commits that you have made to this particular repository. Now this is the particular commit that you have particularly applied right now, and this is causing you a problem. So just copy the commit ID for this, and now just go ahead and do a git revert. So git revert and then give this ID which you just copied. Okay, and hit enter. So once you do that, it will tell you the information about this particular commit ID, right? So just review everything, and then you can see that the commit has been reverted. So now I've not pushed the changes, but then if I come back here and if I hit enter, you can see the older website comes back because the code has now been changed. And if I want to make these changes to the remote repository as well, all I have to do is git push origin master, and it'll ask me the credentials, and the changes have been pushed. Right now, if I come here and I just see the code again, if I do a refresh, you can again see that the code has changed back to 2.jpeg, which was our earlier code which we made changes to. All right, so guys, this is how you can do a revert on a basically a commit and a push that you have made to your remote repository as well. Right, so if you encounter any problem during working while working as a DevOps engineer, you should remember this session where I taught you how to revert a particular commit. All right, so with that, let's move on to our next question, which says, have you ever encountered failed deployments and how have you handled them? Now see, any DevOps engineer in the world will have faced a problem in which, probably the things that he had planned, the things didn't go according to his plan. Right? That absolutely happens. And if somebody is asking you in a DevOps interview, have you committed mistakes? So you should, just to impress them, probably never say yes, right? So if you have never committed mistakes, that's awesome, right? But then I know that every engineer or every DevOps engineer who has worked in the industry would have faced a problem while working and would basically account to a mistake that he made while deploying things, all right? Now, the important thing or the important key takeaway from this kind of a learning should be that whatever mistake you make, you learn from it, right? And you never commit it again. And that is basically the intent behind this question as well. The interviewer would want to know, if you made the mistakes, what did you learn from those mistakes? Okay, so if an interviewer was supposed to ask me this question, I'll say, obviously I have encountered failed deployments, and what have I learned from them? I'll just give you the best practices that I think are viable for any DevOps engineer who is working in the industry. So the first thing that everyone should follow and should make it a thumb rule is that you should automate code testing. Not only does it save time, because now your tester does not have to wait for your developer to basically push the code and then check it. The developer can check it in real time because you have written a script for his application, and all the major tests which are to be done, which are pretty common, can be done using automated code testing. Right now, like I said, it's not only for time saving, but also it removes the part where a human error can occur. Right? So if you are working, when you work with people commit mistakes. But if you can write a code which will basically test each and every functionality, that code will never make a mistake. And that is why you should always automate things as far as possible. Right? So like in my example, what happened was that there was basically a commit to the repository, which was basically a feature addition, right? And the tester did not see all the functionalities, or forgot to see some of the functionalities that could impact the other components of my product. And because of that, when it got pushed onto production, basically disaster happened. Everything stopped working, right? And that was only because the testing did not happen properly, right? So for all the critical processes of your website or your product, you can basically create a code which will test that website, and basically that would basically close down most of the doors to mistakes. All right. The next thing is you should always use Docker for same environment, right? And this is basically the ideology behind DevOps, that these kind of problems where a developer used to work and the tester could not run his code on his computer, but the developer said that everything is working fine on his system. Docker basically solves that problem, right? So use Docker as much as you can for the same environment problem that you might face. then we should always use microservices. Now, when you are working in a company, it could be that the product is in the legacy phase and hence it's on a monolith kind of a thing, but you should never encourage this kind of an architecture, right? Reason being, say you did a bad commit or you did a bad push on the production server, but it should not impact the other components of your product, right? If probably you have done something to search, and if it's a bad commit or a bad push, the only functionality that should be impacted should be your search functionality and not the other functionalities. And that is the sole reason behind why we should use microservices. That is, we should divide our application into different small products which we would deploy on servers, and these products should be independent of each other. When you talk about the monolithic architecture, all these components are coinciding with each other, have the dependency upon each other. But when you talk about a microservices kind of an architecture, you remove that dependency so as to, even if one component fails, it does not impact the whole application. Fourth point being, you should always overcome risks to avoid failures. Now, this basically means that if there is a code change, or if there is a feature addition which works sometimes and sometimes it does not, and you're not able to figure out why is exactly that thing happening, it is better to wait and troubleshoot it than to push it just to meet your dates, right? Because the latter can cause you a big problem in production when you're in a company like probably like Airtel, or in a company like Samsung or Ericsson, where their products, each second of their website's uptime brings in money, right? So if your website is down for 30 seconds, that could amount to a huge loss, and that would be on you, right? So for you to not face that kind of a situation, always be 100% sure before you make a change or a release onto the production server. All right, so this is the end to the domain of continuous development. Let's go ahead and now talk about virtualization and containerization. All right, so let's start with the first question of this domain, which says, what is the difference between virtualization and containerization? Now, this is a very important question, guys, because most of us get confused between virtualization and containerization. So let's see what are the differences between these two things. So virtualization is nothing but installing a new piece of operating system on top of a virtualized hardware. What does that mean? So basically, there are softwares like hypervisor or any other software which specializes in virtualizing hardware. So if you have a server which has around 64 gigs of RAM and 1000 TB of hard disk space, with a software like hypervisor, what you can do is you can take that space and divide it among multiple operating systems, right? You can deploy multiple operating systems on the same hardware by virtualizing the hardware, so as to the operating system will feel that, say, if you virtualize 1 GB of RAM from this whole system and say around 100 GB of storage, the operating system will think that, it only has 1 GB and 1 GB of RAM and 100 GB of storage space available to it. It cannot go beyond that. Reason being, it does not know of the hardware which is beyond, or which is ahead of the hypervisor software. All right. So in virtualization, basically you have an hypervisor which sits on top of your operating system and virtualizes the hardware beneath it, right? Then you have a guest operating system. So basically, once you have virtualized the hardware, you install guest operating systems on top of that. For example, the best example for this would be VirtualBox, right? You install VirtualBox and then you can install operating systems on the VirtualBox with a given spec that you will decide, right? And once you have installed the guest operating systems, on top of that, there would be the binaries or the libraries that you probably would be downloading or that came with the operating system. And on top of that, you have the applications which would be running, right? So the key takeaway from virtualization should be that it's the whole operating system is installed from the kernel level to the application level. Everything is fresh, everything is new. Now let's talk about containerization. So the thing in containerization is that the host, on top of host operating system, you install a software called the container engine. Now the container engine is just like any other software, like you have an hypervisor, you have a container engine. Now the container engine does not encourage installing a whole operating system. For example, if you want to run a container for Ubuntu on, say, a Mac machine, you can do that, right? But it will basically, in that container, you will have basically the bare minimum libraries that amount to become the Ubuntu operating system minus the kernel, right? So in a container, you do not have a kernel. The kernel is always used of the host operating system. And this is the main difference between virtualization and containerization, that in virtualization, you have a separate kernel present of the virtual operating system. But in containerization, you do not have that. And that is the reason the containers are very small. They have the bare minimum libraries required for that container to behave as a particular operating system, but the container itself does not contain any operating system. It basically is based on the same kernel on which the host operating system resides. All right, and this is basically the main difference between virtualization and containerization. Moving forward, now the next question says, without using Docker, that is without using Docker to get into a container, can we see the processes that are running inside the container of the Docker container engine? All right. So this basically is relating to the same fact that if you want to see the processes of a container which are running inside the Docker container engine, if you can see them from the outside, basically that means that the processes are running in the same kernel of the host operating system, right? The processes that are running in the Docker container engine would be basically as an addition to whatever is running on the host operating system as well. And you can see that using the ps-aux command, right? So for the host operating system, it's just like any other software or any other process that it has to run. But for the container, it basically thinks that it is running inside an operating system, which it actually is not. Right? So can you see the processes? So the answer is yes, you can see the processes which are running inside a Docker container. And how can you see that? How can you basically see these processes? Let me demonstrate it to you. Okay, so we have come back to our AWS server. Let me clear the screen. All right, so if I do a Docker PS right now, you can see that there are no containers which are running on this system as of now. Now what I'll do is I'll run a container for Ubuntu. So I'll do a docker run -it and then -d and then Ubuntu. All right, so this ran a container for me. And if I do a Docker PS now, you can see that there's a container running, which is basically of the Ubuntu image. So if I go inside this container now, so I'll do a docker exec -it and then bash. Docker exec -it and then sorry, I forgot the container ID. So the container ID and then bash. So if I do that, I'm inside the container, right? And there's no process running inside this container as of now. Now, if I were to duplicate this, let me quickly again do an SSH. So I'll do an SSH into the same server again so that I'm on $. Okay, great. So if I do a ps-aux, these are all the processes which are running inside the operating system right now, right? But let us make it a little simpler. What we can do is, let me see all the processes which has the word watch in them, right? So let me make it more clear for you. So these are the processes which have the watch keyword inside of them. Okay, so there are basically 4 processes which are running and which have the keyword watch inside of them. Now what I'm gonna do is, inside this container, I'm gonna launch a watch process. So what is that watch process? That watch process is basically going to watch a particular command in a set interval of time. And what is that command? I basically want to say, let's see the ls-l command. Okay, so what is it doing? It is keeping a watch on the command ls-l in every 1 second, right? You can see the time over here. It is incrementing every second, and basically it's keeping a watch on all these files which are there inside the container continuously. Okay, now again, so this is the dollar prompt. That we are outside the container right now. Now if I again do the same command, that is again I search for processes which have the word watch in it, I can actually see that there is a new process which is running over here, and this process is running inside the container, which I'm able to see from the host operating system level, right? So the host operating system is basically treating this particular process as if it was running on its own system. That is, the container and the host operating system, because they are sharing the same kernel, the host operating system is taking this process as if it was running inside of it, right? But if we look closely, this watch command is running inside the container, right? Let me just quickly stop it. You can see we are still inside the container, and we have stopped the watch command. And if I go here and if I refresh, you can see that this watch command is again gone, which was being mentioned over here before. And this is exactly what we wanted. We basically wanted to see a process which was running inside a container from outside the container, that is from the host operating system, and that is exactly what we just did. All right. So the question that without using Docker, can you see the processes that are running inside a container? So the answer is yes, you can do it. All right. So the next question is, what is a Docker file used for? What do you basically use a Docker file for? So a Docker file is nothing but it's basically a text document to create an image using an older image and adding some files into it. All right. So it's basically like a script that you run in Linux, which can do all the things for you that are required. For example, I might need an Apache image, and I want my website to be put inside the var/www/html folder inside this particular Apache container. Now, in order to do that, if I were to do it without a Docker file, I would have to first download the Apache image. So I would probably type docker run -it-id and then Apache. Once I've done that, I will exec into the container and then go to the directory called var www.html. Probably I'll do a git clone of the website that I want, and then my website will be available in that container, and hence I'll be able to use it, right? This is one way. Second way is I can create a Docker file which will basically build this image for me without me having to do all these things, all these manual things which I just told you. All right. So let's see how we can do that. So let me just exit this container and let me remove the container which are just running inside my system right now. Okay, so if I do a docker ps now, it's clean. Now what I want to do is I want to run this particular container, docker run -it-p. I want to basically expose the port 83 to this container's port 80, and I want to run it as a daemon so that it runs in the background, and that is it. Okay, so I have the container running, which is this, and what I want to do is I want to basically copy the website into this container. So let me do a docker exec into this container -it. This is the container ID, and then container ID, and then bash. So I want to go inside this particular folder. So if I do an ls over here, you can see that there is an index.html and an index.php which are running, right? So it's exposed on port 83, which basically means if I go to a browser and if I go to the server's IP address on port 83, I should be able to see this Apache page, and this is basically the container which I just ran over here. Okay, what I want to do is inside this particular directory, I would be basically copying the code of my website. Now let's see how we can do that. So let me just exit this container. Let me do a docker ps. Let me do a docker stop to this particular container. So what would this do? So basically if my Apache was running over here, it should stop once I have stopped this container. Okay, so it is stopped. So if I do a refresh over here, you can see the site can't be reached. This is exactly what we want. Okay, now let me do a git clone of my GitHub. I'll do a git clone. All right. Awesome. Now I'll go inside this folder, and basically I want to copy this particular folder inside the container. All right. So for doing that, let's create a Docker file. And what I want to say is in the image shhar/web app, I want to add the folder DevOps IQ. And where do I want to add it? Inside the container, I want to add it in this particular directory. Okay. This is where I want to add it. And inside DevOps IQ. Okay, fair enough. And that is it. That is all you have to do. I'll just come out of this editor and I'll now do a Docker build of this Docker file with the name test. So it says successfully built an image and it has been tagged as test. Great. Now if I run this image now, docker run -it -p, say I run it on port 84, run it as a daemon and run the image. Okay, great. So if I go to port 84 now, let's see if the container is working first. So yes, the container is working. Now if I go inside DevOps IQ, what do I see? Great. So I can see the web. So basically my website is now available inside the container by simply writing a Docker file to do that. And this is exactly what we wanted. Awesome, guys. So what is the Docker file used for? It is basically used for creating an image without having to do all the manual stuff of adding your files and everything. All right. Now, once this image of yours is ready, you can push it to Docker Hub and anybody in the world can download it and can basically use your website on their local system. Great. Now, the next question is explain container orchestration. Okay, so till now we have seen that, we can deploy a container, we can use it, we can probably deploy an application on it, and we can use it on the web browser, right? But it is not that simple. When we talk about a website like Amazon or a website like Google, right? It has a lot of components with it. For example, on Amazon, you would see that you have a comment section. Then on the home page, you see that there are a lot of products which have the prices, the ratings. Now, each and every component, the prices, the ratings, the name of the product, the image of the product, the comment section, each and everything is basically a microservice.
Just a quick info, guys. Intellipaat provides online AWS certification training in partnership with Future Skills, mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
It is a small part of an application which is running independently of all the other parts of the website, right? And all of this is possible using containers. So basically what they would have done is they would have ran each and every component inside a container. Now, the problem over here is, now when you have a website like Amazon, you would be dealing like you would be dealing with minimum like 10 or 11 containers for one particular copy of that website or one particular instance of that website, right? Now when you're dealing with 10, 11 containers, these containers have to be working in conjunction to each other. They should be in sync with each other. They should be able to communicate with each other, right? And they should also be able to, we should also be able to scale a particular container in case it goes down. For example, the comment section container, it goes down for some reason.
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which one of the following cloud concepts is related to sharing and pooling the resources? A. Polymorphism. B. Virtualization. C. Abstraction. D. None of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Now, if it goes down, we have to keep a watch on it and we have to redeploy it if it goes down. And all of these activities, which I just told you, comes under container orchestration, right? If you were to manually deploy these containers on Docker, you will have to keep a manual check on all these containers. But imagine when you have thousands or 10,000s of containers that you're dealing with, in those kind of scenarios, you need container orchestration. Now, container orchestration can be done using various softwares. So you have a software called Kubernetes, and before that there was a software called Docker Swarm, which basically made our life easier by doing all the manual work for us. That is, it will check the container's health. It could scale them in case they become unhealthy. They could always also notify the administrators by an email in case something happens, right? They can also run a monitoring software for you, which basically gives you a report or the health status of all the containers which are running inside that software. So this is a very small part of what a container orchestration tool can do, right? And basically, if you were to understand what container orchestration is like I said, when you work with multiple containers, you have to take in note a lot of things, and that is possible using the container orchestration tools like Kubernetes and Docker Swarm. Okay, so the next question is, what is the difference between Docker Swarm and Kubernetes? Now, they're both container orchestration tools. We just saw that. But why do we have two? Or if I were to choose between Kubernetes and Docker Swarm, which should I choose? All right, so let's look at the differences between each one of them. So the first difference, which is probably the most important difference, or probably I'll say is the deciding factor whether you should go ahead with this tool given that you have a short deadline and you have to deploy a project. So installing Docker Swarm is very easy. It comes pre-packaged with the Docker software. So if you have installed Docker Swarm is already installed on your system. You don't have to worry about anything. On the other hand, installing Kubernetes is a very tough job, right? There are a lot of dependencies for Kubernetes. You'll have to see the system. You'll have to see the operating system on which it is running and a host of other things, right? It has a lot of dependencies and hence it is very tough to install. But the moment you install it, it becomes very helpful. That is, Kubernetes becomes very helpful because of the features that it offers, which brings us to our second point. Docker Swarm is faster than Kubernetes, reason being that it has less features than Kubernetes and therefore making it a very light software and hence faster than Kubernetes. So if you want to use Docker Swarm, you should be reading about what Docker Swarm does not offer and what Kubernetes offers. And if you feel you do not need all the features that Kubernetes is offering, you can go ahead with Docker Swarm and deploy your application in a faster manner. But like I said, Kubernetes is complex and it has a lot of services and features, because of which its deployments are a little slower when we compare it to Docker Swarm. The third point, which is the most important point, is Docker Swarm does not give you the functionality of autoscaling. Meaning if your containers go down or if your containers are basically performing at their peak capacity, there is no option in Docker Swarm to scale those containers. On the other hand, because of Kubernetes monitoring services and the host of other features, you have that option of providing auto scaling to your containers, which basically means you can automatically scale your containers up and down as and when they are required. And this is an amazing thing that Kubernetes handles for us. Alright guys, so these were the questions around the domain virtualization and containerization. So moving ahead, now our next domain is continuous integration. So let's shed a light on what continuous integration is. So our first question itself is, what is continuous integration? So continuous integration is basically a development practice, or I'll say it's a stage which basically connects all the other stages of the DevOps lifecycle. For example, you push your code to Git. Like we took that example, when you push the code to Git, you might have provisions which might allow you that the moment the code is pushed onto the remote repository, it automatically gets deployed on the servers as well. Well, if that is the case, basically that would be possible using integration tools that would integrate your Git repository with your remote server. And that is exactly what Jenkins runs. It's a continuous integration tool which helps us integrate different DevOps lifecycle stages together so that they work like an organism, right? This is what continuous integration means. So, because we discussed about what continuous integration is, our next question says, create a CI/CD pipeline using Git and Jenkins to deploy a website on every commit on the main branch. So on every push that you make to the remote repository, the code should automatically get deployed on a remote server. All right. So this is something that we're going to do just now. All right. But before going ahead, let's see what is the architecture for this kind of a thing. All right. So this is how the whole thing is going to work. Basically, the developer is going to commit the code to his GitHub. GitHub basically, once it sees a change in the branch that we mentioned, it is going to trigger Jenkins, which in turn will integrate or will take the website from the GitHub repository and push it onto the build server on which we want the website to be deployed. All right. Sounds awesome. Great. Now let's go ahead and do this demo. So for that, we will have to SSH into our server. So let us do that. Okay, so I'm in now. Let me clear the screen. So first let's check if our Jenkins is running on this server. So let me check the status for Jenkins. So if I do a service Jenkins status, I can see that the Jenkins service is active. Awesome. So I'll just go here and I'll go to the Jenkins website, which is basically available on AT80. All right. So I'll enter my credentials. And this is how the dashboard for Jenkins looks like. Now our question is, or our aim is to create a job which basically will push a website that we are uploading to GitHub on a particular server. All right, so let's create a new job first. So let's call our job as a demo job. Okay, and let's name it as a freestyle project and click OK. So this will create a job in Jenkins for us. All right, so our job has now been created. So what we want to do is I want to take code from my GitHub. So I'll have to specify the GitHub repository over here. Okay. And similarly, I'll have to say that I want to trigger the build the moment anything is pushed on my remote repository. All right, and this should be it. Great. So I mentioned that anything that is pushed onto my master should trigger a build on Jenkins. Okay, and what should this build, or what set of commands do I want to run once build is triggered? So first I want to remove all the containers which are running inside my system. So I want to clean up, right? So for that I'll say sudo docker rm-f, then a $. This basically is going to clean all the containers which are running currently in the system. Once this is done, I want to build my website, which is going, or build my container, which is going to have my website. All right, now how can we do that? For that, I'll have to push the code to my GitHub, which will have the Docker file as well. Okay, so we created a Docker file inside. Okay, so here it is. So we have our Docker file created in the DevOps IQ folder, which was there in my home directory. Now what I want to do is I want to push. So what is there inside this Docker file? We saw that we could create a Docker file using, if we write something like this in our Docker file, and this would basically create an image with our code which is there on GitHub. All right. So what we'll do, we'll just push this code to our remote repository. And let's add the message that we have ordered a Docker file. Great. And now let's push it to our remote repo. Great. So it has been pushed to my remote repo. And now if I just go here and check if my changes have been done or not, let me just quickly refresh it. So yes, I have a Docker file in my Git repository right now, which was committed 42 seconds ago. Awesome. Great. So now what I'll do is I'll come to my Jenkins and I will say that build sudo docker build the Docker file. Now where is that Docker file? The Docker file will basically be downloaded in the Jenkins workspace. So that is in var lib Jenkins workspace, and then the name of the job, which is demo job, and that is it. So inside this I will have my Docker file, and it will basically build it and name it as, say, Jenkins. It'll name it as Jenkins. In the next step, what I'll do a sudo docker run -it and then -p and say I want to deploy it on 84 or say 87 port. Okay, and what do I want to deploy? I want to deploy Jenkins. Okay, so this should do this should basically do all the stuff. So in the first command, basically we're removing any container which is running on the system. In the second command, what we're going to do is we're going to build the Docker file which is available in this workspace, and this workspace will basically have my GitHub project and the link I have specified over here. So it'll basically just copy, or it'll pull the project and save it in the workspace of demo job. So in this demo job, there's a Docker file. So we are building this Docker file and we are naming this created image as Jenkins. And then we are running this image and exposing it to port 87. Okay, so let's save it. Awesome. Now what we have to do is I'll have to go inside. So if you want to configure a webhook, the way to do that, when I say a webhook, basically you want your GitHub to interact with your Jenkins whenever there is a push to a particular repository. So in your repository, go to settings and then go to webhooks. So this is a webhook that I created for my Jenkins, right? So let me create it again for you. So all you have to do is click on add webhook, right? And enter the URL for your Jenkins over here. So in my case, it is this. I'll just enter it over here, followed by this keyword, which is GitHub-webhook. And that is it. Once you specify that, just go down, click on add webhook. And this should basically send a request to Jenkins. And if everything goes well, it will say last delivery was successful. Okay. So any changes that I make to my GitHub now should trigger a change over here. Now let me delete this job, because I think even this job gets triggered when my GitHub, any changes made to my GitHub, right? So let me delete this project. Okay, great. So I just have this job now. Awesome. Now let us see how it actually works. So what I want to do is I'll come back to my terminal, do an ls, and let me go inside DevOps IQ and let me do some changes in the code. So let's say I go into nanoindex.html. So the first thing that I do is I change the title of the website. So I call it as Jenkins test website. Okay. And I change the image from 2 to 1.jpg, and that is it. Let us see if I just push, or if I just push this website onto my server, what will happen. So I'll do a git push. Sorry, first I'll have to add these changed files into my repository. Git push origin master, sorry, git commit, and let me label this commit as test push. Okay, done. Now let's push this to a remote repository. Git push origin master, and let's give the credentials. Awesome. Now if you wait here, it should basically start a job. So as you can see, there is a job queued, which is for demo job, and this got automatically triggered by my GitHub. Okay, so let me refresh this. Okay, so the moment it gives you a red, that basically means that your job has been failed. So let's see what had just happened, why our job got failed. So if you go here, you can see the console output just like this. Okay, so basically we forgot to add a sudo here, and that is causing us a problem. Okay, so we can fix this by just going down and adding a sudo here. Save it, and again we'll have to change the code. Let's call it as Jenkins test 2 website. We'll do a control X, Y, and now let's add our files to our local repository. Git add. Now let's commit it. test push 2, and now let's push this to our master. I'll enter the credentials, and this should be it. Okay, so let's see. So our second job got triggered automatically, and it gives us a blue. Now blue means that your job was executed successfully. So let's check what happened. So we were deploying it on port 85. So let's check if it has been indeed deployed. So it was on port 85 and the folder was DevOps IQ. Okay, so let's check. I'm not sure if it was port 85. Let's check. What are the port that we have specified? So the port is 87. Okay, so let's go to port 87. Okay, so it's giving an error saying unsafe port. So for our troubleshooting, let's check if the container is running. So yes, the container is running on port 87, but it says an unsafe port. So what we can do is let us change it to say 82. And now let's just try to build the job from here. We'll just click on build now. Job has been completed and the port was 82. Yes, so Apache is working. Now let's try going inside DevOps IQ folder. And there you go. You have your website with this title which you pushed on GitHub. Now for one more time for testing purposes, let us push our code once more and see what happens. So I'll say that this website is test3 website, and say I'll change the image as well to 2.jpeg. Okay, save it, do a git add, do a commit, and say call it test push 3, and now let's git push origin master. Enter the credentials. Great. Now let's check what will happen. Okay, so our build has been started and it has been completed. Great. So if I refresh this now, it says Jenkins test 3 website, and the background also has been changed. So congratulations guys, we have successfully completed the demo. So basically if you change anything in your GitHub, the website is automatically getting deployed on your build server, right? And on top of this, just for making it more interesting, what we can do is we can do a git log and we can revert on this commit that we saw earlier. Okay, so let's do a git revert and then paste it, agree to everything, and then push to master. Enter the credentials. Everything has been pushed. Job is getting triggered.
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which one of the following is cloud platform by Amazon? A. Azure, B. AWS, C. Cloudera, D. All the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Job is completed, and if I go here again, my website got reverted to a particular previous version. Awesome, guys. So we have completed the demo, which basically asked us to create a CI/CD pipeline using Git and Jenkins to deploy a website on every commit on the main branch. So we have done it successfully. Awesome. Let's move on to our next domain, which talks about configuration management and continuous monitoring. Awesome. So what is configuration management and what is continuous monitoring? Let's understand it. So what is the difference between Ansible, Chef, and Puppet? Now, before understanding the difference between Ansible, Chef, and Puppet, these are basically configuration management tools. What is configuration management? If you have, say, around 200 servers and you want to install a particular software on each of these servers, what will you do? One way what you can do is you can basically go to each and every of these servers, run a script, and that basically will install software on that on these servers, right? The other way to do it is install a configuration management software using which you can deploy or you can install all these softwares, or you can control the configuration of all these servers from one central place. And that is exactly what configuration management means, right? Now, in configuration management, you have many tools like Ansible, Chef, Puppet, etc. But these are the three top tools which are used in the industry. Now, the question is, what is the difference between Ansible, Chef, and Puppet? All right, so let's go ahead and see the differences. All right, so let's first talk about Ansible. So Ansible is very easy to learn because it is based on Python. So you don't have to sweat a lot, or you don't have to sweat much on learning the commands for Ansible because it is based on Python. So if you know Python, Ansible is going to be a cakewalk for you. It is preferred for environments which are designed to scale rapidly. Basically, with Ansible, the thing is that you don't have to install the Ansible client software on the systems on which you want to basically deploy the configuration. Ansible just has to be installed on the master, and that is it. No other configuration required. You can directly control the configuration of the client server given you have the access to it. So it offers simplified orchestration, reason being, like I just told you, that you don't have to worry about installing softwares on the client machines. Ansible can standalone take care of all the complications that come forward when you are dealing with deploying configurations without installing a particular software on the client machines. But this is basically a disadvantage of Ansible, that it has a very underdeveloped GUI. That is, you only get the CLI to work with, right? And it has very limited features when we compare it with Puppet and Chef. Now let's talk about Chef. How is Chef different from Ansible? So it is Ruby based and hence it's difficult to learn. Now Ruby is a language that not many people are acquainted with, and hence people might find it difficult to get versed with the commands of Chef. The initial setup is complicated. When I compare it with Ansible, the setup was very easy because I just had to install Ansible on the host machine, and on the client machine I didn't have to install any software. So, but with Chef you have to do that, and hence it becomes a little complicated. But once all the setup and everything is done, Chef is very stable, right? It has been, since it's a community product and it has been well contributed to, it's a very stable product and it offers you resiliency. So of course, when you're working on production servers, probably working on Chef would be a better idea than Ansible, because Ansible does not have that great community when you compare it with Chef. And of course, Chef is the most flexible solutions for OS and middleware management. Now, middleware basically means the software management part. Chef offers to be a great choice for configuration management. Reason being, it is very reliable and is very mature, because it was probably among the first configuration management tools to come out. And because community has contributed a lot to this project, it is very mature in its development stages as well. Now let's talk about Puppet. So Puppet can be tough for people who are beginners in the DevOps world, right? Because it uses its own language called Puppet DSL, right? The setup part is smooth when you compare it with Chef, but it's a little harder than Ansible, because when you're using Puppet, we use a master and an agent as well. So you will have to install Puppet agent on the client machine, and only then Puppet will be able to interact with the client software, right? Now it has a strong support for automation. So if you're planning to do some configuration management that you want to automate, Puppet is very compliant in that part. You can easily do the automation part using Puppet, and it is not suitable for scaling any deployment. So if you have say around 50 or 60 servers and you plan to add more in the future, probably Puppet would not be the right choice for that kind of an architecture. It is good to have when you have a stable infrastructure where you're probably not adding servers now and then. But if you are working on cloud and you do not know the capacity that you would be running, probably Puppet would not be a good idea to manage your configuration on your clients. Okay. Our next question is, what is the difference between asset management and configuration management? So asset management basically deals with resources. It deals with hardware, which we'll have to plan so that our IT workforce can work with maximum efficiency, right? So we'll have to plan the planning of your hardware, of how many resources a particular team might need. Giving the right resources to the right people is what asset management counts in. When we talk about configuration management, it basically employs not the hardware but the software component of what all softwares are required by a particular employee of a team or a particular person in the team. What softwares are required by that person, and for other person what software is required. I mean, rather than taking the radical approach of installing every software in every machine, which should not be done because some softwares are licensed. So configuration management basically means installing the right software on the right system on which a particular person or on which a particular workload is going to run. So our next question is, what are NRPE plugins in Nagios? Okay, so NRPE plugins are basically extensions to Nagios which help you monitor the local resources of the client machines, right? So you don't have to SSH into the client machines to see how much of memory or how much of CPU is being used. Nagios being a monitoring tool, you just have to install the NRPE extension on the client machine, and it will give you a real-time data of the resources that are being consumed on that particular client machine. And obviously, when you're working in production environment, you will be monitoring multiple machines, and with NRPE plugins installed on each of those machines, you can easily monitor the resources of them at one central place. And that is exactly what NRPE plugin is. Our next question is, what is the difference between an active check and a passive check in Nagios? Okay, so in Nagios, if the data, the monitoring log that you're getting from your clients, if it's being delivered by a Nagios agent, in that case, it is called an active check. Reason being, Nagios is actively involved in taking all the data or in collecting all the data from your clients. But in case when you're dealing with systems wherein it does not allow you to install any other software, or probably the software itself can generate monitoring logs, in those cases what happens is rather than Nagios, the software component pushes the logs to the Nagios master, where it can take the logs and probably create a graph or create the metric for you in the dashboard. So basically, using those logs which are being published by some other software, Nagios will create a report of the health monitoring part of your client systems, right? And that is why it is called a passive check. Reason being, Nagios is not involved on the client side at all. It is basically the software's own services which are basically pushing the log to Nagios master, and hence it's called a passive check. All right, but if you talk about the architecture or the working or the life cycle of how this actually works, between on the master itself, the logs which are published are actually published to a queue, right? And whether it's an active check or a passive check, the logs have to be published to that queue so that the Nagios master can pick them up and create the monitoring metric which is required. All right, so in a passive check and in an active check, the queue is going to be there, but it's the only difference between the agents. That is, in an active check, the Nagios agents are involved, but in a passive check, third-party software tools are involved which publish the log to the Nagios master. All right, so our next question says create an Ansible playbook to deploy Apache on a client server. So basically we have to do configuration management. So as to without, going inside the client system, we'll have to install a particular piece of software inside it. Okay, so let me quickly do an SSH into my AWS machine. And what I'm gonna do is I have a slave machine which I've already configured, which can interact with my master. That is, if I do a Ansible ping all, you can see that there is a server 1 that I have configured, which has successfully responded to my master's request. Okay, now let me show you the server, which is basically working. So this is the server which is configured with my master, right? This is my client machine, and on this machine I'll have to install Apache. So if I right now go to the IP address of this machine, it says connection refused. Reason being that there is nothing installed on this server, or there is no Apache software installed on this particular server right now. All right, so let's install Apache. Now to do that, you will have to write a playbook. Now what is a playbook? A playbook looks something like this. So it's basically a YAML file that you'll have to create. So I have created one for me. So where do you want to install the Apache software is the part where you'll have to specify in hosts. So basically my client machine is a part of a group called servers that I've created, right? So the hosts are servers, and where can you actually specify what part is your machine, or which group is your machine a part of? So that you can specify over here. So it's in /etc/ansible and /hosts. Okay, so as you can see over here, this is the group name, that is servers, and inside servers I've specified a server 1 client machine which has the IP address this. So this is the IP address of my slave. So if you can compare, it's 18.223.101.172, and if I compare it with my slave, this is the IP address of my slave, right? And this has been configured over here. So I can refer to my server 1 as servers, or I can refer it to as server 1, right? So if I do, let me do a clear over here, I can say Ansible -m ping, and I can say server 1 as well. It will reach out to my server 1, or I can say servers as well, because it's part of the group servers. Okay, so this is how it works. Now I want to install Apache. So for installing Apache, I'll have to write a playbook which looks like this. Basically it's a YAML file. So you start with the 3 dashed lines, and then you specify hosts. So hosts, I've specified every server, every machine which is inside the servers group should install Apache on it, right? And what is the task? I want to install Apache 2. This is basically a name. You can specify anything over here. Then I've specified APT. Basically, I want to use the APT package to install Apache 2, the latest software. Okay. Now, what I will do, I will type in Ansible -playbook and I'll type in apache.yaml. I'll hit enter, and now it has started to install everything. So it is installing on the servers group. It is gathering the facts, and it saw that it is able to communicate with server 1, and now it is accomplishing the task of installing Apache. All right, so it has been done successfully. So if I go to my Chrome browser now, and if I refresh the address, you can see that Apache is installed on this server automatically. So I didn't have to basically SSH into the server. It all happened automatically. And if I had like 5-6 computers which were running on AWS, and if I wanted to install the software on it using Apache, using Ansible, this would have been the same way. It's only that in the server group, I would have specified more IP addresses which my Ansible could talk to. Okay, so this was our task of basically deploying an Ansible playbook on a client server without SSH, doing an SSH into that client server and doing it from a central location. All right, so this is done. Now let's move on to our next domain, which is continuous testing. Now, what is continuous testing? So we talked about continuous development, which is done using GitHub. We talked about continuous integration, which is possible using Jenkins. We talked about continuous configuration management, which can be done using Ansible. And next online is we have continuous testing. So once the code has been deployed, it has been integrated with Jenkins, it has been deployed on a server. The next thing is automated testing that we discussed in the best practices before, right? And it can be done using a tool called Selenium, a software called Selenium WebDriver, right? So the first question is, list out the technical challenges with Selenium. So the Selenium tool is used widely for automatic testing or automated testing, but what are the problems that you get with Selenium? So if you're using Selenium, mobile testing cannot be done. So if you have developed an application for your mobile, you cannot test it using Selenium. The reporting capabilities of Selenium are very limited. If your application or your web application deals with pop-up windows or it gives pop-up windows, Selenium would not be able to recognize those pop-up windows and work on them. And again, Selenium is only limited to web applications. So if you have an application that probably runs on desktop, probably it's a software that you have designed, you cannot test that software using Selenium. Selenium is only for those applications which can run inside a browser. And if you want to check whether there is some image in your web page and that image should have some particular content, it is a little difficult to implement it in Selenium. Although it is not impossible, it is possible. You'll have to import some libraries and other things like that. But natively, Selenium does not support image testing. You'll have to work around. You'll have to work around with Selenium to import some libraries which could do it for you. But like I said, natively Selenium does not support image testing. So our next question is, what is the difference between verify and assert commands? So let us see the differences. So if you're using assert in Selenium, if the command fails, the whole execution comes to a halt. Whereas in verify, it does not come to a halt. It keeps on continuing the rest of the lines which are written in the code. Now, how can it be helpful? How is it helpful to basically put execution at halt whenever there is an error which occurs for a particular line? It is helpful when you're dealing with critical cases. Like for example, if there are 5 cases and say if case 3 fails, case 4 and 5 cannot execute because they have a dependency on case 3. In those cases, I would say that you would have to use assert with the case 3. But in the same example, if you talk about case 1 and case 2, they do not have a dependency or they do not create a dependency for any other test cases that have to run, right? For example, case 3, case 4, case 5 are not dependent on case 1 and case 2. In those cases, we can run the verify command, which will not stop even if the test case fails, right? And this basically is done to basically see what all is working and what all is not in one shot in a testing program. And for those cases, you would use verify. But in the cases where you are testing critical cases and you do not want to waste your time testing other things, if one of your case fails, in those cases, you will use the assert test. So like I said, it is used to validate critical functionality, assert command, and verify is used to validate functionality which is of the normal behavior kind of scenario, which comes into the normal behavior. That is, it does not create a dependency for other things to not work because it stopped working. All right. So our next question is, what is the difference between set speed and sleep methods? So set speed is basically used for executing tasks at a particular interval that we specify. For example, say I want to echo hello world at intervals of 5 seconds. In that case, I can specify it using set speed. But sleep method basically suspends the execution of the whole program for a particular interval. For example, if you're doing a Selenium web test and the web page takes around 3 seconds to load, and you don't want testing to happen just after each line, you can specify a sleep method of say around 3 seconds, where it waits for 3 seconds for the website to load, and only then it will start executing the tests which follow that particular line. All right. So this is the difference between set speed and sleep.
Just a quick info, guys. Intellipaat provides online AWS certification training in partnership with Future Skills, mentored by industry experts. The course link is given in the description below. So guys, we have come to the end of the session. Hope you all enjoyed it. If you have any doubts, please put down in the comment section below. We will try to answer it as soon as possible. Thanks for watching.